Welcome to Part 2, The Crisis and Judgment.
Welcome back. When a hiring manager at Amazon, Google, or Meta asks you about your biggest failure, they are not looking for a cute story about a missed meeting. They want to know what you do when a database drops, when a multi-million-dollar project is going to miss its deadline, or when you face an impossible ethical dilemma. They are testing your emotional resilience and your systemic thinking under extreme stress.
Part 1 recap. You have mastered influence.
In Part 1, you have just completed the first half of the FAANG Behavioral Masterclass. We have covered leadership, teamwork, communication, impact, initiative, and customer focus. If you have mastered these frameworks, you now know how to prove to an interviewer that you can guide teams and deliver massive business value without relying on a formal title. In case if you missed Part 1, the link to Part 1 is the first thing in the description below.
Transition from influence to survival.
But delivering results when things go well is only half the interview. In Part 2, we tackle the hardest, most grueling part of the FAANG loop, the crisis and judgment round. We are moving from the light into the dark side of engineering leadership.
Welcome to Part 2, The Crisis and Judgment.
In Part 1 of this behavioral masterclass, we covered how to lead, collaborate, and drive impact. If you missed Part 1, the link is in the description. But today, we are entering the dark side of engineering leadership. We are talking about failure, immense pressure, total ambiguity, and ethical dilemmas.
Why this round is the ultimate filter.
When a hiring manager at Amazon, Google, or Meta asks you about your biggest failure, they are not looking for a cute story about a missed meeting. They want to know what you do when a database drops, when a multi-million-dollar project is going to miss its deadline, or when a stakeholder lies. They are testing your emotional intelligence, your resilience, and your systemic thinking.
The 53 questions we will conquer in this video.
In this video, we will apply our FAANG-optimized STAR+L framework to the final 7 categories of the behavioral loop. Category 7, Failure and Mistakes, 10 high-stakes scenarios. Category 8, Problem Solving Under Fire, 11 scenarios. Category 9, Navigating Ambiguity, 8 scenarios. Category 10, Pressure and Deadlines, 5 scenarios. Category 11, Learning and Growth, 7 scenarios. Category 12, Ethical Judgment and Integrity, 5 scenarios. Category 13, Self-Reflection and Motivation, 7 scenarios. Prepare to defend your worst moments like a true architect. Let's begin with Category 7, Failure and Mistakes.
Category 7, Failure and Mistakes.
This is the most dangerous category in the senior loop. Interviewers at companies like Amazon and Google are not looking for safe mistakes or fake weaknesses. They want to see how you handle catastrophic failure, whether you take absolute ownership, and how you extract systemic improvements from a disaster. At the staff and principal level, your ability to lead a blameless postmortem for a major outage is the ultimate sign of engineering maturity.
Failure and Mistakes Masterclass Scenarios.
These 10 scenarios test your ego, your resilience, and your ability to lead through crisis. 52. Tell me about your biggest professional failure. 53. Tell me about a mistake you made. 54. Tell me about a time you made a wrong decision. 55. Describe a project that did not go as planned. 56. Tell me about a time you missed a deadline. 57. Tell me about a time you had to admit you were wrong. 58. Tell me about a time you failed to meet expectations. 59. What would you do differently if you could redo a project? 60. Tell me about a decision you later realized was wrong. 61. Tell me about a time when you underestimated the complexity of a task. If you have not failed at scale, you have not built at scale. Own your scars. Question 52. Tell me about your biggest professional failure. Note, interviewers ask this question to evaluate ownership, engineering judgment, and ego. At companies like Amazon, Google, and Netflix, engineers are trusted with massive production systems. Interviewers want to see if you possess the courage to admit a costly mistake and the systemic thinking to ensure it never happens again.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to detect candidates who lack accountability or maturity. Avoid these traps. 1. The not really a failure trap, describing a minor inconvenience. For example, I missed a minor bug in a PR instead of a meaningful, painful mistake. 2. The blame broadcast, shifting the ultimate responsibility to QA, product managers, or legacy systems instead of owning your architectural choice. 3. The hero failure. Framing a failure as a positive, for example, I worked too hard and burned out. Interviewers hate this. 4. The technical excuse, explaining the failure purely as a system glitch without acknowledging the human decision that allowed the glitch to reach production. 5. The no systemic learning, ending the story with an apology, but failing to demonstrate how you rebuilt the system to prevent recurrence.
Here are the signals the interviewer is scoring.
While you answer this question, interviewers evaluate these 5 maturity signals. 1. Extreme ownership. Did the candidate clearly and uncomfortably accept responsibility for the blast radius? 2. Technical depth. Was the failure rooted in a complex, realistic distributed systems decision? 3. Crisis mitigation. Did they act decisively to stop the bleeding during the incident? 4. Transparency. Did they hide the failure, or did they communicate openly with stakeholders? 5. Systemic learning. Did they introduce automated structural safeguards, not just process, to prevent recurrence? Elite engineers are not judged by their lack of failures, but by the quality of their recoveries.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation. Early in my career as a backend lead, our checkout service was suffering from high latency due to heavy read volume on our pricing and inventory database. Task. I architected and deployed an aggressive Redis caching layer to sit in front of the database, aiming to drop latency by 80%. Action. I implemented a time-to-live TTL-based invalidation strategy. I deployed it, and latency dropped beautifully. However, I completely underestimated the volatility of flash sale pricing. During a major promotional event, the cache served stale, heavily discounted prices for 45 minutes because the TTL had not expired. Result: by the time I triggered the emergency rollback, the system had processed over 2,000 orders at the wrong price, resulting in a $40,000 revenue hit. It was entirely my fault for choosing TTL over event-driven invalidation. Learning plus L. I learned that eventual consistency is unacceptable for financial data. I led the post-mortem and completely re-architected the caching tier to use change data capture, CDC, via Debezium, ensuring the cache was invalidated at the database transaction level rather than relying on application-level guessing. The plus L transforms a $40,000 mistake into a permanent, enterprise-grade data consistency framework.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates extreme accountability. 1. Ownership matched. You explicitly stated it was entirely my fault and named the dollar amount of the damage. 2. Technical depth matched. You highlighted the classic distributed systems trap of cache invalidation and TTLs. 3. Crisis mitigation matched. You executed an emergency rollback to stop the financial bleeding. 4. Transparency matched. You did not hide the financial impact. You used it to highlight the severity of the lesson. 5. Systemic learning matched. You replaced a flawed application logic approach with a robust, infrastructure-level CDC pattern. This demonstrates vulnerability combined with elite technical remediation.
Follow-up 1. Clarification probe. Why did not your testing catch the stale data issue before deployment?
Answer: our load tests validated the cache's performance throughput, but our integration tests did not simulate the exact cadence of high-frequency production updates. In staging, prices rarely changed, so the invalidation logic appeared flawless. My failure was testing the speed of the cache without rigorously testing the staleness boundaries.
Follow-up 2. Level 3 or Level 4 junior depth. How exactly did the change data capture, CDC, fix the problem?
Answer: CDC reads the actual transaction log of the primary database. Instead of the application trying to remember to delete a cache key when it updates a price, the database itself emits an event the millisecond a row changes. A background worker consumes that event and instantly drops the Redis key. It removed human error from the invalidation process entirely.
Follow-up 3. Level 5 or Level 6 senior depth. What did you do to rebuild trust with the business stakeholders after costing them $40,000?
Answer: I owned the narrative immediately. I did not wait for them to come to me. I drafted a blameless post-mortem document, walked into the meeting with the product VP and said, "Here is exactly how I broke the system. Here is the exact dollar impact." And here is the architectural shift we are making so this class of error is mathematically impossible in the future. Executives forgive mistakes. They do not forgive cover-ups or repeated errors.
Follow-up 4 Curveball. What if, during the incident, the rollback script failed and you could not detach the cache?
Answer: if the graceful rollback failed, I would employ a circuit breaker or feature flag override to forcefully bypass the cache layer in the application code. If that was not available, my last resort would be to poison or flush the entire Redis cluster manually, forcing all traffic to fall back to the primary database. It would cause massive latency and potential timeouts, but protecting data correctness and financial integrity always overrides system performance.
Leadership Pro Tip: Own the blood.
When asked about a failure, many candidates try to soften the blow by picking a story where nobody really got hurt. This is a mistake. FAANG interviewers want to see your scars. The more painful and expensive the failure, the more credibility you earn when you explain how you took the heat, absorbed the lesson, and re-architected the system to be bulletproof. Own the blood. Question 53. Tell me about a mistake you made. Note: interviewers use this question to evaluate accountability, transparency, and engineering maturity. Companies like Amazon and Google expect engineers to operate complex systems independently, so they want evidence that you acknowledge mistakes quickly, mitigate damage, and introduce safeguards to prevent recurrence.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to filter out candidates who lack ownership or self-awareness. Avoid these traps. 1. The tiny mistake, choosing a harmless or trivial error, for example, a typo in a README that had no real engineering impact. 2. The blame shift, claiming the mistake occurred because another team provided incorrect information or undocumented code. 3. The silent fix, admitting the mistake but hiding it from leadership instead of informing the team transparently. 4. The excuse narrative, over-explaining why the mistake happened to justify it without firmly acknowledging responsibility. 5. The no system change, fixing the immediate issue but failing to improve the CI/CD or architecture process afterward.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 engineering maturity signals. 1. Ownership: did the candidate clearly and unequivocally accept responsibility for the mistake? 2. Technical depth: was the failure rooted in a real, complex distributed systems engineering decision? 3. Speed of response: did they quickly mitigate the problem before it escalated further? 4. Transparency: did they communicate the issue openly with stakeholders and affected teams? 5. Systems improvement: did they implement guardrails to prevent anyone from making the same mistake in the future? Strong engineers treat mistakes as signals that reveal weaknesses in the system's guardrails.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: I was optimizing our order confirmation microservice, which was suffering from latency spikes during peak traffic due to connection starvation. Task: I decided to tune the Hikari CP database connection pool, increasing the max connections per pod to improve throughput. Action: I increased the pool size from 20 to 100 per pod. However, I failed to account for our Kubernetes autoscaler. When traffic spiked, the service scaled to 40 pods. My configuration change unleashed a connection storm of 4,000 sudden connections to our shared Postgres SQL cluster. The database hit its maximum connection limit and dropped traffic, causing an outage not just for my team, but for 2 other services sharing that cluster. Result: I immediately recognized the correlation, triggered an emergency rollback of the deployment, and manually killed the excess pods to stabilize the database. The shared outage lasted 12 minutes. Learning +L. I learned that application-level configs can become infrastructure-level weapons at scale. I partnered with the DBA team to implement PG Bouncer for connection multiplexing and established hard role-based connection quotas on the DB side, ensuring no single service could ever monopolize the cluster again. The +L shows you transformed an application config mistake into a global infrastructure safeguard.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates mature engineering accountability. 1. Ownership matched: you admitted your configuration change caused a cross-team outage. 2. Technical depth matched, you demonstrated deep understanding of connection pools, K 8 seconds auto-scaling and connection storms. 3. Speed of response matched, you executed a rollback and manually drained pods to restore DB health immediately. 4. Transparency matched, you brought the DBA team in and owned the postmortem for the shared cluster. 5. Systems improvement matched, introducing PG bouncer and DB level quotas made the mistake mathematically impossible to repeat. This demonstrates responsible engineering behavior in high-stakes production environments.
Follow-up 1. Clarification probe. Why did not this connection exhaustion surface in your staging or load testing environment?
Answer: our staging environment had a fixed replica count and did not have the Kubernetes horizontal pod autoscaler, HPA, enabled. The connection limit increase was safe on a static number of pods, but catastrophic when multiplied by dynamic scaling. This mistake exposed a massive gap in our testing parity, which we subsequently fixed by enabling HPA in staging load tests.
Follow-up 2. Level 3 or Level 4 junior depth. How did you realize it was your deployment causing the database to fail, rather than a natural traffic spike?
Answer: through Datadog observability. The database CPU was not spiking, but the active connections metric hit a hard ceiling exactly 2 minutes after my deployment completed. Concurrently, the application logs started throwing Hikari pool connection is not available and Postgres threw fatal sorry, too many clients already. The timestamp correlation made it undeniable.
Follow-up 3. Level 5 or Level 6 senior depth. Your mistake took down 2 other teams' services. How did you handle the political and interpersonal fallout with those engineering leads?
Answer: I took immediate public accountability. I did not wait for them to trace the logs back to my team. I posted in the global engineering channel. I deployed a config change that caused a DB connection storm. I am rolling it back now and I own the postmortem. During the review, I did not just apologize. I presented the PG bouncer architectural fix. Trust with other leads is rebuilt through architectural guarantees, not apologies.
Follow-up 4. Curveball. What if the rollback had failed, and the database remained locked up because the pods would not release the connections?
Answer: if the graceful rollback failed, I would move to aggressive mitigation to save the core infrastructure. I would use kubectl scale deployment replicas equals 0 to brutally kill my own service, instantly severing the network connections to the DB. My service would suffer 100% downtime, but it would immediately allow the database to recover and restore availability for the other 2 critical services.
Leadership pro tip. The blast radius confession.
When asked about a mistake, many candidates minimize the damage. Elite candidates do the opposite. They highlight the full extent of the blast radius. Admitting that your code took down a shared database, and then explaining the deep technical steps you took to decouple that blast radius, like connection multiplexing, shows an interviewer that you possess the resilience and systemic vision required to be a principal architect. Question 54. Tell me about a time you made a wrong decision. Note: interviewers ask this question to evaluate engineering judgment and self-awareness. At companies like Amazon and Netflix, engineers regularly make architectural and operational decisions with incomplete information. Interviewers want to see whether you recognize flawed decisions early, mitigate the impact, and convert the experience into better decision frameworks.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to detect candidates who lack accountability or attempt to deflect blame. Avoid these traps. 1. The humble brag, claiming a perfectionist trait as a bad decision. For example, I push myself too hard to deliver the best code. 2. The scapegoat narrative, explaining how you made a decision based on someone else's bad advice or faulty data. 3. The trivial mistake, describing a minor typo or formatting error instead of a substantial architectural or process decision. 4. The denial response, stating that you have not made any significant wrong decisions in your career. 5. The unresolved failure, describing a wrong decision without clearly explaining how you corrected it or what systemic changes followed.
Here are the signals the interviewer is scoring.
While you answer this question, interviewers evaluate these 5 leadership signals. 1. Accountability. Did the candidate fully own the poor decision without making excuses? 2. Impact awareness. Did they understand the business or technical consequences of their choice? 3. Course correction, did they take decisive action to pivot or rectify the situation? 4. Analytical reflection, did they understand why their initial judgment was flawed? 5. Systemic improvement, did they alter their decision-making framework or team processes to prevent a recurrence? Elite candidates prove they learn faster from bad decisions than they do from successes.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: we were designing a new event-driven order processing system. We needed a message broker, and I was the lead architect evaluating the options. Task: I chose to implement a cutting-edge, newly released open-source streaming platform instead of an established standard like Kafka, believing its promised low-latency features would future-proof us. Action: after 2 months of integration, we started hitting severe bugs under load. The community support was minimal, and my team was spending 40% of their sprint cycles just managing the broker's instability. I realized my decision was wrong. I had prioritized theoretical performance over operational maturity. I wrote a migration plan, presented my error to the team, and we spent the next month migrating the infrastructure back to managed Kafka. Result: while the pivot cost us a month of development time, moving to Kafka stabilized the platform immediately. We launched the order system with 0 dropped messages during peak traffic. Learning plus L. I learned the hard way that boring technology is often the right choice for critical path infrastructure. I subsequently introduced a strict technology adoption rubric for the Architecture Guild, requiring any new infrastructural tool to meet specific maturity and community support metrics before being considered for production. The +L demonstrates that the candidate codified their lesson into organizational governance.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates mature self-reflection. 1. Accountability matched, you admitted to choosing the wrong technology based on flawed priorities. 2. Impact awareness matched, you highlighted the operational cost, 40% of sprint cycles lost to instability. 3. Course correction matched, you decisively pulled the plug and absorbed the cost of the migration. 4. Analytical reflection matched, you recognized you had prioritized cutting-edge features over operational maturity. 5. Systemic improvement matched, the technology adoption rubric ensured the entire organization would not repeat the mistake. This shows the interviewer you have the humility and judgment required for senior leadership.
Follow-up 1, clarification probe. How did the team react when you told them they had to tear out 2 months of work because of your architectural choice?
Answer: it was a difficult conversation, but because I owned the mistake completely, without blaming the tool or external factors, they respected the transparency. The team was actually relieved, as they were the ones bearing the operational burden of the unstable system.
Follow-up 2, Level 3 or Level 4 junior depth. What specific metrics in the new rubric would have prevented you from choosing that initial tool?
Answer: the rubric now requires a tool to have at least 3 major production use cases documented by peer companies, a minimum threshold of active maintainers on GitHub, and a proven track record of resolving critical CVEs within specific SLAs. The tool I originally chose would have failed all 3 criteria.
Follow-up 3, Level 5 or Level 6 senior depth. How did you explain a month-long delay to your business stakeholders or product manager?
Answer: I framed it in terms of risk. I explained that while we were delaying the launch by a month, continuing with the unstable architecture guaranteed severe outages during our peak season, which would cost exponentially more in lost revenue. By framing the pivot as a necessary risk mitigation strategy rather than just an engineering mistake, they understood the business necessity of the delay.
Follow-up 4, curveball. What if leadership refused to authorize the time for the migration and told you to just make the current system work?
Answer: if forced to proceed, I would disagree and commit. I would clearly document the risks and the projected operational costs in an executive summary. Then, I would shift our engineering focus entirely to hardening the unstable system, building aggressive circuit breakers, robust dead-letter queues, and automated restart scripts to mitigate the inevitable failures as much as possible.
Leadership pro tip: the cost of resume-driven development.
Interviewers love stories about resume-driven development, choosing a flashy new technology simply because it is exciting, rather than because it serves the business. Admitting you fell into this trap, and then demonstrating how you matured out of it, signals deep architectural pragmatism. Question 55. Describe a project that did not go as planned. Note, interviewers use this question to evaluate your adaptability, risk management, and ability to pivot when core architectural or business assumptions fail, which is a major leadership signal evaluated at companies like Google and Meta.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to find engineers who panic or become rigid when things go wrong. Avoid these traps. 1. The helpless victim, describing the project failure as something that happened to you, showing a lack of agency or control. 2. The sunk cost fallacy, explaining how you doubled down on a failing plan because you had already invested too much time. 3. The communication blackout, realizing the project was off track but failing to notify stakeholders until the deadline had passed. 4. The blame game, attributing the failure to the impossible requirements of the product team or the bad code of a previous developer. 5. The no outcome, ending the story on a negative note without describing the successful pivot or the systemic learning.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 resilience signals. 1. Early risk detection. Did the candidate identify that the plan was failing before it became a catastrophe? 2. Analytical pivot. Did they use data to determine the new direction rather than just guessing? 3. Stakeholder management. Did they manage expectations and maintain trust while the plan was changing? 4. Pragmatism. Did they prioritize the business outcome over their original technical vision? 5. Systemic growth. Did they change the planning process to catch similar risks earlier next time? Strong candidates prove that a failed plan is a success if it leads to a better strategic pivot.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: I was leading the migration of our legacy user profile service to a new globally distributed NoSQL database. Our original plan assumed a big bang cutover during a 4-hour maintenance window. Task: 2 weeks before the cutover, our rehearsal revealed that the legacy data transformation logic was 5 times slower than expected, meaning the maintenance window would actually need to be 20 hours, unacceptable for the business. Action: I did not push the team to work faster on a flawed plan. I halted the cutover and proposed a total pivot to the strangler fig pattern. I designed a dual-write bridge that synchronized data in real time, allowing us to migrate users in small batches over 2 weeks with 0 downtime. Result: we hit our final decommissioning target on time. While the technical complexity increased, we eliminated the risk of an extended outage and ensured 100% data consistency during the transition. Learning plus L. I learned that offline migrations are too risky for large datasets. I subsequently authored a 0 downtime migration playbook that made dual-write synchronization the mandatory standard for all future stateful service moves. The plus L demonstrates that you fix the planning methodology for the entire organization.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite project leadership and adaptability. 1. Early risk detection matched. You identified the 20-hour window risk during the rehearsal, not during the actual launch. 2. Analytical pivot matched. You abandoned the Big Bang plan in favor of a more complex but safer dual-write synchronization strategy. 3. Stakeholder management matched. You presented the business with a 0 downtime option when the original maintenance window became unfeasible. 4. Pragmatism matched. You accepted higher technical complexity to protect the company's uptime and revenue. 5. Systemic growth matched. The plus L step, the migration playbook, ensured the org would not attempt a risky Big Bang move again. This shows you are an architect who can navigate through a failed assumption without crashing the project.
Follow-up 1. Clarification probe. How much extra engineering effort did the dual-write bridge add compared to the original plan?
Answer: it added roughly 10 days of development and testing. I justified this to my manager by comparing it to the worst-case cost. If we had proceeded with the original plan and it failed, the recovery would have taken days and cost the company hundreds of thousands in lost customer trust. The bridge was a calculated insurance policy.
Follow-up 2, Level 3 or Level 4 junior depth. How did you ensure the dual write logic did not introduce significant latency into the user-facing profile updates?
Answer: I implemented the writes asynchronously using a background queue. The user received a success message the moment the primary database was updated. The secondary write to the new NoSQL database happened in the background. We monitored the queue depth closely to ensure the drift between the two systems stayed under 500 milliseconds.
Follow-up 3, Level 5 or Level 6 senior depth. Pivoting mid-project can damage team morale. How did you get the engineers to buy into a more complex plan when they were already tired?
Answer: I did not present it as more work. I presented it as de-risking their careers. I shared the rehearsal data and asked the team, do you want to be on an 18-hour bridge call that is guaranteed to fail, or do you want to build a cool piece of synchronization infrastructure? I framed the pivot as an engineering challenge that would protect their sleep and our reputation. They were energized by the shift from a grind to a solve.
Follow-up 4, Curveball. What if, during the 2-week batch migration, a major bug was found that caused the dual write to corrupt the data in the new database?
Answer: this is why we kept the legacy system as the source of truth. If the new data was corrupted, it would not matter yet because the UI was still reading from the old system. I would have purged the new database, fixed the synchronization bug, and restarted the batch migration from day one. In a migration, never cut over until you have verified data integrity on a per-user basis.
Leadership pro tip: the pivot is the strategy.
Junior candidates view a project not going to plan as a failure. Senior architects view it as the moment the real engineering starts. When you answer this, focus on the detection point, the moment you realize the plan was flawed, and show the interviewer that you had the courage to stop the momentum and steer the team toward a safer, better outcome. Question 56. Tell me about a time you missed a deadline. Note: interviewers use this question to evaluate your accountability, risk management, and stakeholder communication when projects fall behind schedule. At companies like Amazon and Meta, this tests your ability to prioritize business integrity over arbitrary dates and whether you can negotiate trade-offs under pressure.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to identify candidates who hide bad news or sacrifice quality for speed. Avoid these traps. 1. The last-minute surprise, realizing the deadline would be missed but waiting until the day of to inform stakeholders. 2. The hero culture fix, admitting you missed the deadline but fixed it by working 80-hour weeks. This signals poor planning and unsustainable work habits. 3. The quality sacrifice, missing the deadline technically, but shipping buggy, untested code just to hit the date. 4. The external blame, attributing the delay entirely to a third-party vendor or a slow other team without explaining your attempts to mitigate the risk. 5. The trivial deadline, choosing a story where the deadline did not actually matter, which makes the failure look minor.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 project leadership signals. 1. Early risk signal: did the candidate detect the delay early enough to give the business options? 2. Trade-off negotiation: did they offer a reduced scope MVP or a phased rollout instead of a total delay? 3. Accountability: did they own the planning failure without making excuses? 4. Stakeholder management: did they maintain trust with the business while delivering bad news? 5. Systemic improvement: did they change their estimation or discovery process to prevent a recurrence? Strong candidates prove that missing a deadline is a strategic decision, not an accidental failure.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: I was leading a high-priority migration of our customer data store to a new encrypted cluster to meet a strict GDPR compliance deadline set by the legal team. Task: we had a hard 3-month window. Halfway through, we discovered that 15% of our legacy data was stored in an incompatible non-UTF-8 format that required a complex, manual scrubbing process. Action: I realized that hitting the original date meant skipping the scrub and risking 15% data loss. I immediately flagged this to the legal and product VPs. Instead of just asking for more time, I proposed a two-speed migration. We would migrate the 85% compliant data by the deadline and implement a temporary manual proxy for the remaining 15% while we finished the scrub over an extra 3 weeks. Result, we hit the compliance milestone for the vast majority of our traffic on time. The remaining data was fully migrated 3 weeks later with zero data loss or customer impact. Learning plus L. I learned that our data discovery phase was too shallow. I subsequently introduced a data profiling sprint as a mandatory first step for any large-scale data migration to identify encoding risks before committing to timelines. The plus L shows you fixed the discovery gap for the entire engineering org.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite risk management and transparency. 1. Early risk signal matched. You identify the data encoding issue halfway through the project, giving you time to pivot. 2. Trade-off negotiation matched. You proposed a two-speed migration to satisfy the compliance deadline while protecting data integrity. 3. Accountability matched. You took ownership of the fact that the discovery phase was originally insufficient. 4. Stakeholder management matched. You brought the legal and product VPs into the decision-making process with a concrete alternative. 5. Systemic improvement matched. The plus L step, the data profiling sprint, fixed the root cause of the misestimation. This demonstrates that you prioritize business-critical data integrity over simply checking a box.
Follow-up 1. Clarification probe. When you realized the deadline was at risk, who exactly did you notify first and why?
Answer: I notified my engineering manager first to align on the technical feasibility of the two-speed proposal. Once we were aligned, we immediately requested a sync with the legal counsel and the product lead. I wanted to ensure that the technical fix met the legal definition of compliance before presenting it as a solution.
Follow-up 2. Level 3 or Level 4 junior depth. How did you estimate that the data scrubbing would take exactly 3 weeks?
Answer: I did not guess. I took a 5% sample of the corrupted data and ran a pilot scrub. I measured the throughput of the script and factored in a 20% buffer for unexpected serialization errors. Based on that real-world velocity, we calculated that 21 days was the most accurate window to finish the remaining 15% of the dataset.
Follow-up 3. Level 5 or Level 6 senior depth. The legal team was likely unhappy with any delay. How did you handle their pushback regarding the remaining 15% of data?
Answer: I used a risk comparison framework. I presented the trade-off. We can ship today and have a 15% data loss, which is itself a GDPR violation. Or we can ship a partially compliant environment today and be 100% compliant in 3 weeks. By framing the delay as the lower risk option for the company, I turned legal into a partner in the decision rather than an adversary.
Follow-up 4. Curveball. What if the VP of engineering told you that missing the date was unacceptable and you had to find a way to do it in 1 week? What would you do?
Answer: I would request a surge of temporary resources from adjacent teams. I would explain that with the current team, we are at a physical limit of script execution time. If we could spin up 3 additional engineers to help with manual validation and parallelize the scrubbing across more worker nodes, we could potentially hit the 1-week target, but at the cost of the other team's sprint goals. I make the cost of the deadline explicit so the VP can make the ROI call.
Leadership pro tip. Deadlines are hypotheses.
Junior engineers view a deadline as a law. Senior architects view a deadline as a hypothesis based on current information. When the information changes, discovery of new complexity, the hypothesis must be updated. Your value in an interview is showing that you can deliver bad news early, with data, and with a concrete plan B that protects the business outcome. Question 57. Tell me about a time you had to admit you were wrong. Note: interviewers use this question to evaluate your intellectual humility, ego management, and ability to prioritize technical truth over personal pride. At companies like Google and Amazon, senior engineers are expected to follow the data, even when it contradicts their own previously stated positions.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to identify engineers who are defensive or lack self-awareness. Avoid these traps. 1. The minor mistake, admitting to a tiny safe error like a typo or a missed meeting. This avoids showing true vulnerability. 2. The fake wrong, describing a situation where you were actually right but someone else's mistake made you look wrong. 3. The blame the input, claiming you were only wrong because you were given bad requirements or faulty data by a stakeholder. 4. The slow admission, admitting you were wrong only after the system crashed and the evidence was impossible to hide. 5. The ego defense, focusing more on why your original idea should have worked rather than why it was actually the wrong choice.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 psychological and technical signals. 1. Intellectual humility. Did the candidate prioritize the project's success over their own ego? 2. Data responsiveness. Did they pivot as soon as the metrics or logs contradicted their hypothesis? 3. Transparency. Did they admit the error to the team and stakeholders immediately and clearly? 4. Risk mitigation. Did they take decisive action to roll back or fix the impact of their wrong decision? 5. Systemic improvement. Did they update their decision-making framework to prevent similar errors? Strong candidates prove that being right a lot requires the ability to admit when you are wrong quickly.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer around a technical pivot driven by data. Situation. I advocated strongly for migrating our high-frequency pricing engine from a standard SQL database to a specialized in-memory NoSQL store to achieve sub-10 milliseconds latency. Task. I led the initial phase of the migration, convincing the architecture review board that the SQL engine was our primary bottleneck. Action. After the first month of performance testing on a production-mirrored cluster, the data showed that our latency actually increased by 15%. I realized my original assumption was wrong. I had failed to account for the heavy network serialization overhead between the app and the new store. I immediately called an emergency sync, admitted my hypothesis was flawed, and proposed halting the migration to focus on SQL indexing and query optimization instead. Result: by admitting the error early, we saved 2 months of wasted engineering effort. The subsequent SQL optimizations achieved our sub-10 milliseconds goal, and we avoided adding a complex, unnecessary component to our stack. Learning +L. I learned that architectural elegance on paper does not always translate to performance in production. I subsequently implemented a benchmark-first policy, requiring a verified performance prototype before any protocol or database shift is proposed. The +L, learning, shows you built a guardrail against your own technical biases.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite professional maturity. 1. Intellectual humility matched. You halted your own project the moment the data proved it was the wrong direction. 2. Data responsiveness matched. You did not try to tweak the NoSQL store to force it to work. You followed the performance metrics back to SQL. 3. Transparency matched. You called an emergency sync to admit the flaw to the review board publicly. 4. Risk mitigation matched. You saved the company from a massive sunk cost disaster and avoided technical debt. 5. Systemic improvement matched. The benchmark first policy ensured the organization would not repeat your mistake. This demonstrates that you are a trusted advisor who values the truth more than your reputation.
Follow-up 1. Clarification probe. How did the architecture review board react when you told them the project you fought for was a mistake?
Answer: they were surprisingly supportive. At the senior level, leadership values speed to truth more than being right initially. By coming to them with the data and a solution, SQL optimization, before they discovered the failure themselves, I actually increased my credibility as a pragmatist.
Follow-up 2. Level 3 or Level 4 junior depth. Why did not you realize the serialization overhead would be an issue during the design phase?
Answer: I relied on the vendor's white papers, which showed extremely high local throughput. My mistake was a local versus distributed bias. I assumed the local speed of the store would override the network costs. In a distributed system, the wire is often slower than the CPU, and I failed to model that correctly until the performance test revealed it.
Follow-up 3. Level 5 or Level 6 senior depth. How did you manage the team's morale? They had spent a month building this migration only to see it scrapped.
Answer: I framed the pivot as a victory for engineering rigor. I told the team, Our performance testing was so effective that it saved us from a production disaster. I ensured they knew the work was not wasted because it gave us the definitive data to justify staying on SQL. We then focused their energy on the high-impact SQL optimizations, where they saw immediate results.
Follow-up 4 Curveball. What if your SQL optimizations also failed to hit the latency target? Would you go back to the no SQL store again?
Answer: no. I would not flip-flop between two failed hypotheses. I would reevaluate the entire request path. If the database was not the answer, I would look at the application-level logic, the load balancer settings, or potentially implement a sidecar cache. I would maintain a data-driven approach rather than returning to a solution I had already proven to be flawed.
Leadership pro tip. Admitting you are wrong is a power move.
Junior engineers think admitting a mistake makes them look weak. Senior architects know it makes them look safe. If an interviewer knows you are willing to admit you are wrong when the data changes, they know they can trust you with a $100 million system. It proves you will never drive a project off a cliff just to save face. Question 58. Tell me about a time you failed to meet expectations. Note: interviewers use this question to evaluate your ability to manage performance gaps, your transparency with stakeholders, and your capacity to recalibrate when high-stakes technical commitments are missed. This is a core signal for reliability and trust at companies like Google and Meta.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to identify candidates who are unreliable or lack the maturity to communicate failure. Avoid these traps. 1. The perfectionist lie, claiming you never fail to meet expectations, or choosing a failure that is actually a positive. For example, I failed because I worked too hard. 2. The communication blackout, realizing an expectation will not be met but failing to notify stakeholders until after the deadline has passed. 3. The finger pointer, blaming the failure on a lack of resources, a bad manager, or an underperforming teammate. 4. The silent acceptance, admitting the failure but not describing any concrete action taken to remediate the situation or improve the outcome. 5. The vague impact, failing to quantify exactly what expectations were missed and how it impacted the business or the system.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 reliability signals. 1. Early detection: did the candidate recognize the performance gap before it became a crisis? 2. Stakeholder management: did they proactively recalibrate expectations with the business? 3. Accountability: did they own the failure rather than hiding behind technical complexity? 4. Systemic remediation: did they implement a technical or process change to prevent a repeat failure? 5. Resilience: did they maintain their professional standing and velocity after the failure occurred? Strong candidates prove that failing an expectation is a data point for future calibration.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer around a missed technical commitment and the subsequent systemic fix. Situation: during a major infrastructure overhaul, I committed to delivering a 99.9% availability target for our new API gateway. This was a critical expectation shared with our top-tier enterprise customers. Task: I was the lead architect responsible for ensuring the high-availability failover logic was production-ready by the launch date. Action: 3 weeks before launch, our chaos engineering tests revealed that our cross-region failover took 4 minutes, violating our 99.9% SLO, which allows only 43 minutes of downtime per month. I realized I had overpromised on the timeline required for such complex state syncing. I immediately flagged this to the CTO and product leads. I did not ask for a lower bar. I asked for a 2-week launch delay to implement a more robust global server load balancing strategy. Result: I missed the original launch expectation. However, the delay allowed us to achieve a 25-second failover. We launched with the promised 99.9% availability and maintained it through the first quarter with 0 SLA breaches. Learning plus L. I learned that initial availability estimates are often too optimistic without real-world chaos testing data. I subsequently introduced pre-commit SLO benchmarking for all new architectures to ensure expectations are calibrated against proven test results. The plus L, learning. Shows you built a framework to ensure future expectations are grounded in data.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite professional maturity and risk management. 1. Early detection matched. You identify the SLO violation during chaos testing, well before the live launch. 2. Stakeholder management matched. You proactively informed the CTO and product leads when the gap was found. 3. Accountability matched. You admitted the original estimate was over-optimistic rather than blaming the complexity of the tech. 4. Systemic remediation matched. You delayed the launch to build a superior GSLB solution, prioritizing long-term reliability. 5. Resilience matched. You successfully navigated the pressure of a launch delay to deliver a stable product. This demonstrates that you protect the company's reputation more than your own ego.
Follow-up 1. Clarification probe. How did the CTO react when you proposed a launch delay for a 4-minute failover window that seemed small to them?
Answer: initially, there was pushback. I used our revenue at risk model to explain the impact. I showed that even a 4-minute outage during peak traffic would breach our contractual SLA with our largest enterprise client, potentially triggering $50,000 in credits. By framing the delay as a financial risk mitigation rather than a technical preference, I secured their alignment immediately.
Follow-up 2. Level 3 or Level 4 junior depth. Technically, why did the cross-region failover take 4 minutes initially?
Answer: the bottleneck was DNSTTL and database record synchronization. The old architecture relied on standard health checks that took 60 seconds to detect failure, followed by a slow DNS propagation. I moved us to a global accelerator approach that used Anycast IPs, removing the DNS dependency and bringing detection and routing under 30 seconds.
Follow-up 3. Level 5 or Level 6 senior depth. Missing a deadline can damage your personal brand within the company. How did you manage your reputation with the marketing and sales teams who were ready for the launch?
Answer: I took a proactive communication approach. I hosted a brief sync for the sales leads to explain the reliability value of the new launch date. I gave them the exact talking points they could use with customers to explain that we were delaying the release specifically to ensure enterprise-grade stability. I turned the failure into a sales strength. We care so much about your uptime that we are refusing to ship a substandard system.
Follow-up 4. Curveball. What if, after the 2-week delay, the failover still took 2 minutes and you still missed the SLO? Would you delay the launch again?
Answer: at that point, it becomes a multivariable business decision. If a second delay would cause catastrophic market damage, I would propose a limited release. We would launch to non-enterprise customers where the lower SLO was acceptable, while keeping our high SLA clients on the old infrastructure until the failover logic was perfected. You must maintain the ability to find a middle path when technical ideals fail.
Leadership pro tip. SLOs are a contract with reality.
Junior engineers view expectations as a target to hit by any means necessary. Senior architects view expectations as a contract with reality. When the data shows you cannot meet the contract, the only senior move is to communicate the gap immediately and offer a recovery path. Being wrong about a timeline is acceptable. Being silent about a risk is a fireable offense. Question 59. What would you do differently if you could redo a project? Note: interviewers use this question to evaluate your retrospective thinking and technical judgment. Senior engineers are expected to identify where they over-engineered, ignored a trade-off, or missed a systemic risk. This is a major signal for maturity and architectural foresight evaluated at companies like Google and Meta.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to detect candidates who are rigid or lack self-awareness. Avoid these traps. 1. The perfect project claim saying you would not change anything because the project was a total success. This proves a lack of growth mindset. 2. The surface-level change, suggesting minor, trivial changes like I would have written more comments or I would have used a different variable name. 3. The blame the tools defense, saying you would change the project only by using a different external library or vendor that did not exist then. 4. The resource excuse, claiming you only needed more people or more time, rather than identifying a flaw in your own strategy or design. 5. The hindsight bias, failing to explain why your original decision made sense at the time and what specific new data changed your perspective?
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 architectural signals. 1. Critical self-reflection. Can the candidate identify a flawed assumption in their own design? 2. Trade-off awareness. Do they understand the long-term cost of the path they originally chose? 3. Pragmatism. Would their new approach be more efficient, cost-effective, or maintainable? 4. Systemic growth. Have they applied this lesson to subsequent projects? 5. Business alignment. Does their redo prioritize business value over technical perfection? Strong candidates show they have matured from building it fast to building it right for the long term.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer around a complex architectural trade-off. Situation: I led the migration of our legacy monolith to a microservices architecture to support a projected 10 times growth in user traffic. Task: I was the primary architect responsible for decomposing the monolithic database into 12 domain-specific services. Action: if I were to redo this project today, I would have opted for a database per service model much later in the lifecycle. At the time, I prioritized total decoupling, which forced us to implement complex distributed transactions and Saga patterns for simple checkout flows. I realized that while the decoupling worked, the operational complexity and network latency we introduced were premature for our actual scale. Result: the migration was technically successful and did support the growth, but it increased our mean time to repair for production incidents by 30% due to the difficulty of tracing data across so many isolated databases. Learning plus L. I learned that microservices are an organizational tool for scaling teams, not just a technical tool for scaling code. I now advocate for a modular monolith or shared schema approach as an intermediate step to ensure the domain boundaries are stable before committing to the cost of physical database isolation. The +L proves you now possess the architectural restraint that defines a principal engineer.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite technical maturity. 1. Critical self-reflection matched. You admitted that the decision to physically isolate databases was premature and created unnecessary complexity. 2. Trade-off awareness matched. You identified the hidden cost of the decision, specifically a 30% increase in MTTR. 3. Pragmatism matched. You proposed a modular monolith as a more efficient intermediate step for similar projects. 4. Systemic growth matched. You now use a shared schema validation phase before moving to full microservice isolation. 5. Business alignment matched. You recognize that operational stability, MTTR, is just as important as technical decoupling. This shows you have the wisdom to avoid over-engineering, even when a solution is technically correct.
Follow-up 1. Clarification probe. If you had stayed with a shared schema longer, how would you have prevented teams from creating tight coupling between their tables?
Answer: I would have enforced coupling at the CI/CD and code layer rather than the physical storage layer. I would have implemented schema linting and strict code ownership rules in our Git repository. This would have provided the logical isolation we needed to move fast, without the 40 milliseconds network penalty and distributed transaction overhead of a fully isolated database per service.
Follow-up 2. Level 3 or Level 4 junior depth. Why did you think the physically isolated database was necessary in the first place?
Answer: at the time, our database CPU was hitting 90%. I assumed the only way to scale was to physically split the load. Looking back, I realized that 60% of that load was coming from inefficient cross-domain joins that could have been resolved with better indexing and read replicas. I chose a high-complexity architectural fix when a low-complexity optimization would have bought us another year of growth.
Follow-up 3. Level 5 or Level 6 senior depth. How do you now decide when a team is actually ready to move from a modular monolith to fully isolated microservices?
Answer: I look for organizational friction rather than technical load. If two teams are constantly stepping on each other's toes during deployments, or if a bug in the shipping service is taking down the billing database, then the cost of isolation is justified. If the teams are independent and the system is stable, the overhead of microservices is a tax you should not pay. Architecture should follow the team's communication needs, not just technical trends.
Follow-up 4 Curveball. What if you proposed the modular monolith today, but a highly influential lead developer on the team accused you of staying in the past and pushed for full serverless or microservices rewrite?
Answer: I would avoid a religious debate about architecture and move to a total cost of operation model. I would map out the projected engineering hours required to manage distributed state, the cost of observability tooling like tracing, and the impact on our onboarding speed. I would frame the choice as, do we want to spend 50% of our capacity on infrastructure management or on shipping features for our customers? Data-driven financial logic usually wins against architectural hype.
Leadership pro tip. Hindsight is a data asset.
Junior engineers hide their past mistakes because they think it makes them look incompetent. Senior architects document their past mistakes because they know it makes them reliable. When you answer what you would do differently, you aren't admitting defeat. You are proving that your current technical judgment is based on real-world scars, not just reading blogs. Question 60. Tell me about a decision you later realized was wrong. Note: interviewers use this question to evaluate your technical judgment, self-awareness, and your ability to prioritize business efficiency over your own architectural pride. This is a critical signal for being right. A lot of companies like Amazon and Google, where admitting a mistake early is seen as a sign of high integrity.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to detect candidates who are either stubborn or lack financial or operational pragmatism. Avoid these traps. 1. The safe error, admitting to a tiny low-stakes decision that had zero impact on the business or team. 2. The external circumstances defense, claiming you were only wrong because a vendor lied or a requirement was hidden. This lacks true ownership. 3. The silent correction, explaining how you fixed the mistake but admitting you never told your manager or team that you were wrong initially. 4. The resume-driven bias, defending a complex architectural choice that was clearly overkill for the problem just because the tech was modern. 5. The slow pivot, admitting you knew the decision was wrong but waited months to change it to avoid looking bad.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 leadership signals. 1. Pragmatism. Did the candidate prioritize business value and cost over their own technical vision? 2. Data-driven humility. Did they use metrics to identify and admit the error quickly? 3. Total cost of ownership. Did they realize the long-term maintenance or financial burden of their choice? 4. Stakeholder transparency. Did they communicate the mistake and the pivot plan clearly to leadership? 5. Systemic improvement. Did they change the design review process to prevent similar over-engineering? Strong candidates prove they are willing to kill their darlings for the good of the company.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer around an over-engineered decision that you corrected for the sake of the business. Situation: I was the lead architect for a new global metadata service. Expecting 100% availability and sub-100 milliseconds global latency, I decided to implement a full active-active multi-region database setup using DynamoDB global tables across 4 regions. Task: I wanted to ensure that if an entire AWS region failed, our metadata would remain available with zero manual failover. Action: after 2 months in production, I audited our usage metrics and realized that 98% of our traffic was coming from a single region, US East 1. The cost of replicating every write to 4 regions was costing us an extra $12,000 per month for data that was almost never read outside the US. I realized I had over-engineered for a 0.01% risk. I authored an architectural pivot doc, admitted the setup was overkill, and migrated us back to a single primary region with cross-region read replicas. Result: the pivot reduced our monthly cloud bill by 70% while still meeting our 99.99% SLA. Latency remained unchanged for 98% of our users. Learning plus L. I learned that high availability is a spectrum, not a binary choice. I now use a tiered risk model for all new designs, ensuring we only pay the multi-region tax for services that are truly mission-critical to the global business. The plus L shows you transformed a mistake into a financial governance framework.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite technical and financial leadership. 1. Pragmatism matched. You chose to simplify the architecture to save the company $144,000 per year. 2. Data-driven humility matched. You audited your own design, found it was inefficient, and raised the flag yourself. 3. Total cost of ownership matched. You recognized that the cost of replication was not worth the theoretical benefit of active-active availability. 4. Stakeholder transparency matched. You wrote a formal architectural pivot document to explain the correction to the team. 5. Systemic improvement matched. The tiered risk model ensured the organization would not over-engineer future services. This demonstrates that you lead with the mindset of a business owner, not just a technologist.
Follow-up 1. Clarification probe. Why did not you catch this cost-to-value mismatch during the initial design phase?
Answer: at the time, the project was operating under a reliability at all costs directive from a previous major outage. I allowed that historical fear to cloud my judgment, causing me to over-index on availability. My failure was not re-evaluating that directive against the actual traffic patterns once we had real data.
Follow-up 2. Level 3 or Level 4 junior depth. How did you migrate the live data from 4 regions back to 1 without causing an outage?
Answer: I used a weighted routing approach. I first detached the 3 redundant regions as active targets, but kept them as read replicas. Once I verified that US East 1 could handle 100% of the write load, I gradually shifted the DNS traffic and then decommissioned the global replication. The transition was completely transparent to the application layer.
Follow-up 3. Level 5 or Level 6 senior depth. Admitting you were wrong after spending 2 months of engineering time is a heavy cost. How did you justify that waste to your leadership?
Answer: I did not frame it as waste. I framed it as a discovery dividend. I explained that we now had 2 months of production data, proving we did not need the $144,000 annual expense. I showed that the cost of staying wrong was far higher than the cost of fixing it now. Leadership respects architects who stop the bleeding of engineering resources as soon as the data changes.
Follow-up 4. Curveball. Suppose the VP of Engineering disagreed with your pivot and said, "We are a global company. We must be active-active everywhere to look professional." What would you do?
Answer: I would return to the data and the risk model. I would show the VP that our 99.99% SLA is currently being met with the single region setup, and that the $144,000 saved could be better spent on other features the customers are actually asking for. However, if they still insisted, I would disagree and commit. I would document the cost and operational overhead clearly, and then work to make the active-active setup as efficient as possible.
Leadership pro tip. Do not fall in love with your design.
Junior engineers view their code and architecture as an extension of themselves. They feel attacked when it is criticized. Senior architects view their designs as a disposable tool meant to solve a business problem. When the business problem changes, or the data proves the tool is too expensive, the elite architect is the first person to volunteer to tear it down. Detachment from your own ego is the fastest way to gain influence. Question 61. Tell me about a time when you underestimated the complexity of a task. Note: interviewers use this question to evaluate your technical judgment, estimation maturity, and risk awareness. At companies like Google and Meta, engineers are expected to scope massive, ambiguous systems. Interviewers want to see that you can identify hidden depth early and pivot your strategy rather than just working longer hours to hide a bad estimate.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to find engineers who are reactive or lack architectural foresight. Avoid these traps. 1. The typo mistake, describing a simple bug or syntax error as complexity. This makes you look like you do not understand what real complexity is. 2. The work harder fallacy, explaining how you solve the complexity by just working nights and weekends. This is a negative signal for sustainability and planning. 3. The blame the code-based defense, claiming you only failed because the existing code was a mess. Senior engineers are expected to account for technical debt in their estimates. 4. The silent delay, realizing the task was complex but failing to notify stakeholders until the original deadline was missed. 5. The no process change, finishing the task but failing to implement a new discovery or estimation mechanism to prevent it from happening again.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 execution signals. 1. Technical insight. Did the candidate identify why the task was more complex than it appeared, for example, distributed state edge cases? 2. Communication. Did they raise the complexity flag as soon as the data changed? 3. Adaptability. Did they change their implementation strategy to match the new reality? 4. Risk management. Did they prioritize the business outcome over the original technical plan? 5. Systemic growth. Did they improve the team's technical discovery process afterward? Strong candidates prove they value accuracy over ego when it comes to timelines.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer around a simple feature that revealed a complex architectural dependency. Situation: I was tasked with implementing a delete user account feature for our core platform to comply with new right-to-be-forgotten regulations. I originally estimated this as a 1-week task, assuming it was a simple row deletion. Task: I needed to ensure that, when a user clicked delete, every trace of their PII, personally identifiable information, was purged across our entire distributed system. Action: during the first 48 hours of discovery, I realized that user data was not just in one table. It was replicated across 12 different microservices and nested inside 5 years of compressed S3 cold storage. A simple delete would leave orphan data and violate compliance. I immediately halted work, presented a data lineage map to leadership, and proposed a pivot to an asynchronous, event-driven cleanup service using a Saga orchestrator to ensure 100% purge verification. Result: the project took 4 weeks instead of 1, but we launched a robust, auditable system that successfully purged 500,000 accounts with 0 dangling references. We avoided a potential multi-million-dollar compliance fine. Learning plus L. I learned that in a microservices environment, data gravity is invisible. I subsequently introduced a data dependency audit into our RFC template, requiring every feature to map its data footprint before estimation begins. The plus L, learning, demonstrates that you improve the organization's ability to see hidden complexity.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite architectural maturity. 1. Technical insight matched. You recognize that user data existed in both live microservices and compressed cold storage S3. 2. Communication matched. You presented a data lineage map to leadership to justify the timeline shift with hard evidence. 3. Adaptability matched. You moved from a simple delete to a Saga orchestrator to handle the distributed state complexity. 4. Risk management matched. You prioritized legal compliance and data integrity over hitting an arbitrary 1-week deadline. 5. Systemic growth matched. You institutionalized the data dependency audit to prevent similar estimation errors globally. This shows you are an architect who manages complexity with systems, not just effort.
Follow-up 1, clarification probe. Why did not you identify the 12 microservice dependencies during the initial 1-week estimation?
Answer: at the time, our architecture lacked a centralized service catalog. I based my estimate on the services I was familiar with. This failure was the exact catalyst that led me to advocate for our current service graph, which now gives us instant visibility into data flow across all 50-plus services.
Follow-up 2, Level 3 or Level 4 junior depth. Technically, how did the Saga orchestrator ensure that the data was actually deleted if one of the 12 services was down during the event?
Answer: we used an ACK-based state machine. The orchestrator published a purge request event to a persistent Kafka topic. Each service had to process the delete and then publish a purge confirmed event back. If a service was down, the message remained in the queue. The orchestrator tracked the state and would not mark the user as fully purged until it received all 12 confirmations.
Follow-up 3, Level 5 or Level 6 senior depth. Moving from a 1-week estimate to a 4-week project is a huge jump. How did you manage the expectations of the legal team who were waiting for this compliance feature?
Answer: I moved from time to integrity. I showed legal that the 1-week solution only offered partial deletion, which left them legally exposed. I framed the 4-week plan as the only version that would survive a regulatory audit. By aligning the technical complexity with their legal risk, they became the strongest advocates for the extra 3 weeks of development.
Follow-up 4 Curveball. What if, despite the 4-week redesign, you still found user data in a forgotten log file 6 months later? Does that mean your Saga architecture failed?
Answer: it means the architecture worked for known dependencies, but our discovery was still incomplete. I would treat that as a SEV2 incident. I would not just delete the log. I would update our data lifecycle policy to include log retention scrubbing. Engineering at scale is an iterative process of closing the gap between what we know and what we discovered.
Leadership pro tip: complexity is exponential.
Junior engineers estimate based on the happy path. Senior engineers estimate based on surface area. When you are asked about underestimating complexity, show the interviewer that you have learned to look for the hidden iceberg, distributed state, data consistency, and cross-team dependencies. Being able to stop a project to rescope is a sign of high confidence and senior leadership.
Category 7 Wrap-up: the value of accountability.
You have successfully navigated the failure and mistakes category. You have demonstrated that a senior architect is not someone who never fails, but someone who possesses the courage to own the blast radius and the engineering rigor to ensure the same mistake is never repeated. You have proven that your judgment is forged in real-world production scars.
Transition from reflection to resolution.
Owning a past mistake proves your character, but solving a current, high-stakes technical crisis proves your capability. When systems break at scale, they rarely break in obvious ways. This brings us to Category 8, problem solving, where we move from the what and the who to the deep technical how.
Check the comments section or description of this video. I have given a link to download a magical bundle that teaches you to develop Google Caliber thinking and provides a complete mental model in a way that screams Google SRE. This bundle is the only end-to-end system that teaches you to think, act, and communicate like a Google SRE before you even set foot in the interview. It is the only structured playbook for Google's impossible rounds like NALS and troubleshooting. Most candidates sound like outsiders. The magic of this bundle makes you sound like you already work at Google. Cracking the Google SRE interview is one of the toughest challenges in tech. Most resources only prepare you for parts of the process, a few coding problems here, some system design notes there. But Google's SRE loop is multidimensional. It tests how you think, act, and communicate. Imagine preparing with scattered LeetCode problems, random design blog posts, and still wondering how to survive the NALS round. That's how most candidates prep: fragmented, incomplete, and unstructured.
Now, imagine having one complete system.
Imagine instead you had one system that gave you everything.
A system that gives you
1. End-to-end coverage of every single round. 2. Playbooks that turn chaos like NALS and troubleshooting into structure. 3. Realistic practice drills that simulate the actual interview loop. 4. Insider language and frameworks that make you sound like you already belong. That's what this bundle does. It's not just prep material, it's a game changer because it transforms the way you think, act, and communicate into the exact style Google interviewers are looking for.
The Google SRE interview bundle covers
1. Recruiter screen and resume prep, tailored templates and scripts that pass the first filter. 2. Coding rounds, Python and Go question and answers designed for SRE-style reliability tasks. 3. System design and NALS, playbooks for both high-level design and Google's infamous NALS round. 4. Troubleshooting and debugging, a step-by-step handbook to master war room-style scenarios. 5. Behavioral and Googliness, real reliability scenarios that make you sound like you already work at Google. 6. Post-interview and hiring committee, an insider breakdown of how decisions are made. 7. Salary negotiation, recruiter-proof scripts and strategies to maximize your offer confidently. If LeetCode is practice mode, this bundle is the real game simulation. It doesn't just prepare you for questions. It prepares you to think, act, and communicate like a Google SRE before you even set foot in the interview.
Category 8, Problem Solving.
In FAANG interviews, problem solving is not about solving a LEET code puzzle. It is about architectural forensics. Interviewers want to see how you decompose a complex, ambiguous system failure into its constituent parts, how you isolate variables under pressure, and how you use observability data to find the hidden truth in your infrastructure.
Problem Solving Masterclass Scenarios.
These 11 scenarios evaluate your analytical depth and your ability to debug complex distributed systems. 62. Tell me about the hardest technical problem you solved. 63. Describe a complex problem you had to break down. 64. Tell me about a time you solved a problem with limited information. 65. Tell me about a time you had to troubleshoot a major issue. 66. Tell me about a time when the solution was not obvious. 67. Describe a time when you had to learn something quickly to solve a problem. 68. Tell me about a time when you solved a problem creatively. 69. Tell me about a time you identified the root cause of a critical issue. 70. Describe a time you had to debug a production incident. 71. Tell me about a time when you improved system performance or efficiency. 72. Tell me about a time you anticipated and mitigated a scalability issue. Senior engineers fix bugs. Principal architects fix the architectural flaws that allowed the bugs to exist. Question 62. Tell me about the hardest technical problem you solved. Note, interviewers use this question to evaluate your technical depth, analytical persistence, and your ability to navigate the unknown unknowns of a complex system. This is a critical signal for technical leadership and architectural forensics evaluated at organizations like Google and Amazon.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to separate engineers who follow tutorials from those who solve system-level mysteries. Avoid these traps. 1. The LEET code trap, describing a difficult algorithmic puzzle or a standard data structure implementation instead of a real-world production system failure. 2. The simple bug story, picking a problem that was solved by a simple Google search or a single-line syntax fix. 3. The magic solution, claiming the fix just occurred to you without describing the rigorous forensic process of elimination used to find it. 4. The vague hand-waving, failing to describe the specific technical internals, such as memory addresses, thread states, or network packet behavior. 5. The no systemic impact, solving a problem that only affected your local machine rather than a production-scale distributed environment.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 analytical signals. 1. Decomposition. Can the candidate break an ambiguous "it is slow" or "it is broken" signal into verifiable technical hypotheses? 2. Forensic rigor. Did they use deep observability tools like flame graphs, distributed traces, or heap dumps? 3. Technical mastery. Do they understand the low-level behavior of their stack, for example, JVM internals, kernel limits, or network protocols? 4. Pragmatism. Did they choose a fix that balanced performance, correctness, and maintainability? 5. Root cause permanence. Did they fix the architectural flaw so the problem can never return? Strong candidates prove they are technical detectives who follow data to the source.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer around a gray failure, a problem where the system is running, but behaving incorrectly under load. Situation. During a high-traffic sales event, our order processing service began experiencing flapping, intermittent 500 errors that only affected 2% of transactions, but caused permanent data inconsistency in our downstream ledger. Task. Standard monitoring showed healthy CPU and memory. I needed to isolate a non-obvious failure that was bypassing our standard error handling logic. Action. I analyzed distributed traces and discovered a race condition in our distributed locking mechanism. Under extreme concurrency, 2 worker nodes were occasionally acquiring a lock on the same record due to a clock drift in our Redis cluster. I reproduced the drift in a controlled lab, documented the failure mode, and re-engineered the process to use optimistic concurrency control with versioned records instead of heavy distributed locks. Result, we eliminated the data corruption entirely. P99 latency actually improved by 15% because we removed the lock contention bottleneck. The system successfully processed a record-breaking 5 times traffic surge the following month. Learning plus L. I learned that distributed locks are a leaky abstraction at high scale. I subsequently introduced a concurrency testing suite into our CI/CD pipeline to catch potential race conditions before they reach production. The plus L shows you turned a specialized fix into an organizational testing standard.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite analytical forensics. 1. Decomposition matched. You moved from intermittent 500 errors to identifying clock drift as the variable. 2. Forensic rigor matched. You used distributed traces in a controlled lab reproduction rather than just guessing. 3. Technical mastery matched. You demonstrated knowledge of distributed locking flaws and clock drift impact. 4. Pragmatism matched. You chose optimistic concurrency, which solved the bug while improving performance. 5. Systemic improvement matched. The concurrency testing suite in the pipeline ensures this class of error is caught automatically. This demonstrates you are an architect who can be trusted with the most complex system failures.
Follow-up 1. Clarification probe. How did you actually prove the clock drift was the issue, given that it only happened intermittently?
Answer: I added high-resolution timestamp logging to the lock acquisition events. By correlating the lock-granted logs from different nodes, I found instances where node A's timestamp was actually before node B's timestamp in the central RIDI's log, despite node B requesting the lock later. That objective timestamp overlap was the technical proof of the drift.
Follow-up 2. Level 3 or Level 4 junior depth. What specific tools did you use to analyze the distributed traces?
Answer: I used AWS X-ray combined with Jaeger. I filtered for traces where the checkout service had a high duration, but the database subsegment was fast. This allowed me to ignore the database and focus entirely on the time spent waiting for the distributed lock service, which eventually led me to the RIDI's bottleneck.
Follow-up 3. Level 5 or Level 6 senior depth. Why did you choose optimistic concurrency over simply fixing the clock drift using NTP or a more reliable lock provider?
Answer: fixing the clock drift is a whack-a-mole strategy. You can minimize drift, but in a distributed system, you can never guarantee zero drift. Optimistic concurrency is a more defensive architecture. By using version numbers in the database, the system remains correct even if the clocks or the locks are perfectly misaligned. I chose the solution that was architecturally robust rather than operationally fragile.
Follow-up 4. Curveball. Optimistic concurrency can lead to many write conflicts and retries if multiple people edit the same record. Did this cause a new performance problem?
Answer: that was the primary trade-off. We analyzed the write density and found that 99.9% of users only ever edit their own profile. The probability of a collision was near zero. By choosing a design that matched our real-world access patterns, we gained 99.9% performance speedup, while only penalizing the 0.1% of users with a simple automated retry.
Leadership pro tip. Hard problems are hidden constraints.
The hardest problems aren't about complex algorithms. They are about leaky abstractions, situations where the underlying infrastructure, like a clock or a network, breaks the assumptions of your code. When answering this question, do not just talk about the code. Talk about the infrastructure, the physics, and the data patterns that made the problem truly difficult. Question 63. Describe a complex problem you had to break down. Note: interviewers use this question to evaluate your analytical methodology and mental clarity when facing high-entropy distributed systems. This is a primary signal for architectural leadership at companies like Meta and Google, where you must decompose multi-layered failures into actionable engineering tasks.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to identify candidates who lack a structured approach to complexity. Avoid these traps. 1. The analysis paralysis, describing how you spent weeks studying a problem without taking incremental steps to isolate the variables. 2. The trial and error method, explaining how you randomly tried different fixes until one worked. This shows a lack of scientific rigor. 3. The symptom chaser, focusing entirely on fixing the surface-level error, the fire, without ever investigating the underlying system flaw, the fuel. 4. The silo thinker, decomposing a problem only within your own service while ignoring the upstream and downstream dependencies that actually caused it. 5. The unstructured narrative, ramming through a long, confusing story that leaves the interviewer more confused than when you started.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 decomposition signals. 1. Taxonomy of failure. Can the candidate categorize the problem, for example, network versus application versus database? 2. Variable isolation. Did they use a divide and conquer approach to rule out components? 3. Tooling proficiency. Did they leverage the right forensic artifacts, distributed tracing, flame graphs, VPC flow logs? 4. Stakeholder clarity. Could they summarize the complex technical mess into a clear status update for leadership? 5. Systemic generalization. Did they apply the lesson to a broader class of problems? Strong candidates show they use a mental framework to solve problems, not just effort.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, show how you managed high-entropy complexity with a structured methodology. Situation. Following a major release, our global account dashboard latency spiked from 200 milliseconds to 4 seconds for our high-value enterprise users. We had 50 different microservices involved in the request path, and every team claimed their service was healthy. Task. I was the staff engineer tasked with breaking down this distributed mystery and identifying the root cause before the customer churn escalated. Action. I applied a top-down decomposition. First, I used Jaeger distributed tracing to isolate the specific span causing the delay, which led to our permission service. I then mirrored production traffic into a staging environment to isolate the service. I ran a resource profiling session on the Java heap and found an N+1 query pattern hidden inside a newly added ORM abstraction that only triggered when a user had more than 500 sub-accounts. Result, I refactored the permission check into a single batch query. Latency for enterprise users immediately dropped to 150 milliseconds, better than the original baseline. We saved the high-value accounts and restored system stability. Learning +L. I realized our service level objectives slow, only monitored averages, hiding the enterprise user outliers. I implemented a P99.9 alerting policy and introduced a mandatory N+1 query linter into our CI/CD pipeline to catch inefficient ORM usage early. The +L proves you fixed the observability gap and the code gap simultaneously.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite technical decomposition. 1. Taxonomy of failure matched. You identified this as a distributed latency issue rather than a simple code bug. 2. Variable isolation matched. You used a top-down approach, ruling out 49 services until you isolated the permission service. 3. Tooling proficiency matched. You used Jaeger traces and heap profiling to see through the ORM abstraction layer. 4. Stakeholder clarity matched. You moved from everything is slow to enterprise users are hitting a specific N+1 query bottleneck. 5. Systemic generalization matched. The +L step, P99.9 alerting and CI linting, solve the class of performance decay globally. This shows you can be dropped into a house on fire and find the gas leak with surgical precision.
Follow-up 1, clarification probe. You mentioned mirroring production traffic. How did you do that without violating user privacy or PII data residency?
Answer, we used a traffic shadowing pattern. We stripped all PII and sensitive headers at the edge using a specialized proxy. We only mirrored the request structure and the volume of identifiers. This allowed us to replicate the exact concurrency and data depth that triggered the bug in staging, without ever moving real user data into a lower environment.
Follow-up 2, Level 3 or Level 4 junior depth. How did the N+1 query actually manifest in the Java heap profile?
Answer, it showed up as a massive allocation of short-lived objects, specifically hundreds of thousands of SQL prepared statement objects and small result sets. While the memory was not leaking, the garbage collector was constantly running minor GCS to clean up these objects, which added to the overall request latency. The profiler confirmed the CPU was spending 40% of its time in GC pauses.
Follow-up 3, Level 5 or Level 6 Senior Depth. Why did you choose a batch query refactor over simply adding a cache layer to the permission service?
Answer: adding a cache is a band-aid that adds new risks, like cache invalidation and memory pressure. The root cause was a fundamental design flaw. The service was making sequential network calls for a bulk operation. A batch query solved the problem at the source of truth, the database, which is always more robust than adding an external stateful layer like a cache. You should only cache what you cannot compute efficiently.
Follow-up 4, Curveball. What if the database team refused to allow the batch query because they feared a long-running transaction would lock the user table?
Answer: I would provide them with a query plan and benchmark data. I would show that one batch query selecting 500 rows using a primary key is significantly lighter on the database engine than 500 individual connection handshakes and small selects. If they still resisted, I would offer to chunk the batch, for example, 50 rows at a time, as a middle ground to satisfy their locking concerns, while still achieving an 80% latency reduction.
Leadership Pro Tip: the 50/50 rule of breakdown.
When breaking down a complex problem in an interview, spend 50% of your time explaining how you narrowed the scope. Interviewers are less interested in the fix than in your process of elimination. Show them that you have a mental flowchart for debugging. If you can explain how you ruled out 95% of the system in 2 minutes, you have already won the interview. Question 64. Tell me about a time you solved a problem with limited information. Note: interviewers use this question to evaluate your technical intuition and your ability to apply hypothesis-driven debugging in blind environments. This is a critical signal for staff engineers at companies like Amazon and Netflix, who must stabilize systems even when telemetry is missing, corrupted, or unavailable.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to find engineers who freeze when the dashboard is empty. Avoid these traps. 1. The waiting room mentality, explaining how you waited for another team to fix the logging or provide more data while the system was failing. 2. The speculative shooter, describing a series of random guesses and configuration changes made without a logical hypothesis. 3. The blindness, spending the interview complaining about the lack of tooling rather than demonstrating how you worked around it. 4. The luck factor, attributing the solution to stumbling upon the fix by accident rather than a deductive process of elimination. 5. The passive observer, noticing a discrepancy but failing to act because you did not have enough proof to justify an intervention.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 architectural intuition signals. 1. Hypothesis generation. Did the candidate create a logical list of potential failure points based on first principles? 2. Deductive reasoning. Did they use proxy metrics, indirect evidence, to rule out system components? 3. Risk-aware action. Did they take safe, incremental steps to gather more data in production? 4. Composure. Did they maintain a structured approach despite the high-stakes blind environment? 5. Observability debt. Did they treat the lack of information as a systemic bug and fix it permanently? Strong candidates prove that intuition is just fast pattern matching based on deep experience.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, show how you use deductive logic to solve a silent failure. Situation: our asynchronous order fulfillment pipeline started dropping roughly 1% of orders. Crucially, there were 0 error logs in the application, and the database showed no failed transactions. The data was simply vanishing. Task: I needed to find a ghost in the machine with 0 direct error telemetry. My goal was to identify the leak before the cumulative revenue loss reached a critical threshold. Action: I hypothesized the failure was happening between services. Since application logs were green, I looked at proxy metrics. I compared the bytes sent from our load balancer to the TCP packets received at our API gateway. I noticed a tiny discrepancy that correlated with our 1% loss. I manually triggered a packet capture, TCP dump, on a single node, and discovered that a security group egress rule was intermittently dropping packets due to a misconfigured MTU size for our cross-region VPN. Result: I adjusted the MTU, maximum transmission unit, settings globally. The order drop rate fell to 0 immediately. We recovered the missing orders from the network retry buffers. Learning plus L. I realized that our observability was only layer 7 application focused. I subsequently implemented network-level synthetic probing to monitor packet loss and MTU fragmentation across all VPC boundaries. The plus L proves you fixed the blindness by adding a new layer to the observability stack.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite deductive forensics. 1. Hypothesis generation matched. You correctly deduced that if the app logs were green, the failure must be in the network plumbing. 2. Deductive reasoning matched. You used bytes sent versus packets received as proxy metrics to prove the network was the culprit. 3. Risk-aware action matched. You used a targeted TCP dump on a single node to gather evidence without risking the entire cluster. 4. Composure matched. You followed the data from the load balancer down to the packet level in a structured sequence. 5. Observability debt matched. The plus L step, network synthetic probing, ensured the team would never be blind to MTU issues again. This demonstrates that you do not need a dashboard to tell you what is wrong.
Follow-up 1. Clarification probe. You mentioned MTU size. How does a simple packet size difference cause 1% of data to vanish without an error?
Answer: it is a classic networking gray failure. Most packets were small and passed through fine. However, 1% of our orders, specifically those with large customer metadata, created packets larger than the VPN's 1,500 byte limit. Because ICMP was blocked, the network could not tell the sender to fragment the packet. The packet was dropped silently at the wire level, so the application never even knew the request arrived.
Follow-up 2. Level 3 or Level 4 junior depth. Why did you use TCP dump instead of just looking at the cloud provider's network logs?
Answer: cloud-native logs, like VPC flow logs, are often aggregated and delayed by several minutes. They show that traffic flowed, but they do not show the internal packet structure or the fragmentation flags. I needed raw, real-time packet inspection to see the do not fragment bit being ignored by the gateway. TCP dump provided the ground truth that high-level logs missed.
Follow-up 3. Level 5 or Level 6 senior depth. How do you decide when a system is observable enough? We cannot log every single packet at scale due to cost.
Answer: I use the value of information framework. We do not log everything. We log boundary transitions. I ensure we have high-fidelity telemetry at every point where a request crosses a trust or technology boundary. For example, Internet to LB, LB to mesh, mesh to pod. If the counts match at the boundaries, the internals are usually fine. This allows us to maintain 100% visibility while only paying for 5% of the data volume.
Follow-up 4. Curveball. What if your TCP dump did not show any dropped packets and the network appeared perfect? What would have been your next hypothesis?
Answer: I would have pivoted to the client side. I would have investigated our CDN logs or our front-end telemetry, RUM. My next hypothesis would be that the client's browser was terminating the connection prematurely due to a timeout setting that was shorter than our backend processing time. If the server does not see the request and the network is clean, the error is likely happening before the request leaves the user's device.
Leadership pro tip. Trust the physics, not the logs.
When logs are missing, senior architects return to first principles, the laws of physics. Data must travel over a wire, occupy memory, and consume CPU. If the logs say success but the data is not there, look at the physical transitions, the network interfaces, the kernel buffers, and the disk I/O. The logs are just an opinion. The system metrics are the fact. Question 65. Tell me about a time you had to troubleshoot a major issue. Note: interviewers use this question to evaluate your composure under fire, your systematic approach to high-stakes incidents, and your ability to lead a recovery effort when millions of dollars are on the line. This is a primary signal for SRE and staff architect roles at companies like Amazon and Google.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to identify engineers who panic or lack a structured methodology. Avoid these traps. 1. The keyboard commando, jumping into the terminal to try random fixes without communicating with the team or following an incident command structure. 2. The symptom killer, restarting servers to fix a problem temporarily without ever identifying the root cause of why they were failing. 3. The blame game, describing the incident in a way that points fingers at another team's bad deploy rather than focusing on the recovery. 4. The zero documentation, successfully fixing the issue but failing to produce a blameless post-mortem or an update to the runbooks. 5. The tunnel vision, focusing on a single technical detail while the entire business flow remains offline for customers.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 incident management signals. 1. Composure. Did the candidate remain structured and analytical during a mission-critical outage? 2. Methodology. Did they follow a logical isolation path? For example, is it the DB, the network, the app? 3. Communication. Did they act as a bridge between technical responders and business stakeholders? 4. Mitigation first. Did they prioritize restoring the user experience before chasing the root cause? 5. Post-mortem integrity. Did they implement a systemic fix to ensure the incident can never repeat? Strong candidates prove they are an asset in a war room environment.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, describe a cascading failure, a complex incident where the system's own safety mechanisms made the problem worse. Situation. During our peak morning traffic window, a minor regional database slowdown triggered a global cascading failure. Healthy pods began failing their readiness checks and were being terminated by Kubernetes, which then overloaded the remaining nodes, causing a total platform blackout. Task. I assumed the role of incident commander to stop the automated pod deletion cycle and restore global availability while the CTO was demanding a status update. Action. I did not try to fix the database first. I recognized the thundering herd pattern. I ordered an immediate freeze on all health check-based terminations and deployed an emergency rate limit at the API gateway to drop 20% of non-critical traffic. This allowed the surviving nodes to stabilize. Once the load was manageable, I identified that the database slowdown was caused by a leaked connection pool in a sidecar service. Result, we restored 100% availability for checkout traffic within 15 minutes. Global service was fully restored in 40 minutes with zero data corruption. Learning +L. I learned that our health checks were too aggressive. I led a project to implement exponential health check jitter and introduced automatic load shedding protocols so the system would degrade gracefully instead of collapsing. The +L proves you optimize the system's survival instinct for the future.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite incident leadership. 1. Composure matched. You identified the thundering herd and cascading failure patterns while the platform was blacked out. 2. Methodology matched. You prioritized the surviving nodes before investigating the database slowdown. 3. Communication matched. You managed the incident command role and provided a path to recovery for the CTO. 4. Mitigation first matched. You used rate limiting at the edge to stop the bleeding and allow the cluster to breathe. 5. Post-mortem integrity matched. The implementation of load shedding and health check jitter fixed the systemic vulnerability. This demonstrates that you are a high-value leader who brings order to technical chaos.
Follow-up 1. Clarification probe. During the 15 minutes of blackout, how did you keep the non-technical leadership informed without slowing down the technical investigation?
Answer. I explicitly decoupled the roles. I assigned a communication lead from the SRE team, whose sole job was to update the internal status page and brief the CTO every 5 minutes. This allowed me and the diagnostic engineers to focus entirely on the traffic shaping and database logs without being interrupted by executive requests for updates.
Follow-up 2. Level 3 or Level 4 junior depth. Technically, how did the health check make the problem worse in this specific instance?
Answer. Our Kubernetes readiness probes were too strict. When the database slowed down, the pods took longer to respond. K8 seconds marked them as unhealthy and stopped sending them traffic. This shifted 100% of the load onto the remaining healthy pods, which immediately crashed under the 10-time surge. It was a classic feedback loop, where the system's attempt to be healthy actually guaranteed total failure.
Follow-up 3. Level 5 or Level 6 senior depth. You chose to drop 20% of traffic. How did you decide which traffic was non-critical enough to sacrifice during the crisis?
Answer: I followed our predefined business criticality map. We dropped the analytics beacon and recommendation engine traffic first. These are nice-to-have features. We prioritize checkout and identity traffic. At a staff level, you must have the business context to know that a 20% drop in analytics is a minor data gap, but a 20% drop in checkouts is a direct loss of revenue.
Follow-up 4, curveball. What if your rate limiting at the edge did not work and the nodes kept crashing? What was your plan C?
Answer: Plan C would have been a static failover. I would have redirected 100% of traffic to a static maintenance page hosted on S3/CloudFront. This would completely sever the connection between the internet and our backend. It is the most aggressive move, but it protects the database from permanent corruption or deadlocks while we manually clear the connection pools and reset the cluster state.
Leadership pro tip: do not be the hero.
Junior engineers try to fix the bug themselves to be the hero. Senior architects realize that during a major outage, the goal is orchestration. Your value is not in how fast you type commands. It is in how fast you organize a team of 10 people to look at 10 different things simultaneously. Effective troubleshooting is an organizational exercise, not just a technical one. Question 66. Tell me about a time when the solution was not obvious. Note: interviewers use this question to evaluate your technical persistence and your ability to look past surface-level symptoms. This tests the dive deep and invent and simplify signals, as elite engineers at companies like Google and Netflix are expected to solve problems where standard documentation and best practices fail to provide an answer.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to filter out candidates who rely on luck or trial and error. Avoid these traps. 1. The obvious bug, picking a problem that was clearly visible in the logs from the start, which makes you look unobservant. 2. The magic fix, saying you just had a feeling or found the solution by accident without a logical trail of evidence. 3. The restart strategy, claiming the solution was a simple reboot or clearing a cache, which only hides the problem temporarily. 4. The tutorial solution, describing a problem that was solved by simply following a Stack Overflow post or a standard manual. 5. The surface diagnosis, failing to explain the low-level mechanics of why the problem was happening, for example, not mentioning threads, memory, or network packets.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 analytical signals. 1. Evidence-based deduction. Did the candidate use data to rule out the most obvious causes? 2. Technical curiosity. Did they explore layers beneath the application code, for example, OS kernel runtime? 3. Variable isolation. Did they perform controlled experiments to verify their hypothesis? 4. Persistence. Did they continue investigating when the initial safe fixes failed to work? 5. Structural resolution. Did the final non-obvious fix improve the system's fundamental design? Strong candidates prove that technical intuition is built on a foundation of scientific rigor.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, describe a ghost in the machine, a performance bottleneck caused by a hidden runtime interaction. Situation: our high-throughput message ingestion service started hitting 100% CPU utilization on all nodes every day at exactly 2 p.m. Crucially, our traffic logs showed no increase in request volume during that window. Task: I needed to identify a non-obvious CPU consumer that was bypassing our standard request-level monitoring and threatening the cluster's stability. Action: I ruled out the obvious candidates, cron jobs and background syncs, as null were scheduled for that time. I ran a low-level profiling session using a sync profiler to capture CPU flame graphs during the 2 p.m. spike. I discovered that a recently updated JSON serialization library was triggering a massive amount of reflection metadata lookups. This only happened when a specific, rare third-party payload arrived, causing the CPU to thrash in garbage collection while trying to manage millions of short-lived metadata objects. Result: I implemented a custom serializer that avoided reflection entirely. The daily CPU spike vanished, and we reduced our baseline CPU usage by 25% across the entire cluster. Learning +L. I learned that third-party library updates can introduce hidden complexity that standard integration tests miss. I subsequently introduced heap allocation benchmarking into our performance pipeline to detect object creation spikes before they reach production. The +L proves you fixed the testing blind spot that allowed the non-obvious issue to occur.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite technical problem solving. 1. Evidence-based deduction matched. You ruled out traffic spikes and cron jobs using logs before diving deeper. 2. Technical curiosity matched. You moved beyond the application logic to look at the reflection behavior of the library. 3. Variable isolation matched. You used flame graphs to pinpoint the exact code path responsible for the CPU thrashing. 4. Persistence matched. You did not just increase CPU limits. You stayed with the problem until you found the runtime root cause. 5. Structural resolution matched. The +L step, heap allocation benchmarking, added a new layer of protection to the CI pipeline. This demonstrates that you solve problems at the architectural level, not just the code level.
Follow-up 1 clarification probe. If the traffic did not increase, why did the CPU spike happen at the exact same time, 2 p.m., every day?
Answer: that was the most confusing part. We eventually traced it back to an upstream partner's scheduled batch job. Every day at 2 p.m., they sent us a specific type of audit payload. The volume was small, only a few hundred requests, but because those specific payloads triggered the inefficient reflection logic in our library, those few hundred requests were enough to consume 100% of our CPU capacity.
Follow-up 2, Level 3 or Level 4 junior depth. Can you explain what reflection is and why it was making the CPU spike so high?
Answer: reflection allows a program to inspect its own structure at runtime. In this case, every time the library received the audit payload, it was searching for class metadata to figure out how to map the JSON fields. This is very CPU intensive. Because it was doing this millions of times per second inside a loop, the CPU spent all its time looking up metadata instead of actually processing data.
Follow-up 3, Level 5 or Level 6 senior depth. Instead of writing a custom serializer, why did not you just roll back the library update to the previous working version?
Answer: a rollback was my plan A. However, the library update was required for a critical security patch, CVE, that fixed a remote code execution vulnerability. Rolling back would have left us insecure. The only architect-level choice was to move forward by fixing the performance regression while keeping the security patch in place. This required the custom serializer implementation.
Follow-up 4 Curveball. What if you had implemented the custom serializer, but the CPU spike still did not go away? What would have been your next step?
Answer: I would have moved from the runtime layer down to the kernel layer. I would have used perf to look for context switches, or I or O wait states. My next hypothesis would be that the audit payloads were causing an interrupt storm at the network interface card, NIC level, perhaps due to a specific packet size or buffer configuration. When the obvious and the non-obvious code fixes fail, the answer is always in the underlying physics of the infrastructure.
Leadership pro tip. Obvious problems are symptoms.
When a problem seems obvious, it usually means you are looking at a symptom. For example, the DB is slow. When a problem is non-obvious, you are usually looking at an interaction, two correct things behaving incorrectly when they touch, for example, a library and a specific data type. Senior architects solve interaction problems. To do this, you must master your observability tools so you can see through the abstractions of your code. Question 67. Describe a time when you had to learn something quickly to solve a problem. Note: interviewers use this question to evaluate your learning agility, technical curiosity, and ability to stabilize mission-critical systems using unfamiliar technology under intense pressure. This is a vital signal at companies like Google and Meta, where engineers must often dive into specialized infrastructure or legacy systems they did not build.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to filter out candidates who are slow to adapt or learn at a surface level. Avoid these traps. 1. The tutorial learner, describing a time you just watched a video or read a manual without applying the knowledge to a high-stakes problem. 2. The copy-paste solution, admitting you just copied a script from Stack Overflow or ChatGPT without actually understanding the underlying mechanics. 3. The slow ramp-up, describing a learning process that took weeks for a problem that required a 24-hour resolution. 4. The academic interest, learning something interesting but failing to translate that knowledge into a measurable business or technical result. 5. The instruction-dependent candidate, needing a senior mentor to walk you through every step instead of demonstrating independent, rapid research skills.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 learning agility signals. 1. Synthesis speed. How quickly can the candidate move from zero knowledge to a working technical hypothesis? 2. Resourcefulness. Did they find the source of truth, for example, source code, kernel docs, rather than just surface-level blogs? 3. Application under pressure. Did they use the new knowledge to solve an active production or project crisis? 4. Systemic depth. Did they learn the why, the mechanics, rather than just the how, the syntax? 5. Knowledge transfer. Did they document or teach what they learned so the team grew with them? Strong candidates prove they are self-winding engineers who can solve anything with enough documentation.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, describe learning a specialized lower-level technology to solve an elite engineering problem. Situation: our Kubernetes cluster started experiencing random 500 milliseconds network latency spikes. Standard observability tools like Datadog and VPC flow logs showed that packets were leaving the app but not reaching the load balancer, yet no firewall rules were blocking them. Task: I suspected a silent drop inside the Linux kernel's networking stack. I had zero experience with low-level kernel tracing, but I needed to find the drop point within 48 hours to prevent a full platform rollback. Action: over a single night, I performed an intensive deep dive into eBPF, Extended Berkeley Packet Filter, and the PRU, Packet Where Are You tool. I learned how to write a targeted eBPF program to trace the lifecycle of a packet through the kernel's network hooks. I deployed the probe to a single node and discovered that a specific container network interface, CNI, plugin was dropping packets during route table updates. Result: I identified the exact line in the CNI source code causing the race condition. We implemented a temporary kernel-level workaround and contributed the fix back to the open-source CNI project. Latency returned to the 5 milliseconds baseline. Learning plus L. I learned that observability must include the kernel layer for cloud-native apps. I subsequently authored an eBPF tracing playbook and trained our SRE team on using eBPF for forensic network analysis. The plus L proves you did not just solve one outage. You added a new superpower to the entire organization.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite rapid learning and application. 1. Synthesis speed matched. You moved from zero eBPF knowledge to a deployed kernel probe in under 24 hours. 2. Resourcefulness matched. You moved beyond application logs to the Linux kernel source code and specialized tracing tools. 3. Application under pressure matched. The learning was directly tied to stopping a platform-wide network failure. 4. Systemic depth matched. You did not just restart the pods. You learned the PRU mechanics to see the internal kernel drop point. 5. Knowledge transfer matched. The plus L step, the eBPF playbook, institutionalized your new skill across the SRE team. This shows you are an engineer who can handle the unknowns of a high-growth tech company.
Follow-up 1. Clarification probe. How did you manage to learn something as complex as eBPF and kernel tracing in just one night?
Answer: I did not try to learn everything about eBPF. I used a goal-oriented learning approach. I focused specifically on kernel packet drop tracing. I identified the most relevant tool, PRU, read the implementation notes to understand how it hooked into the K-probes, and tested it on a local VM before touching production. Efficient learning at scale is about isolating the 20% of knowledge that solves 80% of the problem.
Follow-up 2. Level 3 or Level 4 junior depth. Why did you use eBPF instead of just using TCP dump or logging every network request?
Answer: TCP dump is a layer 2 tool. It tells you if a packet is on the wire, but it will not tell you why the kernel decided to drop it. Logging every request was impossible due to the 50,000 requests per second volume. It would have caused a secondary outage. eBPF is programmable observability. It runs inside the kernel with near zero overhead, allowing us to see the internal state of the networking stack without slowing down the traffic.
Follow-up 3, Level 5 or Level 6 senior depth. Contributing a fix back to an open-source project takes time. How did you balance that with your internal team's roadmap priorities?
Answer: I framed the open source contribution as long-term maintenance reduction. If we only fixed it locally, we would have to maintain a custom, forked version of the CNI forever, which adds a massive technical debt tax to every upgrade. By spending 2 days to merge the fix upstream, we ensured that future versions of the tool would be safe by default, saving us hundreds of engineering hours in the future.
Follow-up 4, Curveball. What if you had spent the whole night learning eBPF, but the next morning you realized it was actually a simple application-level timeout? Would that have been a waste of time?
Answer: no. In a complex outage, ruling out a variable is just as valuable as finding the root cause. If eBPF had shown the kernel was clean, I would have had the definitive proof needed to shift the entire team's focus to the application layer. Furthermore, the skill of eBPF tracing is now a permanent part of my architectural toolkit. In engineering, deep knowledge of the stack is never a waste. It simply makes the next investigation faster.
Leadership Pro Tip. Learning is a defensive strategy.
Junior engineers learn for interest. Senior engineers learn for impact. When an interviewer asks about learning quickly, show them your knowledge extraction process. Prove that you can dive into a black box, identify the source of truth, and translate that new knowledge into a production fix. Being the person who can learn the kernel makes you the most valuable asset in the room during a crisis. Question 68. Tell me about a time when you solved a problem creatively. Note: interviewers use this question to evaluate your lateral thinking and resourcefulness. For senior roles at companies like Netflix and Meta, creativity does not mean writing complex or clever code. It means finding high-leverage, non-obvious solutions that bypass traditional constraints like budget, time, or system limitations.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to filter out candidates who confuse creativity with unreliable hacks. Avoid these traps. 1. The hacky solution, describing a fix that solved the problem but introduced massive technical debt or made the system impossible to maintain. 2. The clever code bias, boasting about using a complex, obscure language feature or rejects that no one else on the team could understand. 3. The over-engineered fix, building a massive new system from scratch when a simple configuration change or repurposing existing tools would have worked. 4. Lack of testing, describing a creative solution that was deployed without rigorous validation, showing a disregard for production safety. 5. The solo inventor narrative, failing to mention how you validated your creative idea with peers or stakeholders before implementation.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 resourcefulness signals. 1. Lateral thinking: did the candidate look outside the immediate problem space for a solution? 2. Resourcefulness: did they repurpose existing infrastructure or data to solve the issue without new costs? 3. Constraint awareness: did the creative move respect the existing boundaries of security, latency, and budget? 4. Pragmatism: was the solution easier or faster than the standard approach? 5. Systemic impact: did the creative solution provide a new capability for the entire organization? Strong candidates prove that creativity is the shortest path between a problem and a result.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, describe using an existing tool in a non-obvious way to solve a critical scale bottleneck. Situation: our legacy authentication service was the single point of failure for our global platform. During a viral marketing event, the service's CPU hit 100% due to a massive surge in token validation requests, threatening to take the entire site offline. Task: the standard fix was to scale the backend nodes, but we were already at our database connection limit. We had no time for a rewrite, and we could not buy more capacity in 15 minutes. Action: I realized we did not need the backend to validate tokens for every request. I implemented a creative offload using our CDN, Content Delivery Network. I wrote a lightweight edge worker that used the CDN's compute layer to validate JWT, JSON Web Token signatures at the network edge. I used a cryptographic hint stored in the user's cookie to allow the edge to verify authenticity without ever making a network call back to our struggling origin server. Result: we offloaded 85% of the authentication traffic to the global edge. Origin CPU usage dropped from 100% to 30% instantly. We survived the traffic surge with zero downtime and actually reduced our overall compute costs. Learning plus L. I learned that the best way to scale a bottleneck is to move the work as close to the user as possible. I later championed a compute at the edge strategy for all read-heavy validation tasks across the company. The plus L proves you turned a tactical save into a long-term architectural shift.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite architectural resourcefulness. 1. Lateral thinking matched. Instead of looking at the backend code, you looked at the network edge (CDN) to solve a CPU problem. 2. Resourcefulness matched. You used the existing CDN compute layer, which was already paid for, to act as a security firewall. 3. Constraint awareness matched. Your cryptographic hint approach maintained security while eliminating the network call bottleneck. 4. Pragmatism matched. You solved a catastrophic scaling issue in minutes without a single database or backend change. 5. Systemic impact matched. The plus L step, compute at the edge strategy, changed how the entire org handles high-scale validation. This demonstrates that you are an architect who can find hidden capacity in the system.
Follow-up 1. Clarification probe. If the CDN validated the tokens at the edge, how did you handle token revocation, for example, if a user logged out early?
Answer: that was the critical design trade-off. Since the edge validation was stateless, it could not see the revocation list in our database. We compromised by setting a very short 5-minute window for the edge-validated hint. If a user logged out, their access would persist at the edge for a maximum of 300 seconds. For a marketing event, the business agreed this 5-minute risk window was far better than a total site outage.
Follow-up 2. Level 3 or Level 4 junior depth. Technically, how does an edge worker validate a JWT signature without access to the private key stored on the server?
Answer: we shared the public key with the CDN. Since JWTs are signed using asymmetric cryptography, RSA or EXA, the edge worker only needs the public key to verify that our server originally issued the token. We kept the private key safe on our internal HSM, hardware security module. This allowed the edge to be smart about validation without ever being a security risk for token generation.
Follow-up 3. Level 5 or Level 6 senior depth. Running compute at the edge can be expensive in terms of request tax. Did you analyze the cost impact of moving logic from free EC2 nodes to metered edge workers?
Answer: I did a quick back-of-the-envelope calculation. While the edge worker costs $0.60 per million requests, the cost of an outage was estimated at $10,000 per minute in lost revenue. Furthermore, by offloading the work, we were able to scale down 20 backend EC2 instances, which actually resulted in a net cost reduction of roughly 15%. At a staff level, I always balance the compute cost against the opportunity cost of an outage.
Follow-up 4. Curveball. What if the security team blocked your edge validation idea because they did not trust the CDN provider to handle our cryptographic keys?
Answer: I would not bypass the security team. Instead, I would propose a degraded security mode. I would ask them, can we allow edge validation only for read requests during this 2-hour traffic window, while keeping all write requests routed to the secure origin? By limiting the scope of the creative fix to non-sensitive data, I can usually find a middle ground that satisfies both the security team's risk appetite and the business team's availability requirements.
Leadership pro tip. Creativity is constraint management.
Junior engineers think creativity means doing something new. Senior architects know creativity means doing something different with what you already have. When asked this in an interview, do not talk about a new library you downloaded. Talk about how you used the wrong tool, like a CDN or a load balancer, to solve the right problem, like CPU load or latency. That lateral thinking is what proves you are ready for staff-level leadership. Question 69. Tell me about a time you identified the root cause of a critical issue. Note: interviewers use this question to evaluate your technical forensic skills and your ability to look past symptoms to find the architectural fuel behind a failure. This is a primary signal for the dive deep and problem-solving competencies evaluated at companies like Google and Amazon.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to filter out engineers who only fix surface-level symptoms. Avoid these traps. 1. The symptom swapper, identifying a symptom, for example, the DB was slow, and calling it the root cause. A senior engineer asks why the DB was slow. 2. The correlation fallacy, claiming a root cause was found because a metric changed at the same time without technical proof of a causal link. 3. The blame game, identifying human error by a specific person as the root cause. Elite architects identify the systemic failure that allowed the human error to occur. 4. The incomplete resolution, describing a root cause but failing to implement a permanent, automated guardrail to prevent it from ever happening again. 5. The narrow lens, investigating only your own code while ignoring the network, kernel, or database layers that were actually failing.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 forensic signals. 1. Logical deduction. Did the candidate use a structured 5 whys approach or a process of elimination? 2. Tooling mastery. Did they leverage deep stack observability, for example, profiling, packet inspection, heap analysis? 3. Causal proof. Did they perform a controlled reproduction to prove the root cause beyond doubt? 4. Systemic remediation. Did they fix the architecture or the process rather than just the code? 5. Knowledge scalability. Did they publish a blameless postmortem to educate the entire organization? Strong candidates prove that finding the root cause is a science, not a guess.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, describe finding a root cause that was hidden deep beneath the application layer. Situation: our core payment orchestrator started experiencing random 2-second timeouts during peak volume. Every metric, CPU, memory, and DB latency, appeared perfectly healthy on our dashboards. Task: I was the staff architect tasked with finding the hidden bottleneck that was causing a 4% transaction failure rate and threatening our monthly revenue targets. Action: I did not trust the high-level metrics. I ran a low-level kernel profile using perf and noticed a massive spike in spin locks and context switching. I realized the root cause was not the code, but socket contention at the OS level. Our pods were hitting the Linux kernel's TCP_max_sin_backlog limit because the sidecar proxy was opening thousands of short-lived connections without reusing them. Result: I tuned the kernel parameters and implemented TCP connection pooling in the proxy layer. Latency dropped to 50 milliseconds, and the 2-second timeouts vanished entirely. We saved the revenue targets and increased our cluster throughput by 3 times. Learning plus L. I learned that our observability was cloud-only and ignored the OS layer. I subsequently introduced kernel-level telemetry into our standard Grafana dashboards and authored a TCP optimization guide for all high-scale services. The plus L shows you fixed the visibility gap that allowed the root cause to stay hidden.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite root cause analysis RCA. 1. Logical deduction matched. You looked at healthy metrics and deduced the failure was happening at a layer the dashboards were not seeing. 2. Tooling mastery matched. You used perf to look at kernel spin locks, moving beyond standard application logs. 3. Causal proof matched. You identified a specific kernel limit, TCP_max_sin_backlog, and proved the connection storm was the trigger. 4. Systemic remediation matched. You implemented connection pooling and kernel tuning, fixing the architectural plumbing. 5. Knowledge scalability matched. The plus L step, kernel-level telemetry, institutionalized this deep stack awareness for the whole team. This demonstrates that you are an architect who follows the data into the lowest layers of the system.
Follow-up 1, clarification probe. How did you decide to look at kernel spin locks when the application dashboards were green?
Answer: it was a process of elimination. If CPU and memory are low but requests are timing out, it usually means threads are waiting rather than working. I ruled out the database and the network by looking at hop latency. That left the kernel queue as the only remaining place where a packet could be stuck. Perf was the only tool capable of seeing that queue saturation.
Follow-up 2, level 3 or level 4 junior depth. Can you explain what a spin lock is and why it was causing the 2-second timeouts?
Answer: a spin lock is a low-level synchronization mechanism where a CPU core spins in a loop waiting for a resource to become available. In our case, the kernel was spinning while trying to manage the massive queue of incoming TCP handshakes. Because the CPU was busy spinning instead of processing the handshake, the requests sat in the queue until they hit the 2-second application timeout.
Follow-up 3, Level 5 or Level 6 Senior Depth. Tuning kernel parameters in a shared Kubernetes environment can be risky. How did you validate that these changes would not destabilize other services on the same node?
Answer: I did not apply the change globally. I used a canary node approach. I applied the system tuning to a single node in the cluster and used node affinity to route only a small percentage of my service's traffic to it. I monitored the noise metrics, context switches, and steal time on that node for 24 hours to ensure other tenants remained unaffected before promoting the fix to the whole cluster.
Follow-up 4, Curveball. What if your kernel tuning only fixed the problem for a week and then the timeouts returned? What would be your next step?
Answer: that would indicate that my kernel tune was just a scaling patch and not the true root cause. My next step would be to investigate the connection lifecycle in the application code itself. I would look for connection leaks where the app fails to close sockets correctly under error conditions. If the app is creating garbage at a rate faster than the kernel can clean it, no amount of tuning will solve the problem permanently.
Leadership Pro Tip. The root cause is always a choice.
Junior engineers think the root cause is the bug. Senior architects know the root cause is the choice that allowed the bug to exist. When you present an RCA in an interview, do not stop at the code fix. Explain why the monitoring failed to see it, why the testing failed to catch it, and why the architecture was vulnerable to it. Fixing the choice is what defines a leader. Question 70. Describe a time you had to debug a production incident. Note: interviewers use this question to evaluate your incident command capability and your ability to restore service under extreme pressure. At companies like Netflix and Amazon, the focus is on mitigation speed and blameless diagnostics. This is a critical signal for SRE and staff engineer seniority.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to find engineers who panic or lack structured troubleshooting. Avoid these traps. 1. The solo cowboy describing how you fix the issue in a silo without notifying stakeholders or coordinating with the on-call team. 2. The fix-first fallacy attempting to find the root cause debugging while the site is still down instead of prioritizing mitigation, restoring service. 3. The blame game, attributing the incident to someone's bad code rather than identifying the systemic or architectural gap that allowed the bug to deploy. 4. The guessing game, describing a series of random configuration changes or restarts made without a data-backed hypothesis. 5. The silent recovery, fixing the bug but failing to lead a post-mortem or update the runbooks to ensure it never happens again.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 incident management signals. 1. Composure. Did the candidate establish order and follow a structured diagnostic path during the crisis? 2. Mitigation mindset. Did they act to stop the bleeding for customers before chasing the root cause? 3. Observability depth. Did they use traces, logs, and metrics to prove their hypothesis? 4. Stakeholder management. Did they communicate clear status updates and EDA to leadership? 5. Systems correction, plus L. Did they implement a durable architectural guardrail post-incident? Strong candidates prove they are an asset in the war room, not a source of more chaos.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, describe a cascading failure, a high-stakes incident where the system's own recovery logic made the problem worse. Situation: during our annual Prime Day event, our core checkout API began returning intermittent 503 errors. Within 10 minutes, our entire microservices mesh entered a death spiral as latency climbed from 100 milliseconds to 30 seconds. Task: I assumed the role of incident commander. We were losing an estimated $10,000 in revenue per minute. I needed to stabilize the cluster and stop the automated thundering herd. Action: I identified the root cause as a retry storm. A minor database delay triggered our application SDKs to retry aggressively, which then overwhelmed our connection pools. I did not try to fix the DB. I ordered an immediate deployment of a global circuit breaker to drop all non-critical retry traffic and applied a 50% rate limit at the edge to give the database room to breathe. Result, the cluster stabilized within 8 minutes. We restored full checkout capability in 22 minutes. Total revenue impact was contained, and no data was lost or corrupted. Learning plus L. I learned that our retry logic was static and lacked jitter. I led a project to implement exponential backoff with jitter across all internal libraries and introduced automated load shedding that activates when P99 latency crosses a specific threshold. The plus L proves you converted an expensive outage into a more resilient self-healing architecture.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite production leadership. 1. Composure matched. You recognized the death spiral pattern and took the incident commander role immediately. 2. Mitigation mindset matched. You implemented a circuit breaker and rate limiting to restore service before fixing the database. 3. Observability depth matched. You used latency metrics and connection pool saturation data to identify the retry storm. 4. Stakeholder management matched. You made the hard business call to drop 50% of traffic to save the other 50%. 5. Systems correction matched. The implementation of jitter and load shedding fixed the systemic vulnerability permanently. This shows you are an architect who protects the business first and the code second.
Follow-up 1. Clarification probe. When you took the incident commander role, how did you handle the leadership team demanding constant updates while you were trying to fix the system?
Answer: I explicitly designated a communications lead from the SRE team. I told the stakeholders, I am focused on mitigation. Please direct all questions to the comm lead. They will update the status page every 5 minutes. By insulating the technical responders from the executive pressure, I allowed the team to find and fix the bottleneck 3 times faster.
Follow-up 2. Level 3 or Level 4 junior depth. Can you explain why retries were making the problem worse instead of helping?
Answer: it is a load amplification attack. If a database is slow and 1,000 clients all retry their request 3 times without waiting, you have turned 1,000 requests into 4,000 requests against a system that is already struggling. Without exponential backoff or jitter, all those retries hit at the exact same millisecond, creating a thundering herd that prevents the database from ever recovering.
Follow-up 3. Level 5 or Level 6 senior depth. Dropping 50% of traffic at the edge is a massive business risk. How did you justify that decision during the incident?
Answer: I used the sinking ship logic. We had 2 choices: keep 100% of the traffic and have 100% of it fail due to timeouts, or drop 50% and ensure the other 50% completes successfully. I prioritized authenticated checkout traffic and dropped guest browsing traffic. I framed it as, I am saving half the revenue rather than losing all of it. At a senior level, you must be willing to make surgical trade-offs to protect the core business value.
Follow-up 4. Curveball. What if your circuit breaker failed to deploy and the thundering herd continued to crash the database? What was your nuclear option?
Answer: the nuclear option would be a global traffic black hole at the DNS layer. I would temporarily point our primary domain to a static maintenance page hosted on S3. This completely severs the link between the internet and our infrastructure. It is the most painful move, but it is the only way to allow the database to clear its lock weights and IOPS backlog so we can bring the system up in a controlled, staggered manner.
Leadership pro tip. Mitigation is not a fix.
Junior engineers think an incident is over when the dashboard turns green. Senior architects know the incident is only over when the post-mortem is published and the systemic fix is in the roadmap. When answering this question, spend 20% of your time on the fix and 80% on the systemic guardrails you built afterward. That is what proves you are a long-term asset. Question 71. Tell me about a time when you improved system performance or efficiency. Note: interviewers use this question to evaluate your technical depth and your ability to optimize for the triple constraint: speed, cost, and resource utilization. For senior roles at companies like Google and Amazon, efficiency is not just about fast code. It is about the total cost of ownership and the scalability of the architecture.
Here are the critical red flags. the instant rejection signals.
Interviewers use this question to filter out engineers who perform blind optimization. Avoid these traps. 1. The micro-optimizer, focusing on a tiny code tweak like changing a loop that has zero impact on the overall system's end-to-end latency. 2. The cost-ignorant architect, improving speed by simply throwing 10 times more hardware at the problem without improving the software efficiency. 3. The metricless story, claiming the system feels faster without providing hard data like P99 latency, throughput RPS, or DPU hours saved. 4. The unstable speed, describing an optimization that made the system faster but also made it brittle or prone to race conditions. 5. The premature optimizer, optimizing a part of the system that was not the actual bottleneck, showing a lack of profiling rigor.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 efficiency signals. 1. Profiling rigor. Did the candidate use flame graphs, heap dumps, or network traces to find the true bottleneck? 2. Algorithmic and structural logic. Did they improve the fundamental way data is processed, for example, batch to stream, async, or data locality? 3. Financial intelligence. Did the optimization result in a measurable reduction in cloud compute or licensing costs? 4. Scalability headroom. Did the improvement allow the system to handle significantly more load without adding resources? 5. Observability integration. Did they add automated performance regression tracking to preserve the gains? Strong candidates prove that efficiency is a first-class architectural requirement, not an afterthought.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer around a data-driven modernization that saved time and money. Situation: our nightly financial reconciliation pipeline was taking 18 hours to process 500 million records. With 15% year-over-year data growth, we were on track to breach our 24-hour business window within 6 months. Task: I was the lead engineer tasked with re-architecting the pipeline to complete under 4 hours while reducing our $15,000 monthly Spark cluster costs. Action: I profiled the Spark DAG and identified a massive shuffle bottleneck caused by data skew on the merchant ID key. I implemented a salting technique to redistribute the keys and move the architecture from a serialized batch model to a parallelized micro-batching model using Amazon EMR serverless. I also implemented a custom Delta Lake indexing strategy to avoid full table scans. Result: the pipeline execution time dropped from 18 hours to 35 minutes, a 96% improvement. We reduced compute costs by 40% by utilizing Graviton-based spot instances and automated cluster right-sizing. Learning +L. I learned that scaling up is a linear solution to an exponential data problem. I subsequently established a performance budget for our data engineering team, requiring all new pipelines to pass a cost per million records benchmark before production deployment. The +L proves you turned a technical optimization into a financial governance standard.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite architectural efficiency. 1. Profiling rigor matched. You identified data skew in the Spark shuffle phase rather than just increasing the instance size. 2. Structural logic matched. You implemented salting and Delta Lake indexing to fix the fundamental processing physics. 3. Financial intelligence matched. You quantified the 40% cost reduction and used Graviton spot instances for ROI. 4. Scalability headroom matched. You unlocked a 96% speedup, giving the business years of growth capacity. 5. Systemic improvement matched. The +L step performance budget introduced a new financial guardrail for the entire team. This demonstrates that you are an architect who optimizes for the bottom line, not just the CPU clock.
Follow-up 1, clarification probe. You mentioned salting the merchant ID. How did that specifically solve the Spark shuffle bottleneck?
Answer: we had a power law distribution where 1% of merchants owned 50% of the transactions. In a standard shuffle, all data for one merchant goes to one Spark executor, causing that node to crash or lag, the straggler task. By salting, I added a random suffix to the keys, forcing Spark to distribute that merchant's data across all 40 nodes in the cluster. This turned a serialized bottleneck into a perfectly parallel operation.
Follow-up 2, Level 3 or Level 4 Junior Depth. How did you ensure that salting the keys did not break the final aggregation logic where you needed the total per merchant?
Answer: we used a two-stage aggregation. In the first stage, Spark aggregated the salted keys, merchant ID plus salt. In the second stage, we stripped the salt and performed a final global aggregation on the resulting small intermediate data. This map-side combine approach ensured the math remained 100% accurate while the heavy lifting was done in parallel.
Follow-up 3, Level 5 or Level 6 Senior Depth. Moving to EMR serverless and spot instances increases the risk of spot interruptions mid-job. How did you design for that reliability risk?
Answer: that was the core of the resilience requirement. I designed the pipeline to be checkpoint aware. We used Delta Lake's ACID transaction logs. If a node was interrupted, the serverless engine would spin up a new node, and the job would resume exactly from the last successful micro-batch checkpoint rather than restarting the 18-hour process. We traded a 1% chance of a retry for a 40% reduction in cost.
Follow-up 4, Curveball. What if the finance team rejected the EMR serverless migration because they did not want to change their existing fixed capacity budget model?
Answer: I would perform a TCO comparison, total cost of ownership. I would show them that while EMR serverless looks variable, the area under the curve of our spend was 40% lower than the fixed cluster, which sat idle for 6 hours a day. I would frame it as capacity on demand versus paying for air. Usually, once a CFO sees the waste of a fixed idle cluster in a chart, they approve the serverless migration.
Leadership pro tip: performance is a feature, cost is a constraint.
Junior engineers optimize for the wow factor of speed. Senior architects optimize for the business balance. When answering this question, do not just brag about how fast the system is. Brag about how much headroom you created for the company to grow without spending another dollar on infrastructure. The best optimization is the one that makes the next 3 years of growth free. Question 72. Tell me about a time you anticipated and mitigated a scalability issue. Note: interviewers use this question to evaluate your architectural foresight and your ability to prevent outages before they happen. This is a critical leadership signal at companies like Amazon and Google, where engineers are expected to build systems that scale 10 times beyond current traffic without manual intervention.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to find proactive architects versus reactive fixers. Avoid these traps. 1. The wait-and-see approach, describing a time you waited for the system to actually hit its limit before proposing a change. This shows a lack of foresight. 2. The hardware-only fix, solving a scalability bottleneck by simply throwing larger, more expensive instances at the problem rather than fixing the architectural logic. 3. The unquantified risk, stating that the system felt slow without providing hard data from load tests or capacity planning projections. 4. The siloed scaling, scaling the web layer while ignoring the fact that the database or a third-party API remained a massive single point of failure. 5. The theoretical scaling, proposing a plan but never actually executing it, which fails to prove your ability to deliver results under real enterprise constraints.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 scalability signals. 1. Foresight: did the candidate identify the bottleneck months before it became a production crisis? 2. Load testing: did they use scientific benchmarking to prove where the system would break? 3. Decoupling: did they move the architecture toward a more distributed horizontal model? 4. Resource optimization: did they improve throughput per dollar spent, or just increase the budget? 5. Governance: did they implement automated scaling guardrails to protect the system in the future? Strong candidates prove they are scale-aware from day one of the design process.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer around a predictive migration, moving from a synchronous to an asynchronous model. Situation: our legacy customer onboarding service was highly synchronous. Every new sign-up required 4 different API calls to downstream systems, fraud, billing, identity, and CRM, to finish within the same request thread. Task: with a massive global marketing campaign approaching, our projections showed a 10 times increase in sign-up volume. My load tests proved that our CRM's API would start rate limiting us once we hit 3 times current volume, which would crash the entire onboarding thread. Action. I did not try to increase the CRM's rate limit. I re-architected the onboarding flow to be eventually consistent. I moved the non-critical downstream calls, CRM and marketing, into an asynchronous event-driven pipeline using AWS SQS and Lambda. The user received a welcome response instantly, while the background sync was processed independently with built-in retries. Result: during the 10 times traffic spike, our core onboarding succeeded with 100% reliability. The CRM API did hit its limit as predicted, but because the integration was now asynchronous, the events simply queued up and were processed safely over the following hour with zero impact on the user experience. Learning plus L. I learned that synchronous coupling is the enemy of scale. I subsequently introduced a synchronous debt audit in our design review process, mandating that any new cross-service call be evaluated for asynchronous conversion by default. The plus L proves you fixed the cultural bias for synchronous calls across the organization.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite architectural foresight. 1. Foresight matched. You used a marketing campaign projection to identify the CRM bottleneck months in advance. 2. Load testing matched. You used a scientific benchmark to prove that 3 times volume was the exact breaking point of the system. 3. Decoupling matched. You transformed a rigid synchronous thread into a resilient, event-driven async pipeline. 4. Resource optimization matched. You used SQS and Lambda, serverless, to handle the bursty traffic without paying for idle servers. 5. Governance matched. The plus L step, synchronous debt audit, ensured future engineers would not repeat the mistake. This demonstrates that you design for the 10 times future, not just the 1 times today.
Follow-up 1. Clarification probe. If the CRM sync took an extra hour during the peak surge, did that cause a data inconsistency issue for the sales team?
Answer: we identified that as a business trade-off. We met with the sales leadership and confirmed that a 1-hour delay in the CRM record was acceptable, as long as the user could still log in and use the product immediately. We prioritized user availability over internal data freshness, which is a standard architectural trade-off during hyper-growth events.
Follow-up 2. Level 3 or Level 4 junior depth. How did you handle the errors in the background queue if the CRM API returned a permanent failure? For example, an invalid email format.
Answer: we implemented a dead letter queue (DLQ) pattern. If a message failed 3 retries, it was moved to the DL queue. I built a simple internal dashboard for the support team to view these failures. In many cases, they were able to correct the customer data manually and replay the message from the dashboard without engineering intervention.
Follow-up 3. Level 5 or Level 6 senior depth. Moving to an event-driven model increases observability debt. How did you ensure you could still trace a single user's journey from the initial sign-up to the final CRM sync?
Answer: I implemented distributed trace IDs. We injected a unique correlation ID into the header of the initial request and passed it through the SQS message metadata into the Lambda logs. This allowed us to query our logging stack, CloudWatch or Datadog, for that specific ID and see the entire lifecycle of the onboarding across all asynchronous boundaries in a single view.
Follow-up 4. Curveball. What if the 10 times traffic spike was actually 100 times, and even your SQS or Lambda pipeline started hitting AWS regional service limits?
Answer: if we hit regional cloud limits, I would trigger our emergency load shedding protocol. We would prioritize the ingest of sign-up data into a highly durable, low-complexity storage layer, like raw S3 files, and pause all downstream processing entirely. This allows us to capture every customer's data safely while the cloud limits are being increased. You must always have a backstop that favors data preservation over real-time processing during an extreme black swan event.
Leadership pro tip. Scaling is the removal of state.
Junior engineers try to scale by making things faster. Senior architects scale by making things later. Whenever you face a scaling bottleneck, ask, does this work really need to happen right now? If you can turn a synchronous requirement into an asynchronous one, You have effectively removed the bottleneck and replaced it with a queue. In distributed systems, a queue is the ultimate scaling tool.
Category 8 Wrap-Up, the Technical Detective.
You have completed the problem-solving category. You have proven that a senior architect does not rely on luck or simple restarts. You have demonstrated the ability to use low-level forensics, from kernel spinlocks to distributed traces, to find the root cause of failures that bypass standard monitoring. You have moved from fixing bugs to fixing the fundamental physics of your system.
Transition, Navigating the Fog of Uncertainty.
In a perfect world, every decision is backed by exhaustive data. In the real world, especially at FAANG scale, the data is often missing, conflicting, or arriving too late. High-level leadership is the ability to make the correct call when the path is not clear. This brings us to Category 9, Ambiguity and Decision-Making.
Check the comments section or description of this video. I have given a link to download a magical bundle that teaches you to develop Google Caliber thinking and provides a complete mental model in a way that screams Google SRE. This bundle is the only end-to-end system that teaches you to think, act, and communicate like a Google SRE before you even set foot in the interview. It is the only structured playbook for Google's impossible rounds like NALS and troubleshooting. Most candidates sound like outsiders. The magic of this bundle makes you sound like you already work at Google. Cracking the Google SRE interview is one of the toughest challenges in tech. Most resources only prepare you for parts of the process, a few coding problems here, some system design notes there. But Google's SRE loop is multidimensional. It tests how you think, act, and communicate. Imagine preparing with scattered LeetCode problems, random design blog posts, and still wondering how to survive the NALS round. That's how most candidates prep, fragmented, incomplete, and unstructured.
Now, imagine having one complete system.
Imagine instead you had one system that gave you everything.
A system that gives you
1. End-to-end coverage of every single round. 2. Playbooks that turn chaos like NALS and troubleshooting into structure. 3. Realistic practice drills that simulate the actual interview loop. 4. Insider language and frameworks that make you sound like you already belong. That's what this bundle does. It's not just prep material, it's a game changer because it transforms the way you think, act, and communicate into the exact style Google interviewers are looking for.
the Google SRE interview bundle covers
1. Recruiter screen and resume prep, tailored templates and scripts that pass the first filter. 2. Coding rounds, Python and Go question and answers designed for SRE-style reliability tasks. 3. System design and NALS, playbooks for both high-level design and Google's infamous NALS round. 4. Troubleshooting and debugging, a step-by-step handbook to master war-room-style scenarios. 5. Behavioral and Googleness, real reliability scenarios that make you sound like you already work at Google. 6. Post-interview and hiring committee, an insider breakdown of how decisions are made. 7. Salary negotiation, recruiter-proof scripts and strategies to maximize your offer confidently. If LeetCode is practice mode, this bundle is the real game simulation. It doesn't just prepare you for questions. It prepares you to think, act, and communicate like a Google SRE before you even set foot in the interview.
Category 9. Ambiguity and Decision-Making.
Interviewers at companies like Google and Amazon use this category to measure your judgment. They want to see if you freeze when requirements are unclear, or if you can impose structure on chaos. At the staff and principal level, you are evaluated on your bias for action, the courage to make high-stakes architectural trade-offs under pressure, take accountability for the outcome, and pivot as soon as new information emerges.
Ambiguity and Decision-Making Scenarios.
These 8 scenarios evaluate your professional maturity and your ability to lead through technical and organizational uncertainty. 73. Tell me about a time you had to make a decision with incomplete information. 74. Describe a time when requirements were unclear. 75. Tell me about a time you had to choose between multiple solutions. 76. Tell me about a time you made a decision that was unpopular. 77. Tell me about a time you had to prioritize competing tasks. 78. Describe a situation where you had to act quickly. 79. Tell me about a time when you had to balance speed versus quality. 80. Tell me about a time when you had to make a trade-off between technical and business priorities. Senior architects do not wait for clarity, they create it. Question 73. Tell me about a time you had to make a decision with incomplete information. Note: interviewers use this question to evaluate your risk assessment skills and your ability to avoid analysis paralysis. At companies like Amazon and Meta, senior engineers are expected to demonstrate a bias for action by making high-stakes decisions using technical intuition and proxy data when the full picture is unavailable.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to identify candidates who freeze or act recklessly under uncertainty. Avoid these traps. 1. The wait-and-see trap, describing a time you delayed a critical decision for weeks while waiting for perfect data, causing a project to fail or an outage to drag on. 2. The blind guess, making a decision based on a gut feeling without explaining the logical framework or proxy metrics used to minimize risk. 3. The hidden uncertainty, failing to inform stakeholders that the decision was based on incomplete data, creating a false sense of security. 4. The irreversible gamble, making a high-stakes, one-way door decision without building a rollback plan or a safety net. 5. The blame the missing data, spending the interview complaining about poor documentation or missing logs rather than showing how you worked around them.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 decision-making signals. 1. Risk quantification. Did the candidate identify the worst-case scenario and the likely scenario? 2. Proxy reasoning. Did they use indirect data, for example, secondary logs, peer systems, to fill the information gaps? 3. Reversibility. Did they design the solution as a two-way door that could be rolled back if proven wrong? 4. Stakeholder transparency. Did they communicate the level of uncertainty and the mitigation plan to leadership? 5. Iterative validation. Did they implement early warning metrics to validate the decision as soon as it was live? Strong candidates prove that decision-making is about managing probability, not finding certainty.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, describe an irreversible-looking decision that you made reversible through engineering. Situation: I was leading the decommissioning of a 10-year-old legacy monolith. We needed to shut down the primary database cluster to save $30,000 per month. However, the system had zero documentation, and we could not identify if 3 zombie services still relied on that data. Task: I needed to make the go or no-go decision on the shutdown. Waiting for a full code audit would take 3 months, costing $90,000 in wasted cloud spend. Action: I did not guess. Since direct connection logs were missing, I looked at proxy traffic. I monitored the VPC flow logs and database IRO bytes over a 7-day period. I saw zero traffic, but I still was not 100% sure about quarterly jobs. I proposed a virtual shutdown, the Scream test. I did not delete the DB. I revoked the access credentials for 24 hours. This created a reversible failure state. Result: no services screamed or failed. We confirmed the services were truly dead. I authorized the final deletion, saving the company $360,000 annually with zero production impact. Learning plus L. I learned that when metadata is missing, the network wire is the only source of truth. I subsequently mandated that all new services must register in our service catalog with a heartbeat metric to prevent future zombie infrastructure. The plus L proves you built a system to ensure incomplete information never happens again.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite architectural judgment. 1. Risk quantification matched. You identified the $90,000 cost of delay versus the risk of a production crash. 2. Proxy reasoning matched. You used VPC flow logs as a proxy because application-level logging was missing. 3. Reversibility matched. You used a virtual shutdown, revoking keys, to make an irreversible decision reversible. 4. Stakeholder transparency matched. You proposed the Scream test to leadership as a controlled risk experiment. 5. Systemic improvement matched. The The service catalog heartbeat ensures future engineers have perfect information for decommissioning. This demonstrates that you solve ambiguity with risk-managed experiments, not guesses.
Follow-up 1 clarification probe. What if a critical annual job ran only once a year, and your 7-day VPC log check missed it? How did you account for that?
Answer: that was the most dangerous unknown. To mitigate this, I performed a metadata deep scan in our backup storage. I looked for the existence of database snapshots created in the last 12 months. Since the backup sizes were identical for the last year, it strongly suggested the data was static. I combined this historical data with the 7-day real-time check to increase my confidence to roughly 95% before triggering the Scream test.
Follow-up 2 Level 3 or Level 4 junior depth. Technically, how did you perform the virtual shutdown without actually stopping the database instance?
Answer: I modified the security group rules and the IAM policy to block all inbound traffic to the database ports, while keeping the instance running and the storage attached. This allowed me to simulate a total failure for any dependent services, but gave me a 10-second recovery time. I just had to flip the security group rule back if something broke. It turned a one-way door into a two-way door.
Follow-up 3 Level 5 or Level 6 senior depth. Your decision involved potentially breaking the system to save money. How did you get the product and business leads to sign off on a Scream test?
Answer: I used a financial risk model. I showed them that we were spending $1,000 a day on a service we believed was dead. I framed the Scream test as a business continuity drill. I told them, if a hidden dependency exists, we want it to fail now during business hours, when the entire team is on standby, rather than randomly failing at 3 a.m. on a weekend. I sold them on controlled failure as a form of reliability.
Follow-up 4 Curveball. What if, 5 minutes after the virtual shutdown, a critical legacy system in the finance department crashed and stopped all payroll processing? What is your immediate action?
Answer: I immediately revert the security group and IAM changes, no questions asked. Restoring the business flow is the only priority. Once the crisis is over, I would lead a discovery postmortem. The fact that the finance system did not show up in our VPC flow logs or our dependency mapping is a massive architectural blind spot. I would use that failure as the business justification to perform a full network-level trace of the finance environment before attempting the shutdown again.
Leadership pro tip. Decisions are either one-way or two-way doors.
Elite architects use Amazon's one-way versus two-way door framework. Most technical decisions are two-way doors. They can be reversed with low cost. When you face ambiguity, do not wait for more data. Instead, focus your engineering effort on turning the one-way door into a two-way door, like using a Scream test instead of a deletion. If you make the decision reversible, you do not need perfect information to act. Question 74. Describe a time when requirements were unclear. Note: interviewers use this question to evaluate your ability to resolve ambiguity through proactive discovery rather than assumption. At companies like Google and Meta, engineers must often lead projects where the business goal is known, but the technical how and success metrics are undefined. This tests your ability to act as a bridge between product and engineering.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to identify candidates who are reactive or risk-prone. Avoid these traps. 1. The passive implementer, explaining how you just followed whatever vague instructions you were given, resulting in a project that did not meet the real need. 2. The assumption trap, building a complex system based on your own guesses without validating them with stakeholders first. 3. The frustrated complainer, spending the interview complaining about how disorganized the product manager was rather than showing how you helped them. 4. The Big Bang failure, attempting to build the perfect final product without defining an MVP, minimum viable product, to validate the requirements early. 5. The scope creep victim, allowing the project to grow indefinitely because you never established clear in-scope versus out-of-scope boundaries.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 leadership signals. 1. Proactive discovery. Did the candidate lead the effort to find the missing data? 2. Stakeholder alignment. Did they interview the right people, product, legal, customers to find the job to be done? 3. Technical translation: did they turn a vague business request into a concrete technical specification (RFC) or design doc? 4. Phased delivery: did they use an iterative approach to validate requirements through a prototype or MVP? 5. Organizational impact: did they improve the product discovery process to prevent future ambiguity? Strong candidates prove that engineering is a discovery process, not just a typing task.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, describe how you led a discovery phase to define a massive, vague project. Situation: leadership requested a global content delivery shield to improve site performance and security. The only requirement given was it must be fast and secure, but there were no definitions of fast or what specific threats we were shielding against. Task: I was the lead architect responsible for defining the technical scope and success metrics for a $500,000 infrastructure investment. Action: I did not start an RFP for vendors immediately. I conducted a 2-week requirements discovery sprint. I interviewed the DevOps team to find their pain points, analyzed our last 12 months of security incidents, and reviewed our P99 latency logs per region. I authored a strategic design document that defined our target latency, sub 100 milliseconds, and established a threat profile, SQLI and DDoS protection. Result: we realized we did not need a custom-built shield. The data proved that a specific configuration of a standard CDN would solve 95% of our needs. We saved the company 4 months of engineering effort and $200,000 in capital expense. Learning plus L. I learned that ambiguity is often a mask for missing data. I subsequently introduced a mandatory inception brief template for all Tier 1 projects, requiring every new initiative to define its P0 success metrics before a single line of code is written. The plus L, learning, proves you established a systemic gate against organizational ambiguity.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite cross-functional leadership. 1. Proactive discovery matched. You initiated a 2-week discovery sprint rather than just guessing. 2. Stakeholder alignment matched. You interviewed DevOps and security to define what secure actually meant. 3. Technical translation matched. You turned fast and secure into sub 100 milliseconds latency and DDoS protection, concrete engineering goals. 4. Phased delivery matched. You prioritized the 95% solution, avoiding the trap of a multi-year custom build. 5. Organizational impact matched. The inception brief template ensured the entire company moved away from vague requirements. This demonstrates that you treat ambiguity as a technical variable to be solved.
Follow-up 1. Clarification probe. What happened during those 2 weeks? Did the project stall while you were doing discovery?
Answer: the project did not stall. It decelerated to ensure we did not accelerate in the wrong direction. I kept the engineering team focused on cleaning up our existing ingress logic during the discovery window. This allowed us to hit the ground running with a clean code base as soon as the final CDN strategy was approved.
Follow-up 2. Level 3 or Level 4 junior depth. How did you narrow down the technical metrics, like sub 100 milliseconds, when the business stakeholders could not define them?
Answer: I used customer experience benchmarking. I looked at our abandonment rates in the checkout funnel and correlated them with regional latency. I found a clear clump where drop-offs spiked once latency hit 150 milliseconds. I worked backwards from that user pain point to set 100 milliseconds as our engineering target, giving us a 50 millisecond safety margin. Data defines the metric when the human cannot.
Follow-up 3. Level 5 or Level 6 senior depth. What if your discovery phase revealed that the project actually was not necessary at all? How would you communicate that to the leader who requested it?
Answer: I would frame it as a ROI victory. I would walk them through the data and say, we found that our current infrastructure already meets the needs of 98% of our users. By not building this $500,000 system, we can reallocate our top engineers to Project X, which we know will drive direct revenue. A senior architect's value is often in the projects they successfully convince the company not to build.
Follow-up 4. Curveball. What if leadership ignored your data and insisted you build the custom solution anyway, because they wanted a proprietary IP asset for the company's valuation?
Answer: I would disagree and commit. I would clearly document the total cost of ownership, specifically the long-term maintenance and security burden of custom-built infrastructure compared to a vendor. Once I have laid out the business risk, and if the strategic decision remains to build, I will architect the most modular, high-quality version of that system possible. My job is to advise on risk, but ultimately to execute the business strategy.
Leadership pro tip: ambiguity is an opportunity.
Junior engineers view unclear requirements as a frustration. Senior architects view them as an opportunity to set the direction. If the requirements are blank, you have the authority to write the rules. When you face ambiguity in an interview, show that you did not just ask for clarity. You generated it by following the data and interviewing the right stakeholders. Question 75. Tell me about a time you had to choose between multiple solutions. Note: interviewers use this question to evaluate your technical decision-making framework and your ability to weigh trade-offs. At companies like Amazon and Google, senior engineers are expected to demonstrate architecture restraint, choosing the solution that provides the highest business value with the lowest long-term operational cost, rather than just the most innovative option.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to identify candidates who pick technology based on personal preference or hype. Avoid these traps. 1. The resume-driven choice, selecting a solution because it uses a trendy new framework or language you want to learn, rather than what the system actually requires. 2. Ignoring the maintenance tax, focusing only on the build cost while ignoring the 5-year total cost of ownership, including security patches, upgrades, and support. 3. The only one path bias, failing to seriously evaluate at least 2 or 3 viable alternatives before making a decision. 4. Subjective decision-making, choosing a path based on feel or intuition without using a weighted matrix or data-backed benchmarks. 5. The all-or-nothing architect, proposing massive, high-risk overhauls when a simple, incremental improvement would have solved the core business problem.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 decision-making signals. 1. Objective framework: did the candidate use a weighted comparison, cost, speed, reliability, complexity? 2. Business context: did the chosen solution align with the company's current stage and budget? 3. Time to value: did they prioritize shipping value to the customer over technical perfection? 4. Reversibility: did they consider how difficult it would be to pivot if the chosen solution failed? 5. Pragmatism: were they willing to choose boring technology if it was the more reliable option? Strong candidates prove that every technical choice is a financial and operational trade-off.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer around a classic build versus. By architectural dilemma. Situation: our engineering org was scaling to 500 developers, and we were drowning in infrastructure glue work. We needed an internal developer portal, IDP, to standardize service scaffolding and environment provisioning. Task: as the platform architect, I had to choose between 2 paths. 1. Building a custom, highly flexible portal on top of the open-source Backstage framework. Or 2. Purchasing a commercial, SaaS IDP platform. Action: I did not start with a code repo. I built a weighted decision matrix. I estimated that the build path would require 4 full-time engineers and 8 months to reach MVP, plus a permanent 20% maintenance tax. The buy path had a $50,000 annual cost but provided a 2-week time to value. I recommended the commercial solution, despite my team's desire to build it ourselves, because our primary company mission was shipping fintech features, not building infrastructure UI. Result: we went live in 3 weeks. Developer onboarding time dropped by 70% immediately. By buying the plumbing, we were able to reallocate those 4 senior engineers to work on our core proprietary transaction engine, which drove $2 million in new revenue that quarter. Learning +L. I learned to distinguish between differentiation work and plumbing. I subsequently implemented a TCO-first policy for all platform decisions. We only build if the solution provides a unique competitive advantage that cannot be bought. The +L, learning, shows you value engineering hours as the company's most expensive currency.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite architectural maturity. 1. Objective framework matched, you used a weighted decision matrix and quantified the maintenance tax. 2. Business context matched, you aligned the choice with the company's mission fintech rather than technical vanity. 3. Time to value matched, you prioritized the 3-week rollout over an 8-month custom build. 4. Pragmatism matched, you chose buying the plumbing to free up senior talent for differentiation work. 5. Systemic improvement matched, the TCO first policy institutionalized financial rigor across the architecture team. This demonstrates that you are a trusted advisor who thinks like a CTO, not just a coder.
Follow-up 1. Clarification probe. What were the specific weighted criteria you used in your decision matrix?
Answer: we used 4 primary buckets. 1. Time to MVP. 2. Yearly maintenance load engineering hours. 3. Extensibility, ability to add custom plugins. And 4. Security or compliance overhead. While build 1 on extensibility, buy 1 decisively on time to value and maintenance. When we looked at the total 3-year cost, the commercial solution was roughly 4 times cheaper than the engineering salaries required for a custom build.
Follow-up 2. Level 3 or Level 4 junior depth. Backstage is free and used by Spotify. Why would building on a free tool be more expensive than a $50,000 paid license?
Answer: free software is free like a puppy, not free like beer. Backstage is a framework, not a product. It requires significant TypeScript development, custom API integrations, and continuous maintenance of the plugin ecosystem. When you factor in the average salary of a senior platform engineer in this market, those 4 engineers represent a $700,000 annual investment. A $50,000 license is negligible compared to that human capital cost.
Follow-up 3. Level 5 or Level 6 senior depth. How did you manage the morale of the platform engineers who were excited to build a custom solution and felt robbed of an interesting project?
Answer: I shifted their focus from building a UI to building value. I explained that by buying the portal's UI, they were now responsible for the much more complex backend orchestration and security guardrails that plugged into the portal. I reframed the project as, we are letting the vendor handle the buttons so we can focus on the hard distributed systems engineering that actually makes us unique. They felt more like owners of the logic rather than maintainers of a UI.
Follow-up 4. Curveball. What if, 12 months later, the vendor triples their prices and you are now locked into their ecosystem? Was the buy decision still correct?
Answer: I accounted for exit cost in the original design. We used the vendor's portal but kept our core logic in standardized Terraform modules and external API services. The vendor was just a glass layer. If we had to switch, we would only lose the UI, not our underlying infrastructure automation. We accepted a UI lock-in to gain massive time to market speed. Even with a price increase, the 12 months of productivity we gained would still far outweigh the cost of an earlier custom build.
Leadership pro tip. Focus on porcelain versus plumbing.
Elite architects categorize work into plumbing, the necessary but generic infrastructure everyone has, and porcelain, the unique features that your customers actually pay for. Never build your own plumbing. Your most talented engineers should only be building the porcelain. When you are asked to choose between solutions, always prioritize the one that gets your team back to building what makes your company special. Question 76. Tell me about a time you made a decision that was unpopular. Note: interviewers use this question to evaluate your leadership courage, empathy, and your ability to stand by a difficult choice for the long-term health of the organization. At companies like Netflix and Amazon, senior engineers are expected to prioritize high standards and business integrity over being liked by the team.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to filter out candidates who are either toxic dictators or passive pushovers. Avoid these traps. 1. The dictator move, explaining how you forced a decision purely because you had the architect title without ever listening to the team's concerns. 2. The hidden decision, making the decision in secret to avoid conflict and only announcing it when it was too late to change. 3. Lack of empathy, describing your team's disagreement as uneducated or lazy rather than validating their very real concerns about workload or complexity. 4. The pushover ending, starting with an unpopular decision but then backing down as soon as people complained, showing a lack of backbone. 5. No organizational alignment, making a decision that benefited your local team but caused massive friction or extra work for other departments?
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 leadership signals. 1. Strategic courage. Did the candidate do the right thing for the business despite the social cost? 2. Upward and peer empathy. Did they actively listen to the concerns of the people affected by the decision? 3. Data-driven conviction. Was the decision based on objective risk or cost data rather than personal preference? 4. Alignment building. Did they work to bring people along on the journey even after the decision was made? 5. Professional maturity. Did they separate the technical disagreement from their personal relationships? Strong candidates prove they care more about the system's success than their own popularity.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer around a security or reliability mandate that caused friction. Situation: our company was in a high-growth feature war with a competitor. To move faster, the engineering team had stopped writing unit tests and was bypassing security scans. Technical debt and security vulnerabilities were reaching a critical point. Task: as the new staff architect, I had to enforce a security-first mandate, requiring 80% code coverage and 0 critical CVEs for every deployment. Action: this was extremely unpopular. The team felt I was killing their velocity. I did not back down, but I did not just order it. I hosted a town hall where I showed a 12-month projection of our rising incident rate. I provided pre-built templates to make writing tests faster and volunteered to spend 2 weeks personally helping the most critical services reach the new standard. Result: velocity dropped for 2 weeks, then stabilized. However, our production incident rate dropped by 65%, and we passed a major enterprise security audit that was required for a $5 million contract. Learning plus L. I learned that people only resist standards when the cost of adoption is too high. I now focus my architectural efforts on building paved roads that make the right decision the easiest decision for the team. The plus L, learning, shows you moved from enforcer to enabler.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite architectural courage and empathy. 1. Strategic courage matched. You enforced a strict standard during a feature war because it was the right long-term move. 2. Upward and peer empathy matched. You personally helped teams with their code and provided templates to reduce their burden. 3. Data-driven conviction matched. You used a 12-month incident projection to prove that the current speed was a mirage. 4. Alignment building matched. You tied the new standard to a $5 million business contract, giving the team a shared goal to rally around. 5. Professional maturity matched. You transitioned from a difficult mandate to a paved road strategy to solve the root cause of the friction. This demonstrates that you have the backbone to protect the system even under social pressure.
Follow-up 1. Clarification probe. What was the specific security scan that caused the most friction, and how did you resolve that specific point?
Answer: the most friction came from our container image scanning. We were blocking builds for any CVE, including low-risk ones in base images. I compromised by adjusting our policy to only block on critical or high vulnerabilities, while reporting on medium/low. This significantly reduced the false positive noise and allowed developers to focus only on the risks that actually mattered.
Follow-up 2. Level 3 or Level 4 junior depth. How did you handle a developer who flat-out refused to follow the code coverage rule and tried to bypass the check?
Answer: I treated it as a coaching opportunity, not a disciplinary one. I sat down with them to understand why they were struggling. I realized they did not know how to mock our legacy database for tests. I spent an hour pair programming with them to build a reusable mock utility. Once they had the right tool, their resistance vanished. Most rebellion is just a lack of technical support.
Follow-up 3. Level 5 or Level 6 senior depth. The product VP likely blamed you for the 2-week velocity drop. How did you defend your position in the executive meeting?
Answer: I did not defend my position. I defended the business asset. I showed the VP that our technical debt interest rate, time spent on bugs, was already consuming 40% of our capacity. I framed my decision as debt consolidation. I told them, we are taking a 2-week hit now to gain 40% capacity back for the rest of the year. When you speak in terms of capacity and ROI, The VP moves from being an opponent to a stakeholder.
Follow-up 4 curveball. What if, after the 2-week delay, the incident rate did not drop and the team remained angry? Would you admit you were wrong and roll back the coverage rule?
Answer: I would reevaluate the hypothesis. If the incident rate did not drop, it means unit tests were not the right solution for our failures. Perhaps the issues were in the network layer. I would not blindly stick to an unpopular rule if it was not delivering the business result. I would be the first to say, the data shows this is not working as expected. Let's pivot to a more effective reliability strategy. Backbone is for the truth, not for pride.
Leadership pro tip. Use your social capital wisely.
A senior architect's influence is like a bank account of social capital. You earn capital by helping others, being humble, and delivering wins. You spend that capital when you have to make an unpopular decision. Never force a decision unless you have already earned the trust of the team. If you lead with empathy first, an unpopular decision becomes a shared sacrifice rather than a top-down mandate. Question 77. Tell me about a time you had to prioritize competing tasks. Note: interviewers use this question to evaluate your ability to manage limited resources and align technical effort with business ROI. At companies like Amazon and Google, senior engineers are expected to prioritize based on customer impact and risk, rather than simply following a first-in, first-out queue.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to identify candidates who lack strategic prioritization. Avoid these traps. 1. The first-come, first-served method, handling tasks in the order they were received without evaluating their relative impact or risk. 2. The hero culture fail, saying you solved the competition by just working twice as hard to finish both tasks at once. This is unsustainable and poor planning. 3. The squeaky wheel bias, prioritizing the task requested by the loudest stakeholder rather than the one with the highest business value. 4. Lack of negotiation, simply accepting all work and letting the quality of every task drop, showing a lack of backbone to manage scope. 5. Static prioritization, failing to reevaluate priorities as new, high-severity information, like a production outage, enters the system.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 prioritization signals. 1. Impact valuation. Did the candidate quantify the business or technical cost of delay for each task? 2. Risk assessment. Did they prioritize based on system stability and data integrity? 3. Stakeholder management. Did they communicate the trade-offs and gain alignment from the affected teams? 4. Pragmatism. Were they willing to deliver an MVP, minimum viable product, for one task to unblock the other? 5. Transparency. Did they update the roadmap and communicate the new timeline immediately? Strong candidates prove that prioritization is a mathematical exercise, not an emotional one.
Here is the FAANG level senior answer, STAR+L.
Pass the senior bar. Structure your answer around a conflict between a business feature and a system risk. Situation: 2 weeks before Black Friday, I was faced with 2 P0 priorities. 1. Deploying a high-profile one-click checkout feature requested by the CEO, and 2. Patching a newly discovered critical vulnerability in our API gateway's authentication logic. Task: we had limited engineering capacity to do both with the required rigor. I needed to decide the sequence and manage the stakeholder fallout. Action: I analyzed the trade-off. The feature drove revenue, but the vulnerability posed an existential risk to user data. I used a risk versus reward matrix. I prioritized the security patch as non-negotiable. To salvage the feature, I negotiated with the product lead to ship a simplified version of OneClick that reused existing secure session logic, deferring the more complex, higher-risk optimizations to Q1. Result: we patched the vulnerability in 48 hours. The simplified feature launched on time and still achieved a 12% conversion increase. Our peak traffic period passed with 0 security incidents. Learning plus L. I learned that prioritization is easier when you have a predefined crisis tier list. I subsequently authored a service-level hierarchy that explicitly ranks security and reliability above new feature work for the entire organization. The plus L, learning, proves you built a systemic rule to handle future priority conflicts.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite professional judgment. 1. Impact valuation matched. You recognize that security integrity protecting data was more valuable than a CEO-requested UI feature. 2. Risk assessment matched. You used a risk versus reward matrix to justify your decision to stakeholders. 3. Stakeholder management matched. You did not just say no to the feature. You offered a simplified, safe alternative that still delivered value. 4. Pragmatism matched. You chose the non-negotiable security patch while finding a middle path for the business deadline. 5. Systemic improvement matched. The service level hierarchy ensured the organization had a shared language for future trade-offs. This shows the interviewer that you prioritize the long-term safety of the company over short-term political wins.
Follow-up 1. Clarification probe. How did the CEO react when you told them their top priority feature was being simplified and delayed due to an internal patch?
Answer: I framed the conversation around risk to brand. I explained that launching the feature without the patch was like putting a high-end storefront on a building with no locks. I showed the potential cost of a data breach versus the conversion gain. When executives see security as a revenue protection measure, they respect the priority shift immediately.
Follow-up 2. Level 3 or Level 4 junior depth. How did you manage your team's workload when these two high-pressure tasks arrived at the same time?
Answer: I shielded the team from the chaos. I assigned 2 senior engineers specifically to the security patch to move fast. I took over the communication with the product team myself to define the simplified one-click scope. By creating clear, isolated focus areas, I prevented the team from thrashing between 2 different problems.
Follow-up 3. Level 5 or Level 6 senior depth. Your simplified version of the feature lacked the optimizations the business wanted. What specific trade-offs did you make to ship it fast and safe?
Answer: we sacrificed micro-personalization. The original plan required a complex new data syncing pipeline between 2 regions. The simplified version used our existing, slower local cache. It meant the feature was slightly slower, 200 milliseconds versus 50 milliseconds, but it was 100% secure and required 0 new infrastructure changes. We chose predictable performance over theoretical speed to hit the date.
Follow-up 4. Curveball. What if you had finished the security patch, but then discovered a major bug in the simplified feature 24 hours before the Black Friday launch? Would you pull the feature?
Answer: yes. If the bug compromised data integrity or checkout stability, I would pull the feature. Launching a broken improvement during a peak event is a net negative. I would have a kill switch feature flag ready. I would explain to leadership, the feature is ready, but the data validation is failing. We are rolling back to the stable baseline to protect our peak traffic revenue. Protecting the existing revenue is always more important than chasing new revenue.
Leadership pro tip. Use a tiebreaker logic.
Junior engineers get overwhelmed by priorities because they treat every task as equally important. Senior architects use tiebreaker logic. If 2 things are urgent, the one that protects integrity, data, and security always wins over the one that provides utility, features, and speed. In a FAANG interview, explicitly stating that you prioritize system health over feature growth is a massive signal of seniority. Question 78. Describe a situation where you had to act quickly. Note: interviewers use this question to evaluate your composure, decision-making speed, and your ability to stabilize a system during a high-stakes emergency. At companies like Netflix and Amazon, engineers are expected to take decisive action to stop a bleeding business metric before they have the luxury of a full post-mortem.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to identify candidates who are either paralyzed by fear or reckless in their actions. Avoid these traps. 1. The panic reflector, describing how you waited for a manager's approval while the system was actively losing data or money. 2. The blind shooter, making a massive, high-risk change, like deleting a table or clearing a global cache without understanding the consequences just to do something. 3. The silo fix, acting quickly to fix your own service while inadvertently causing a larger failure in a downstream dependency. 4. The communication void, solving the problem quickly but failing to notify the on-call team or stakeholders that you were taking action. 5. The repeat offender, fixing a recurring problem quickly every time, but never addressing the architectural flaw that caused it.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 crisis leadership signals. 1. Triage accuracy. Did the candidate correctly identify the most critical bleeding metric? 2. Decisiveness. Did they act without hesitation once the risk profile was clear? 3. Constraint awareness. Did they choose the fastest mitigation path with the lowest risk of worsening the outage? 4. Coordination. Did they inform and align the team while taking action? 5. Systemic remediation. Did they implement a permanent safeguard after the fire was out? Strong candidates demonstrate that acting quickly is a controlled, calculated engineering response.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, describe a situation where you caught a silent failure that required immediate architectural intervention. Situation: during a high-traffic payroll cycle, I noticed a subtle but terrifying anomaly in our ledger audit logs. A rounding error bug was causing thousands of transactions to be overpaid by exactly 1 cent. Task: while it was only a 1-cent error per person, the cumulative financial loss was climbing by $500 per minute, and it threatened our compliance audit integrity. I needed to stop the corruption within minutes. Action: I did not wait for a code review. I triggered an emergency feature flag to disable the specific submodule responsible for the dynamic payout calculation. This immediately reverted the system to its safe static baseline mode. I then updated the global status page and paged the leadership team to explain that I had intentionally throttled the payout speed to protect data correctness. Result: the financial leakage stopped in under 3 minutes. Total loss was limited to $1,500. We found and patched the floating point precision bug 2 hours later, and the system successfully backfilled the missing cents that evening. Learning +L. I realized our financial guardrails were missing. I subsequently implemented an audit circuit breaker, a service that automatically halts processing if a total payout amount deviates from the projected budget by more than 0.1%. The +L proves you built a digital insurance policy so you never have to act that fast again.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite crisis management. 1. Triage accuracy matched. You recognize that a 1-cent error was actually a high-speed financial bleed that needed to be stopped instantly. 2. Decisiveness matched. You used a feature flag to kill a submodule immediately without waiting for a bug fix PR. 3. Constraint awareness matched. You accepted the trade-off of slower payouts to protect data correctness. 4. Coordination matched. You updated the status page and leadership concurrently with your action. 5. Systemic improvement matched. The audit circuit breaker automated the detection and blocking of future financial errors. This shows you are a leader who understands that protecting integrity is the first rule of crisis response.
Follow-up 1. Clarification probe. Disabling a core submodule during a payroll cycle is a huge move. Did you have the authority to pull that trigger without a manager's approval?
Answer: I have an emergency authority framework. I know that if a metric is literally costing the company money every second, the cost of waiting for a meeting is higher than the cost of a temporary rollback. I acted based on my role's accountability for system integrity. I immediately briefed management afterward, and they supported the move because the data proved it stopped a $30,000 potential loss.
Follow-up 2. Level 3 or Level 4 junior depth. Technically, why was the calculation failing by exactly 1 cent?
Answer: it was a floating point precision error. The code was using double for currency math. When multiple tax deductions were applied to small balances, the tiny fractional remains were being rounded up incorrectly. I rewrote the logic to use big decimal with a strict round underscore half underscore even scale, ensuring every cent was accounted for with 0 rounding bias.
Follow-up 3. Level 5 or Level 6 senior depth. How did you backfill the missing data so the ledgers remained perfectly in sync for the auditors?
Answer: I did not trust the live database. I used our immutable transaction logs from S3. I ran a reconciliation script that recalculated every payout from that 45-minute window using the new big decimal logic. We then applied correction transactions to each account to adjust the balances. We documented every correction in a special audit ledger, which we handed directly to the internal audit team.
Follow-up 4. Curveball. What if you had killed the submodule, but the bug was actually deeper in the database, and the overpayments continued? What then?
Answer: I would escalate to the nuclear option. I would have paused the entire database write path at the proxy layer. This would have completely stopped the company's ability to pay anyone, but it would have prevented a total drain of the bank account or a catastrophic data corruption that might take weeks to undo. You must always be willing to sacrifice availability to protect integrity when the stakes are this high.
Leadership pro tip: triage is about stopping the bleeding.
Junior engineers try to solve the mystery during a crisis. Senior architects try to stop the impact. When you are asked about acting quickly, do not focus on the cleverness of your fix. Focus on the speed of your triage. An architect who can kill a broken feature in 60 seconds is more valuable than an architect who can find a bug in 60 minutes. Question 79. Tell me about a time when you had to balance speed versus quality. Note: interviewers use this question to evaluate your pragmatism and your ability to manage technical debt. At companies like Meta and Google, the focus is on speed to learning versus engineering perfection. They want to see if you can ship a good enough solution now to capture a market window, while ensuring the system does not collapse later.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to identify candidates who are either reckless hackers or slow perfectionists. Avoid these traps. 1. The hack and forget, describing how you built a low-quality solution to meet a deadline but never went back to fix it, resulting in a permanent maintenance nightmare. 2. The over-engineer, admitting you missed a critical business deadline because you refused to ship a system that was not perfectly designed. 3. The silent debt, shipping a low-quality solution without informing stakeholders of the risks or the plan to pay back the technical debt. 4. Vague quality definition, failing to explain exactly what quality you sacrificed, for example, test coverage, scalability, or performance, and why that specific trade-off was safe. 5. The unconscious trade-off, making the system lower quality by accident rather than as a calculated business decision.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 trade-off signals. 1. Strategic choice: did the candidate explicitly decide to prioritize speed for a valid business reason? 2. Risk quantification: did they identify the specific technical debt they were incurring? 3. Compromise selection: did they choose to sacrifice elegance rather than correctness or security? 4. Debt repayment plan: did they establish a clear roadmap to return the system to its high-quality state? 5. Outcome focus: did the speed increase actually result in a business win, for example, hitting a holiday window? Strong candidates prove that high quality sometimes means knowing exactly when to ship a low-fidelity solution.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, describe a bridge architecture, a temporary solution built to hit a date while a permanent fix is designed. Situation: our company was entering a new international market, and we had only 3 weeks to comply with a specific local tax regulation or lose our license to operate. Task: a high-quality fix required re-architecting our entire billing engine to support dynamic tax rules, a project estimated at 3 months. Action: I chose speed over architectural elegance. I proposed a tax wrapper, a lightweight, hard-coded microservice that intercepted billing events and applied the local tax rules manually before the transaction hit the database. I explicitly documented this as high-interest technical debt. I required the team to write 100% integration test coverage for the wrapper to ensure financial correctness, even though the code was ugly and non-scalable. Result: we launched in the new market on day 20. The ugly wrapper processed $1 million in revenue without a single error. Because it was a decoupled microservice, we were able to replace it with the permanent, high-quality billing engine 3 months later with 0 downtime. Learning +L. I learned that modularity is the best way to manage quality trade-offs. By building the quick fix as an isolated component rather than hacking the core monolith, the debt was easy to pay back without risking the entire system. The +L, learning, shows you used architecture to make your technical debt modular and safe.
Our answer breakdown: here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite pragmatism. 1. Strategic choice matched. You chose to prioritize the market launch over a clean billing engine redesign. 2. Risk quantification matched, you explicitly identified the hard-coded logic as high-interest debt for the business. 3. Compromise selection matched, you sacrifice scalability by hard-coding, but refuse to sacrifice correctness by adding 100% tests. 4. Debt repayment plan matched, you successfully replaced the temporary wrapper 3 months later as planned. 5. Outcome focus matched, your speed enabled the company to successfully enter a new market and earn $1 million in revenue. This shows you are an architect who can deliver business value without losing control of the codebase.
Follow-up 1. Clarification probe. If the permanent fix was 3 months away, how did you ensure the team did not just forget about the ugly wrapper and leave it in production forever?
Answer: I used forced visibility. I created a dashboard that tracked the transaction volume through the wrapper and reported its maintenance cost to the leadership team every week. I also added a logic bomb into the wrapper's build script. If the code was still in production after 120 days, the CI pipeline would trigger a critical debt alert to the VP of engineering. You cannot fix technical debt if you allow it to become invisible.
Follow-up 2. Level 3 or Level 4 junior depth. Why was it easier to build a separate microservice rather than just adding the tax logic to the existing billing code?
Answer: decoupling. If I had put the hard-coded tax logic into our core billing monolith, it would have been entangled with our main database schema and release cycle. Reverting it later would have been a surgical nightmare. By building it as a separate wrapper, I turned a code problem into a network problem. When the real fix was ready, we just had to update a routing rule at the API gateway to kill the wrapper and send traffic to the new engine.
Follow-up 3. Level 5 or Level 6 senior depth. What if a second international market opened up before the 3-month permanent fix was ready? Would you have built a second ugly wrapper?
Answer: that would be the tipping point. One wrapper is a tactical pivot. 2 wrappers are a failing strategy. I would inform leadership that the cost of speed had now doubled. I would propose accelerating the permanent fix by pulling in more resources, rather than building a second hard-coded service. You must know when the interest rate on your technical debt has become too high to keep borrowing.
Follow-up 4. Curveball. What if the permanent fix project was canceled after 2 months, and you were stuck with the ugly wrapper indefinitely? Was your decision still a success?
Answer: yes. The business achieved its goal of entering the market and earning revenue. My job as an architect is to ensure that even a temporary solution is built to be safe and observable. Because the wrapper was modular and had 100% test coverage, it was a stable, if ugly, piece of infrastructure. Success in engineering is meeting the business needs safely, even if the long-term roadmap changes.
Leadership pro tip. Quality is not binary.
Junior engineers view anything less than clean code as a failure. Senior architects view quality as a variable that you tune based on the business context. In a high-growth environment, high quality often means low coupling. If you build your quick fixes as decoupled, disposable components, you have maintained the highest form of quality, the ability to change your mind later. Question 80. Tell me about a time when you had to make a trade-off between technical and business priorities. Note: interviewers use this question to evaluate your ability to think like a business owner. At companies like Amazon and Apple, the technical strategy must always serve the business objective. They are looking for architects who can sacrifice technical purity to achieve a strategic market win, while managing the resulting operational risks.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to identify candidates who are ivory tower architects or reactive pushovers. Avoid these traps. 1. The ivory tower architect, refusing to compromise on technical standards even when it meant the company would miss a multi-million-dollar market opportunity. 2. The passive pushover, instantly agreeing to every business request without raising technical risks or providing alternative solutions. 3. Lack of ROI thinking, failing to explain the dollar value of the business priority versus the engineering cost of the technical priority. 4. The unconscious trade-off, making a compromise without realizing the downstream impact on scalability, security, or maintenance cost. 5. Blaming the business, describing the situation as the product manager made a bad call, rather than showing how you collaborated to find the best path.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 alignment signals. 1. Commercial awareness. Did the candidate understand the why behind the business priority? 2. Risk communication. Did they clearly explain the technical tax that would be paid later? 3. Creative negotiation. Did they offer a third path that satisfied both business speed and technical safety? 4. Strategic alignment. Was the decision made in the best interest of the customer and the long-term business health? 5. Accountability. Did they personally manage the consequences of the trade-off? Strong candidates prove they are engineers who build businesses, not just systems.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer around choosing good enough technology to win a competitive market window. Situation: our company was in a bidding war for a massive 3-year government contract. The contract required our platform to support a specific encryption standard that our current system did not have. Task: I was the lead architect. A technically pure solution involved migrating our entire auth mesh to a zero-trust model, a 6-month effort. The business priority was to sign the contract in 4 weeks. Action: I did not fight the deadline. I proposed a compliant island architecture. We did not upgrade the whole system. We built one isolated, high-security VPC specifically for that government contract traffic, using a hard-coded manual key rotation process. I explicitly documented this as operational overhead and agreed to manage the manual rotations myself for the first quarter until we could automate the zero-trust migration. Result: we passed the compliance audit in 3 weeks. The company won the multi-million-dollar contract. By isolating the business priority into its own environment, we protected the rest of the engineering team from the distraction of a rushed global migration. Learning plus L. I learned that sometimes isolation is the best form of scalability. I subsequently implemented a tiered compliance framework so we could onboard specialized business requirements without forcing a one-size-fits-all architecture on the entire company. The plus L, learning, shows you turned a difficult trade-off into a flexible organizational capability.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite business-aligned engineering. 1. Commercial awareness matched. You prioritized winning the multi-million-dollar contract over technical purity. 2. Risk communication matched. You explicitly identified the manual key rotation as the technical tax that would be paid. 3. Creative negotiation matched. Your compliant island strategy provided the third path that hit the 4-week deadline. 4. Strategic alignment matched. You protected the rest of the org from a rushed migration while unblocking the revenue team. 5. Accountability matched. You volunteered to manage the operational overhead yourself to ensure the trade-off succeeded. This demonstrates that you are a partner to the CEO, not just a resource to the CTO.
Follow-up 1. Clarification probe. If you were managing the manual key rotations yourself, how did that affect your ability to lead the zero-trust migration project?
Answer: it was a high personal load, but it was a strategic sacrifice. I spent 2 hours every Monday on the manual rotation. This was a clear, calculated cost that I used as leverage to ensure the permanent zero-trust project remained funded and prioritized. I turned my own manual labor into a burn-down metric that the executive team could see and appreciate.
Follow-up 2. Level 3 or Level 4 junior depth. How did you ensure the compliant island did not become a security hole for the rest of the main system?
Answer: total network isolation. We used a one-way data diode architecture. Data could flow into the high-security island from our primary databases, but the island had zero outbound connectivity to the rest of our internal network. It was effectively an air-gapped environment in the cloud. If that government-facing VPC was compromised, the blast radius was physically limited to that single environment.
Follow-up 3. Level 5 or Level 6 senior depth. What if the government contract was canceled after 2 months, and you had spent all that time building the compliant island? Was the trade-off still worth it?
Answer: yes. In the enterprise, we play for probabilities. The probability of winning millions was high enough to justify the 3-week sprint. Furthermore, the compliant island was not wasted work. It proved that we could support high-security tenants. We repurposed that same infrastructure pattern for a second, highly regulated client 6 months later. We turned a specific government requirement into a generic security product.
Follow-up 4. Curveball. What if the manual key rotation failed during the first quarter and caused an outage for that government client? Who is at fault?
Answer: I am. I made the decision to use a manual process to hit the date. I accepted that risk. I would lead the incident response, own the communication with the government auditor, and use the failure as a forcing function to immediately move the zero trust automation to P0 priority. A senior leader does not run from the risk they signed up for. They use it to drive the next correct decision.
Leadership pro tip: trade purity for velocity, never for safety.
Junior engineers trade security for speed. Senior architects trade elegance for speed. When you face a business priority, look for a way to say yes that does not violate your core technical values. Hard-coding a config lack of elegance is a valid trade-off to hit a date. Removing a firewall lack of safety is not. Always protect the company's integrity while supporting its growth.
Category 9 wrap-up: the decisive architect.
You have mastered the ambiguity and decision-making category. You have proven that an elite engineer does not wait for perfect data to act. You have demonstrated the framework for turning one-way doors into two-way doors and shown that you have the professional maturity to prioritize business survival over technical perfection. You now possess the judgment required to lead through uncertainty.
Transition: architecture under fire.
Making the right decision in a vacuum is difficult, but making it while the clock is ticking and the business is watching is the true test of a leader. High-level architecture is as much about managing psychological pressure as it is about managing system load. This brings us to Category 10, pressure and deadlines.
Category 10: pressure and deadlines.
In FAANG interviews, pressure is not about how many hours you can work. It is about how your engineering judgment holds up when resources are scarce and time is disappearing. Interviewers at companies like Amazon and Netflix want to see if you can maintain technical rigor during a crunch, or if you will take dangerous shortcuts that create catastrophic debt. They are looking for stabilizers who can manage stakeholder stress while protecting the integrity of the system.
Pressure and deadlines masterclass scenarios.
These 5 scenarios evaluate your resilience and your ability to execute under extreme organizational constraints. 81. Tell me about a time you had to meet a tight deadline. 82. Describe a high-pressure situation you handled. 83. Tell me about a time you had too much work and had to prioritize. 84. Tell me about a time when a project was at risk of failing. 85. Describe a time when you had to fix a critical issue quickly. Strong candidates prove that under pressure, they do not just work harder, they work smarter. Question 81. Tell me about a time you had to meet a tight deadline. Note: interviewers use this question to evaluate your ability to manage scope, prioritize high-leverage tasks, and maintain technical integrity under time constraints. At companies like Amazon and Meta, this tests whether you can deliver results without accumulating unmanaged technical debt or burning out the team.
Here are the critical red flags: the instant rejection signals.
Interviewers use this question to identify candidates who sacrifice long-term health for short-term dates. Avoid these traps. 1. The heroic burnout, describing how you met the deadline by simply working 80-hour weeks. This is a negative signal for planning and scalability. 2. The silent quality cut, admitting you skipped testing or security reviews to hit the date without informing stakeholders of the risk. 3. The last-minute panic, realizing the deadline was impossible only days before the due date, showing poor initial discovery. 4. The fixed mindset execution, trying to ship 100% of the features in 50% of the time rather than negotiating an MVP. 5. The blame the calendar, attributing the pressure to unrealistic management without showing how you attempted to rescope the work.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 execution signals. 1. Ruthless prioritization. Did the candidate identify and focus only on the mission-critical path? 2. Stakeholder negotiation. Did they gain alignment on a reduced scope MVP to protect the date? 3. Transparency. Did they communicate the technical debt and risks incurred by the speed? 4. Process efficiency. Did they find a technical shortcut, automation, or tooling to accelerate delivery? 5. Systemic improvement. Did they improve the estimation process to avoid similar crunches in the future? Strong candidates prove that a deadline is a constraint to be engineered around, not just a date to suffer through.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer around a strategic scope reduction to hit a market window. Situation: our primary third-party payment processor announced they were sunsetting their legacy API with only 3 weeks of notice. If we did not migrate, we would lose the ability to process all international transactions. Task: I was the lead engineer responsible for migrating our entire checkout flow to the new API while maintaining our 99.99% reliability target. Action: I realized a full migration of all 50 payment methods would take 2 months. I performed an 80/20 analysis and found that 3 specific payment methods covered 92% of our revenue. I negotiated with the product lead to build a compatibility adapter for those top 3 methods immediately, while putting a temporary maintenance block on the rare payment types to save the date. Result: we successfully cut over the high-volume traffic on day 20 with 0 downtime. We protected 92% of our revenue and completed the remaining migration over the following month without the pressure of a hard cutoff. Learning +L. I learned that our architecture was too tightly coupled to a single vendor's API. I subsequently led a project to build an internal payment abstraction layer, which allows us to swap providers in the future with simple configuration changes. The +L proves you turned a tactical deadline into a long-term architectural decoupling win.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite project management and pragmatism. 1. Ruthless prioritization matched. You identified the 3 payment methods that covered 92% of revenue and focused there. 2. Stakeholder negotiation matched. You gained agreement to temporarily block low-volume features to protect the high-volume business. 3. Process efficiency matched. You built a compatibility adapter to minimize the code changes required in the 3-week window. 4. Outcome focus matched. You hit the hard cutoff date and saved the company's ability to process international payments. 5. Systemic improvement matched. The payment abstraction layer ensured the company is now immune to future vendor sunsettings. This demonstrates that you prioritize business survival over completionism.
Follow-up 1. Clarification probe. What did the maintenance block look like for those other payment methods? Did not that hurt the customer experience?
Answer: it was a minor degradation. We updated the UI to show those options as temporarily unavailable with a link to our supported methods. While it was not ideal, it affected less than 8% of users. I justified this by comparing it to the alternative, a total system failure for 100% of users if we had tried to rush the entire migration and failed.
Follow-up 2. Level 3 or Level 4 junior depth. How did you ensure the compatibility adapter did not introduce new security vulnerabilities into the payment flow?
Answer: we prioritize security rigor over feature richness. We skipped the UI enhancements the new API offered and focused 100% of our testing capacity on the encryption and tokenization logic. We ran a 24-hour continuous penetration test in staging before the cutover to ensure the adapter did not leak any sensitive transaction data.
Follow-up 3. Level 5 or Level 6 senior depth. The payment abstraction layer you built after the deadline is a large project. How did you justify the headcount for that when there were other product features waiting?
Answer: I framed it as operational risk insurance. I showed the leadership team how much stress and risk the 3-week deadline caused because of our vendor coupling. I explained that the abstraction layer would reduce the cost of change for all future payment integrations by 60%. Once leadership saw it as a way to increase future velocity and reduce risk, it became a P0 priority.
Follow-up 4. Curveball. What if, on the day of the cutover, the new vendor's API had a major outage? Would you have been blamed for the failure?
Answer: I would own the availability of the checkout, even if the vendor was at fault. This is why our Plan B included an emergency reroute to a secondary established processor we already had in the system. As an architect, I do not assume external APIs will work. I design the system to remain functional when they do not.
Leadership pro tip. Manage the impact, not the date.
Junior engineers focus on the deadline. Senior architects focus on the residual risk. When you are asked about a tight deadline, Show the interviewer that you are willing to cut 20% of the features to ensure 100% of the security and reliability. Shipping a half-finished but stable system is a win. Shipping a complete but buggy system is a failure. Question 82. Describe a high-pressure situation you handled. Note: interviewers use this question to evaluate your emotional intelligence, technical composure, and decision-making clarity when the stakes are at their highest. At companies like Netflix and Google, engineers are expected to act as calming forces during production outages or high-stakes business events.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to identify candidates who panic or contribute to chaos. Avoid these traps. 1. The panic reflector, describing a situation where you absorbed the stress of leadership and passed it down to your team, causing more mistakes. 2. The blame game, focusing your story on the person or team who created the high-pressure situation rather than the recovery. 3. The fragmented focus, trying to do 10 things at once under pressure instead of identifying the single most important action to stabilize the system. 4. The hero myth, claiming you solved a massive high-pressure crisis entirely alone without communicating with stakeholders. 5. The zero reflection, failing to explain how you decompressed the team and improved the system after the pressure subsided.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 composure signals. 1. Emotional regulation. Did the candidate remain analytical and calm when the environment was chaotic? 2. Triage accuracy. Did they correctly identify the most important business or technical priority under stress? 3. Command presence. Did they establish a clear structure for the team to follow? 4. Stakeholder management. Did they maintain trust with leadership while delivering difficult news? 5. Systemic repair. Did they use the pressure as a catalyst for a permanent architectural improvement? Strong candidates prove that high pressure is where their best engineering judgment emerges.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, describe a systemic vulnerability discovered during a high-stakes moment. Situation: 2 hours before a global product launch, we discovered a 0-day vulnerability in our core image processing library that would allow an attacker to execute remote code on our entire cluster. Task: I was the security lead for the launch. I needed to decide whether to cancel the global event, costing $2 million in marketing spend, or find a way to patch 500 servers in under 120 minutes. Action: I did not panic. I immediately halted the release train and established a war room. I realized that a full redeploy of every service would take 4 hours. I proposed a networking level mitigation. I wrote a global WAF rule to block the specific malicious byte signature that triggered the exploit, while simultaneously triggering an automated hot patch script that updated the library in place on our running nodes. Result: we secured the entire infrastructure in 75 minutes. The marketing launch proceeded on schedule with 0 security incidents. We confirmed the hot patch success via an automated scan 15 minutes before the first user arrived. Learning +L. I learned that our patching speed was limited by our deployment pipeline's cold start time. I subsequently led a project to implement blue-green immutable patching, which allows us to update core libraries globally in under 10 minutes without a full service rebuild. The +L proves you turned a near disaster into a world-class deployment capability.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite architectural composure. 1. Emotional regulation matched. You stopped the release train and established a war room instead of rushing a broken patch. 2. Triage accuracy matched. You recognized that the remote code execution risk was an existential threat to the launch. 3. Command presence matched. You proposed the 2-pronged attack, WAF block plus hot patch, to solve the problem within the 2-hour window. 4. Stakeholder management matched. You kept the marketing and leadership teams aligned on the 75-minute recovery timeline. 5. Systemic repair matched. The +L step, blue-green immutable patching, ensured the company is now immune to slow security responses. This demonstrates that you are a leader who can be trusted when the house is on fire.
Follow-up 1, clarification probe. How did you ensure the hot patch script would not crash the running servers right before the launch?
Answer: we used a canary node strategy. We ran the script on exactly one non-critical server first and monitored its health for 5 minutes. Once we verified the process was stable and the vulnerability was closed on that node, we used an automated orchestrator to roll the script across the rest of the cluster in parallel batches.
Follow-up 2, Level 3 or Level 4 junior depth. Technically, how did the WAF rule help if the vulnerability was inside the code library?
Answer: the WAF acted as a shield. The exploit required a specific malformed header to trigger the library's buffer overflow. By dropping any request containing that specific header pattern at the network edge, we prevented the attack traffic from ever reaching our servers, buying us the time we needed to apply the permanent code patch.
Follow-up 3, Level 5 or Level 6 senior depth. What if the marketing team had pushed back and said, "We do not care about the risk, the launch must happen now"? How would you handle that pressure?
Answer: I would move from technical risk to business liability. I would explain that shipping with a known RCE vulnerability is not just a bug. It is an invitation for a total data breach that would destroy the company's brand forever. I would frame the 75-minute delay as the only path to a successful launch, whereas an immediate release would be a catastrophic launch. A senior architect must be the guardian of the company's integrity, even against internal pressure.
Follow-up 4, Curveball. Looking back, do you think it was a failure of your earlier security reviews that a zero-day vulnerability was found so close to a launch?
Answer: by definition, a 0-day is something unknown to the industry until that moment. However, the pressure was a result of our lack of patching velocity. My failure was not missing the vulnerability. It was failing to build an infrastructure that could be patched in minutes rather than hours. That is exactly why I prioritized the blue-green patching project immediately after the launch.
Leadership pro tip, slow down to speed up.
The biggest mistake engineers make under pressure is moving too fast. High pressure creates a high probability of making a second, worse mistake. Senior architects know that spending 10 minutes to establish a war room and a clear plan allows the team to execute the next 60 minutes with 10 times more accuracy. In an interview, show that your first reaction to pressure is to establish order. Question 83. Tell me about a time you had too much work and had to prioritize. Note: interviewers use this question to evaluate your ability to manage cognitive load and align your engineering hours with business ROI. At companies like Amazon and Meta, senior engineers are expected to be strategic gatekeepers who can say no to low-value tasks to ensure high-stakes technical debt and features are delivered.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to detect candidates who are reactive or lack business judgment. Avoid these traps. 1. The heroic burnout claiming you prioritized by just working longer hours to finish everything. This signals poor planning and a lack of scalability. 2. The first-come, first-served method, handling tasks in the order they arrived, rather than by their business or technical impact. 3. The loudest voice bias, prioritizing the work requested by the most senior or aggressive stakeholder, regardless of the real business value. 4. Lack of communication, deciding to drop a task but failing to inform the stakeholder, causing a surprise failure later. 5. The task dumper, handing off your work to junior engineers without context, just to clear your own plate.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 alignment signals. 1. ROI calibration. Did the candidate quantify the business value or technical risk of each task? 2. Scope negotiation. Did they offer a phased approach or an MVP to satisfy multiple stakeholders? 3. Transparency. Did they communicate the trade-offs and cost of delay clearly to leadership? 4. Engineering health. Did they prioritize critical technical debt alongside feature work? 5. Decision framework. Did they use a structured system, for example, Eisenhower matrix, P0/P1/P2? Strong candidates prove that their time is a company asset that must be spent for maximum ROI.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer around a portfolio trade-off between features and platform stability. Situation: I was simultaneously leading a major PCI compliance audit and a new market expansion project. Both had hard deadlines in the same month, and my team was at 120% capacity. Task: I needed to prioritize our resources to ensure we did not lose our payment processing license compliance, while still allowing the business to hit its growth target, revenue. Action: I used an impact effort matrix. I realized the new market project was 40% UI polish. I negotiated with the product lead to defer the UI polish to Q1. I then introduced automated compliance linting to speed up the audit work. I explicitly told my manager, we are dropping the non-essential UI work to guarantee 100% compliance pass rate. Result: we passed the PCI audit with 0 findings. The new market launched on time with a core functionality MVP. The business earned $500,000 in new revenue, and the team avoided burnout. Learning plus L. I learned that stakeholders only push back on prioritization when they do not see the total capacity view. I subsequently built a team velocity and risk dashboard so leadership could see the impact of new requests in real time. The plus L proves you built a visibility system to prevent future prioritization conflicts.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite resource management. 1. ROI calibration matched. You correctly identified that compliance revenue protection was higher priority than UI polish revenue addition. 2. Scope negotiation matched. You did not just say no, you offered a core functionality MVP for the new market. 3. Transparency matched. You explicitly told your manager which tasks were being dropped and why. 4. Engineering health matched. You used automated linting to improve the long-term efficiency of the compliance work. 5. Decision framework matched. You used an impact effort matrix to move the conversation from opinions to logic. This demonstrates that you manage your own capacity like a CEO manages a budget.
Follow-up 1 clarification probe. What happened to the UI polish you deferred? Did it ever get finished?
Answer: yes. Because I had explicitly added it to the Q1 roadmap during the negotiation, it was already funded in our planning. We shipped the full UI enhancements 2 months later. By deferring it correctly rather than just ignoring it, I maintained the trust of the design and marketing teams.
Follow-up 2 Level 3 or Level 4 junior depth. How did you keep the team motivated when they were already at 120% capacity?
Answer: I removed the shadow work. I told the team to stop answering ad hoc Slack requests and point everyone to me. I made it clear that their only job was the audit and the MVP. By reducing their cognitive thrashing and giving them permission to focus, their morale improved even though the workload remained high.
Follow-up 3 Level 5 or Level 6 senior depth. What if the product lead had refused your MVP proposal and insisted on 100% of the UI features for the launch?
Answer: I would move to a resource auction model. I would say, I can deliver the 100% UI, but it requires me to pull 2 engineers off the PCI audit. This creates a high risk of us losing our payment license by Friday. Are you willing to accept that risk? Usually, when you frame a feature request against a license to operate risk, the business lead self-prioritizes the safer option.
Follow-up 4 Curveball. What if, halfway through the audit, a major production outage occurred that required your team's immediate attention? How does your prioritization change?
Answer: everything else stops. A production outage is a P00 day event. I would immediately invoke our on-call escalation protocol. We would prioritize restoration over both the audit and the new market. I would immediately notify the compliance and marketing stakeholders. We are in an active incident. All project work is paused for the next 4 hours. Integrity and availability always trump deadlines.
Leadership pro tip: manage the system, not the to-do list.
Junior engineers prioritize their daily list. Senior architects prioritize the system throughput. When you are asked about too much work, show the interviewer that you do not just work harder. You negotiate scope, you automate the boring parts, and you provide visibility to leadership. If you can explain the cost of delay for your tasks, you are already thinking like a director. Question 84. Tell me about a time when a project was at risk of failing. Note: interviewers use this question to evaluate your risk mitigation skills and your ability to maintain composure when high-stakes technical commitments are crumbling. At companies like Amazon and Google, senior engineers are expected to act as stabilizers who can identify the 20% of work that will save 80% of the project's value.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to detect engineers who panic or lack strategic prioritization. Avoid these traps. 1. The passive passenger, describing a project failure where you noticed the risk but did not intervene because it was not your official role. 2. The work harder fallacy, claiming you saved the project simply by forcing the team to work 14-hour days. This signals poor leadership and a lack of scalable thinking. 3. The miracle fix, attributing the success to a stroke of luck or a last-minute realization rather than a structured recovery plan. 4. Hidden failure, describing a project that was slightly late rather than one that was facing an existential technical or business threat. 5. Lack of transparency, failing to mention how you communicated the failure risk to stakeholders, which is a major signal for lack of integrity.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 turnaround signals. 1. Early risk detection. Did the candidate identify the point of no return before it was reached? 2. Ruthless prioritization. Did they have the courage to cut non-essential scope to save the core delivery? 3. Stakeholder realignment. Did they reset expectations with leadership using data rather than apologies? 4. Composure. Did they provide a calm, structured path forward for a panicked team? 5. Post-mortem integrity. Did they fix the systemic planning flaw that led to the risk in the first place? Strong candidates prove that a project at risk is an opportunity for elite prioritization.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer around a recovery pivot that saved a major business milestone. Situation: I was the lead architect for our global identity migration. 1 month before the hard decommissioning of our legacy auth provider, our performance tests showed that the new system's latency was 3 times higher than required for our Tier 1 mobile apps. Task: the project was at risk of failing the holiday launch window, which would have forced a $200,000 contract extension with the legacy vendor and delayed our mobile roadmap by 6 months. Action: I stopped all new feature work for 2 weeks. I conducted a scope audit and realized we were attempting to migrate 100% of users simultaneously. I pivoted the strategy to a hybrid state model. We migrated 95% of low-complexity users immediately, while building a lightweight proxy for the 5% high-complexity enterprise accounts to keep them on the legacy system temporarily. Result: we successfully decommissioned the primary legacy infrastructure on time, saving the $200,000 extension cost. The mobile apps launched successfully with sub-100 milliseconds latency for 95% of users. Learning plus L. I learned that atomic migrations are a high-risk anti-pattern. I subsequently established a phased release standard that mandates a multi-state coexistence period for any Tier 1 infrastructure change. The plus L proves you fixed the all-or-nothing cultural bias that almost killed the project.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite project turnaround skills. 1. Early risk detection matched. You caught the performance bottleneck during testing, not on the day of the cutover. 2. Ruthless prioritization matched. You identified that the 5% complex users were the bottleneck and isolated them to save the other 95%. 3. Stakeholder realignment matched. You moved the goalposts from 100% migration to 95% migration plus proxy to protect the business date. 4. Composure matched. You halted feature work to focus the team's energy on the single highest risk, latency. 5. Systemic improvement matched. The phased release standard ensured the organization never attempted a risky atomic move again. This demonstrates that you are a leader who prioritizes the mission over the plan.
Follow-up 1. Clarification probe. You mentioned the hybrid state model. How did you ensure data consistency between the new system and the legacy proxy during that 6-month period?
Answer: we used a dual-write pattern with a distributed transaction log. Every change in the legacy proxy was treated as an event and published to a Kafka topic that the new system consumed. We ran a consistency auditor job every hour that compared the checksums of the records in both systems to ensure zero drift during the transition.
Follow-up 2. Level 3 or Level 4 junior depth. How did you identify the 20% of work that would save the project? What metrics did you use?
Answer: I used a friction map. I analyzed our migration error logs and found that 80% of the performance lag was caused by just two specific edge case user attributes. By isolating those two attributes, the complex 5%, and moving them to the proxy, we removed 80% of the complexity with a single decision. Data always reveals where the leverage is.
Follow-up 3, Level 5 or Level 6 Senior Depth. The mobile team likely felt your 95% solution was a compromise of their original requirement. How did you manage their frustration?
Answer: I did not argue the requirements. I argued the launch probability. I showed them that the 100% plan had a 0% probability of launching on time. I gave them a success guarantee. The 95% plan would launch on time with perfect performance. By framing the choice as something great now versus everything broken later, I turned them into stakeholders in the compromise.
Follow-up 4, Curveball. What if the legacy vendor found out about your proxy strategy and refused to allow it because it technically bypassed their API usage policy?
Answer: I would treat that as a legal and vendor risk and escalate to our procurement and legal leads immediately. My role would be to provide the technical plan C, which would likely involve an emergency on-premise cache to reduce the legacy dependency without a full proxy. An architect must always have a contingency plan for vendor hostility in high-stakes migrations.
Leadership pro tip: cut the tail to save the body.
In engineering, the long tail of edge cases, the last 5%, often consumes 50% of the timeline. Senior architects know how to cut the tail, isolating the most complex part of a project to allow the majority of the value to ship on time. When a project is failing, stop looking for more time. Start looking for scope that can be deferred or isolated. Question 85. Describe a time when you had to fix a critical issue quickly. Note: interviewers use this question to evaluate your triage logic and your ability to act decisively to stop a bleeding business metric. At companies like Netflix and Amazon, the focus is on mitigation speed and risk management. Can you stabilize the platform without making the problem worse?
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to find candidates who are either paralyzed by fear or reckless in their actions. Avoid these traps. 1. The panic fixer making high-risk, unverified configuration changes in production just to do something. 2. The silo debugger, spending 2 hours trying to find a root cause while the system remains 100% down for customers. 3. The communication void, solving the problem quickly but failing to notify the on-call team, stakeholders, or users that an incident was occurring. 4. The reappearing incident, fixing the immediate symptom but failing to lead a post-mortem that addresses the architectural cause. 5. Lack of rollback plan, implementing a quick fix that is irreversible, potentially leading to permanent data corruption if it fails.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 crisis response signals. 1. Triage accuracy. Did the candidate correctly identify the most critical business impact? 2. Mitigation speed. Did they act to restore service before deep diving into the code? 3. Risk awareness. Did they choose the safest mitigation path rather than the cleverest one? 4. Collaborative command. Did they involve the right teams, SRE security, PR during the 15-minute window? 5. Systemic learning. Did they automate the detection of this specific failure afterward? Strong candidates prove that speed is a byproduct of preparation, not luck.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, describe a logic-based mitigation that stopped a catastrophic failure in minutes. Situation. During a global firmware update for our IoT fleet, I noticed a 5% failure rate in our ingestion API. The error logs indicated a schema mismatch, and the retry logic was beginning to create a thundering herd that threatened the primary database. Task. I had a 10-minute window to stop the 5% of failing devices from crashing the system for the other 95% of our users. Action. I did not try to debug the firmware. I implemented load shedding at the edge. I deployed a temporary header-based rate limit at the API gateway that explicitly dropped all requests coming from the new firmware version. This isolated the failing devices into a hold state, instantly removing the thundering herd from the database. Result: the database stabilized in 3 minutes, Total downtime for the healthy fleet was 0. We identified the firmware bug in a lab 2 hours later and rolled out a corrected patch that evening. Learning plus L. I learned that our deployment strategy lacked a kill switch for specific client versions. I subsequently implemented client version gating in our gateway, allowing us to disable any faulty client version globally with a single API call. The plus L proves you turned a crisis response into a permanent client control infrastructure feature.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite mitigation-first engineering. 1. Triage accuracy matched. You recognize that the failing 5% firmware was a threat to the 95% healthy fleet. 2. Mitigation speed matched. You used a header-based rate limit to stop the impact in under 3 minutes. 3. Risk awareness matched. You did not roll back the whole DB. You surgically targeted the bad traffic at the edge. 4. Collaborative command matched. You stabilized the infrastructure before the firmware team even finished their initial triage. 5. Systemic learning matched. The client version gating tool ensured that bad clients can never take down the backend again. This demonstrates that you prioritize integrity over elegance during an active incident.
Follow-up 1. Clarification probe. By dropping the traffic for the new firmware, did not you essentially brick or disable those devices for the users?
Answer: temporarily, yes. But the trade-off was binary. Either 5% of users were disabled while we fixed the patch, or 100% of users were disabled because the database crashed. I chose to preserve the service for the vast majority while creating a safe window to fix the minority issue. Leadership almost always supports this blast radius containment strategy.
Follow-up 2. Level 3 or Level 4 junior depth. How did you know which header to use for the rate limit so quickly?
Answer: I looked at the user agent and XApp version headers in our Kibana logs. I compared a success request with a failure request. The version mismatch was obvious in the metadata. In a crisis, the request metadata is often more useful than the application logs for quick triage.
Follow-up 3. Level 5 or Level 6 senior depth. What was your communication plan during those 22 minutes? Did you alert the customers?
Answer: I triggered our customer outreach playbook. I assigned a technical writer to post a specific partial outage notice on our status page, stating that users on the latest firmware might experience connectivity issues. This prevented a flood of support tickets and allowed the customer success team to proactively manage the affected users while we worked on the fix.
Follow-up 4. Curveball. What if the header-based rate limit did not work because the firmware bug caused the devices to randomize their headers? What was your plan B?
Answer: Plan B would have been regional isolation. I would have temporarily severed the connection to the specific AWS availability zone or region where the bulk of the updates were being pulled. This is a much larger hammer, but it is the final defense to protect the primary database from permanent IOPS exhaustion or lock contention.
Leadership pro tip: stabilize the patient, then find the disease.
In a production emergency, junior engineers act like doctors trying to diagnose a disease while the patient is bleeding out. Senior engineers act like paramedics. They stop the bleeding first, mitigation, ensure the patient is stable, availability, and only then do they go to the hospital to find the root cause, RCA. Always show the interviewer that you prioritize mitigation speed over root cause speed.
Category 10 wrap-up: composure under pressure.
You have mastered the pressure and deadlines category. You have proven that a senior architect does not meet deadlines through heroic overtime, but through strategic triage, risk mitigation, and early stakeholder alignment. You have demonstrated that high-pressure situations are where your engineering judgment is most valuable, acting as a stabilizer for the entire organization.
Transition: the perpetual student.
Stability under pressure is a requirement, but stagnation is a risk. In an industry that moves as fast as technology, the most valuable asset an architect possesses is not what they already know, but how fast they can learn what they do not. This brings us to Category 11, Learning and Growth, where we evaluate your intellectual humility and your ability to scale your knowledge across the team.
Check the comments section or description of this video. I have given a link to download a magical bundle that teaches you to develop Google Caliber thinking and provides a complete mental model in a way that screams Google SRE. This bundle is the only end-to-end system that teaches you to think, act, and communicate like a Google SRE before you even set foot in the interview. It is the only structured playbook for Google's impossible rounds like NALS and troubleshooting. Most candidates sound like outsiders. The magic of this bundle is makes you sound like you already work at Google. Cracking the Google SRE interview is one of the toughest challenges in tech. Most resources only prepare you for parts of the process, a few coding problems here, some system design notes there. But Google's SRE loop is multidimensional. It tests how you think, act, and communicate. Imagine preparing with scattered LeetCode problems, random design blog posts, and still wondering how to survive the NALS round. That's how most candidates prep, fragmented, incomplete, and unstructured.
Now, imagine having one complete system.
Imagine instead you had one system that gave you everything.
A system that gives you
1. End-to-end coverage of every single round. 2. Playbooks that turn chaos like NALS and troubleshooting into structure. 3. Realistic practice drills that simulate the actual interview loop. 4. Insider language and frameworks that make you sound like you already belong. That's what this bundle does. It's not just prep material, it's a game changer because it transforms the way you think, act, and communicate into the exact style Google interviewers are looking for.
the Google SRE interview bundle covers
1. Recruiter screen and resume prep, tailored templates and scripts that pass the first filter. 2. Coding rounds, Python and Go question and answers designed for SRE-style reliability tasks. 3. System design and NALS, playbooks for both high-level design and Google's infamous NALS round. 4. Troubleshooting and debugging, a step-by-step handbook to master war-room-style scenarios. 5. Behavioral and Googleness, real reliability scenarios that make you sound like you already work at Google. 6. Post-interview and hiring committee, an insider breakdown of how decisions are made. 7. Salary negotiation, recruiter-proof scripts and strategies to maximize your offer confidently. If LeetCode is practice mode, this bundle is the real game simulation. It doesn't just prepare you for questions. It prepares you to think, act, and communicate like a Google SRE before you even set foot in the interview.
Category 11, Learning and Growth.
Interviewers at companies like Google and Apple use this category to measure your growth mindset. They want to see if you can take critical feedback without becoming defensive, if you can learn complex new technologies in days rather than months, and how you mentor others to raise the collective engineering bar. At the staff level, your growth is measured by how much you help the organization grow.
Learning and Growth Masterclass Scenarios.
These 7 scenarios test your ability to adapt, evolve, and elevate the people around you. 86. Tell me about a time you learned a new skill quickly. 87. Tell me about a time you received critical feedback. 88. Tell me about a time you had to adapt to change. 89. Describe a time when you improved after failure. 90. Tell me about a time when you mentored someone. 91. Tell me about a time when you helped someone improve their performance. 92. Tell me about giving tough feedback to a peer or direct report. Senior architects do not just grow their skills, they grow the entire engineering culture. Question 86. Tell me about a time you learned a new skill quickly. Note, interviewers use this question to evaluate your learning synthesis speed and your ability to apply new, complex technology to solve an immediate production crisis. This is a vital signal at companies like Google and Meta, where engineers must often dive into specialized or proprietary infrastructure they have never seen before.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to filter out candidates who learn at a surface level or lack technical curiosity. Avoid these traps. 1. The tutorial learner describing learning something simple like a new library syntax without applying it to a complex engineering challenge. 2. The copy-paste fix, admitting you used a new tool by copying a template without understanding the underlying mechanics or trade-offs. 3. The academic pursuit, learning something interesting but failing to translate that knowledge into a measurable business or technical result. 4. Lack of resourcefulness, needing a formal training course or a mentor to explain everything rather than performing independent deep research. 5. The surface diagnosis, admitting you learned the how syntax, but completely ignored the why architecture and physics.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 learning agility signals. 1. Synthesis speed. How quickly did the candidate move from zero knowledge to a deployed technical solution? 2. Technical depth. Did they learn the low-level mechanics of the tool, for example, memory management, thread models? 3. Application under fire. Was the learning directly tied to resolving a production outage or a major project blocker? 4. Resourcefulness. Did they use the source of truth, source code, kernel docs, to learn rather than just blogs? 5. Knowledge multiplier. Did they document or teach what they learned to the rest of the team? Strong candidates prove they are self-winding engineers who can master any stack.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, describe learning a lower-level technology to solve a distributed systems mystery. Situation: our high-throughput sidecar proxy started experiencing mysterious memory corruption bugs that caused random pod crashes in our production mesh. I had zero experience with Rust, but the proxy was written in it. Task: I had a 48-hour window to identify the corruption point and deploy a patch before we were forced to roll back the entire service mesh migration. Action: I performed a 24-hour deep dive into Rust's memory ownership and unsafe blocks. I used the LLVM debugger to inspect core dumps and map the memory addresses to the source code. I identified that a third-party library was using an incorrect pointer offset in a FFI, foreign function interface call. Result: I wrote a memory-safe wrapper in Rust that intercepted the FFI calls and validated the offsets. The pod crashes stopped immediately. The service mesh migration succeeded, improving global throughput by 20%. Learning +L. I learned that memory safety is not just a language feature. It is a production requirement at scale. I subsequently authored a Rust safety audit checklist and trained our backend leads on identifying unsafe pointer logic. The +L, learning, shows you turned a personal deep dive into a new organizational capability.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite technical agility. 1. Synthesis speed matched. You moved from zero Rust to a memory-safe production patch in under 48 hours. 2. Technical depth matched. You moved past syntax to learn memory ownership, pointers, and FFI mechanics. 3. Application under fire matched. The learning was the only path to saving a global service mesh migration. 4. Resourcefulness matched. You used the LLVM debugger and source code inspection to find the ground truth. 5. Knowledge multiplier matched. The +L step, the safety audit, ensured the team inherited your new expertise. This demonstrates that you solve problems at the architectural level, regardless of the language.
Follow-up 1, clarification probe. How did you ensure your quickly learned Rust code was safe enough to run in production without creating a second incident?
Answer: I leaned on the compiler as a partner. I wrote the fix using the strictest ownership rules possible and ensured the code was 100% safe Rust with zero unsafe blocks. I then ran the new sidecar through a 4-hour high-concurrency fuzzing test in our staging environment to verify that no new memory leaks or panics were introduced.
Follow-up 2, Level 3 or Level 4 junior depth. What was the specific technical concept in Rust that was hardest to grasp in that 48-hour window?
Answer: understanding the lifetime of pointers across the FFI boundary was the biggest hurdle. Because the memory was being allocated in C and used in Rust, the standard borrow checker could not automatically track it. I had to learn how to use manually drop and box to explicitly manage the heap memory lifecycle to prevent the corruption.
Follow-up 3, Level 5 or Level 6 senior depth. Why did you choose to learn Rust and fix it yourself, rather than escalating to the specialized infrastructure team who originally built the proxy?
Answer: the infrastructure team was tied up in a separate SEV0 outage. My team was the customer of the proxy, and we were the ones whose launch was blocked. At staff level, I believe in full-stack ownership. If I have the technical baseline to dive into the dependency and unblock my own project, I will always do so rather than waiting for another team to provide a fix.
Follow-up 4, curveball. What if you had spent the 48 hours learning Rust but could not find the fix? Would that have been a failure of judgment?
Answer: no. I set a strict 12-hour checkpoint for my learning. If I had not made progress in the first 12 hours, I would have pivoted to a mitigation strategy, like bypassing the sidecar proxy entirely for the launch. In a crisis, rapid learning is a high ROI experiment, but you must always have a hard time box and a fallback plan to protect the business.
Leadership pro tip: learn the mechanics, not the syntax.
Junior engineers focus on learning how to type in a new language. Senior architects focus on learning the thread and memory model. When you are asked about learning quickly, show the interviewer that you go straight for the internal physics of the technology. If you understand how a system manages memory and concurrency, the syntax becomes trivial. Question 87. Tell me about a time you received critical feedback. Note: interviewers use this question to evaluate your ego strength, coachability, and emotional maturity. Senior engineers at companies like Netflix and Apple are expected to view feedback as data for improvement rather than a personal attack. They want to see that you can separate your technical identity from your technical output.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to identify defensive or stagnant candidates. Avoid these traps. 1. The non-critical feedback, admitting to a tiny, safe piece of feedback like "I need to talk louder in meetings." This shows a lack of vulnerability. 2. The defensive response, spending the interview explaining why the feedback giver was actually wrong or did not understand the context. 3. The self-correcting feedback, claiming you received feedback for a mistake you had already fixed. This hides the real emotional work of receiving tough news. 4. The emotional reaction, describing the feedback in a way that shows you are still bitter or resentful about the interaction. 5. No change in behavior, failing to describe the specific, measurable steps you took to evolve after receiving the feedback.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 ego management signals. 1. Receptivity: did the candidate listen and ask clarifying questions without getting defensive? 2. Internalization: did they pause to evaluate the feedback objectively against the data? 3. Transparency: did they admit the feedback was valid to their team or manager? 4. Action orientation: did they implement a concrete behavioral or technical shift immediately? 5. Outcome focus: did the change result in a measurable improvement in their performance or the system? Strong candidates prove that their ultimate loyalty is to the truth, not their pride.
Here is the FAANG level senior answer, STAR+L.
Pass the senior bar. Structure your answer around feedback regarding your architectural judgment. Situation: I had just finished designing a new multi-region event mesh for our financial ledger. I was extremely proud of the design, which used complex distributed consensus logic to ensure zero data loss. Task: I presented the design to our principal architect during a formal review. My goal was to get immediate approval for the implementation phase. Action: the principal gave me brutal feedback. He said my design was intellectually beautiful but operationally fragile. He pointed out that while it solved for 0.001% edge cases, it was so complex that our on-call engineers would never be able to debug it during an outage. I felt defensive initially, but I stopped, asked him to walk me through a specific failure scenario, and realized he was right. Result: I scrapped the complex consensus logic and pivoted to a much simpler at least once delivery model with idempotency guards. It was 40% simpler to build and 100% easier to monitor. Learning plus L. I learned that senior architecture is about maintainability over cleverness. I now use a debuggability score for every design, ensuring that the people who run the code are just as important as the people who write it. The plus L, learning, shows you turned a painful critique into a new architectural principle.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite professional maturity. 1. Receptivity matched: you stopped your defense and asked for a specific failure scenario to see the principal's perspective. 2. Internalization matched: you admitted the design was operationally fragile, a hard technical truth to accept. 3. Action orientation matched: you did not just tweak the design, you scrapped the complex parts and rebuilt the core logic. 4. Outcome focus matched: the new design was 40% simpler, directly improving the team's operational safety. 5. Systemic improvement matched. The debuggability score ensures you never repeat the mistake of over-engineering. This shows an architect who cares more about the system's success than being the smartest person in the room.
Follow-up 1. Clarification probe. After the principal gave you that feedback, did you feel that your reputation as an architect was damaged?
Answer: no. In high-performing cultures like Google or Amazon, the most respected engineers are the ones who can pivot the fastest when presented with a better truth. By accepting the feedback and immediately delivering a simpler, more robust design, I actually increased my trust with the principal. It proved I was a pragmatist who prioritized the business over my own ego.
Follow-up 2. Level 3 or Level 4 junior depth. How did you specifically make the new design easier to monitor compared to the original one?
Answer: the original design used a complex distributed state machine that required looking at 5 different logs to trace a single transaction. The new design used a flat event ledger with a single trace ID. We could now set up a single dashboard that showed exactly where every transaction was in the pipeline, making the mean time to repair, MTTR, significantly lower.
Follow-up 3. Level 5 or Level 6 senior depth. Giving and receiving brutal feedback can create tension in a team. How did you maintain your relationship with that principal architect afterward?
Answer: I followed up with a one-on-one a week later to thank him. I told him, "Your feedback on the operational fragility of that mesh was a turning point for me." By closing the loop and acknowledging the value of his critique, I turned a high-friction meeting into a long-term mentorship. Elite teams thrive on high-challenge, high-support relationships.
Follow-up 4. Curveball. What if the principal was actually wrong, and your original complex design was the only way to meet the zero data loss requirement? Would you have still accepted the feedback?
Answer: I would have disagreed and committed to a data-gathering phase. I would have said, "I understand the maintainability concern. Let's run a 3-day stress test on the simpler version. If it maintains the required data integrity, we go with your approach. If not, we look at how to make the complex version more observable." You do not argue with feedback. You test the underlying assumptions with data.
Leadership pro tip. Feedback is a gift of time.
Junior engineers view critical feedback as a roadblock. Senior architects view it as a shortcut. Every piece of tough feedback is someone else giving you the answer key to a problem you have not seen yet. If you can prove in an interview that you seek out feedback early specifically to find your own blind spots, you signal the highest level of leadership maturity. Question 88. Tell me about a time you had to adapt to change. Note: interviewers use this question to evaluate your flexibility and your ability to maintain velocity during organizational or technical shifts. In high-growth companies like Amazon and Meta, change is the only constant. They are looking for architects who can lead a team through a strategy pivot without losing morale or technical direction.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to identify rigid or resistant candidates. Avoid these traps. 1. The passive passenger, describing a time change happened to you but you just followed orders without adding any strategic value to the transition. 2. The slow adopter, admitting that the change caused your productivity to drop for weeks or months while you adjusted. 3. The complainer, spending the interview describing why the change was a bad idea or how much better things were before. 4. Lack of influence, failing to mention how you helped your team or peers adapt to the new reality. 5. The brittle architect, describing a change that broke your original design because you failed to build flexibility into your architecture from the start.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 adaptability signals. 1. Strategic speed. How quickly did the candidate realign their technical roadmap with the new business direction? 2. Ambiguity management. Did they maintain a structured approach while the new requirements were still being defined? 3. Team stabilization. Did they act as a shock absorber to keep their team focused and productive? 4. Pragmatism. Did they let go of their previous work without sunk cost bias? 5. Systemic evolution. Did they use the change to build a more flexible architecture for the future? Strong candidates prove that change is a catalyst for innovation, not a distraction.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer around a massive cloud or cultural pivot. Situation: I was halfway through a 12-month project to migrate our core services from on-premise servers to a self-managed Kubernetes cluster on AWS. Suddenly, the CTO announced a public cloud-first mandate, ordering all teams to move directly to AWS Fargate and manage services to reduce operational overhead. Task: I had to immediately pivot our 6 months of Kubernetes architecture work and lead the team through a transition to a serverless or managed architecture without missing our decommissioning deadline. Action: I did not fight the mandate. I spent 48 hours performing a gap analysis between our K8 seconds design and Fargate. I realized that while we lost control, we gained scale. I restructured the roadmap into a container-first migration, allowing us to reuse our Docker images while stripping out the complex K8 seconds manifest logic. I hosted a serverless masterclass for my team to reskill them on AWS-managed IAM and VPC networking. Result: we hit the original decommissioning date. We reduced our projected operational toil by 60% compared to the K8 seconds plan. The team morale actually increased as they realized they could now focus on features instead of patching nodes. Learning plus L. I learned that architectural portability is the most valuable property. I now design all services to be infrastructure agnostic, using standard containers and environment-driven configs, so we can pivot between compute providers in days, not months. The plus L, learning, shows you turned a forced change into a new standard for cloud portability.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite architectural adaptability. 1. Strategic speed matched. You executed a full gap analysis and realigned the 12-month roadmap in just 48 hours. 2. Shock absorber matched. You hosted a serverless masterclass to turn your team's anxiety into a learning opportunity. 3. Pragmatism matched. You abandoned 6 months of work without sunk cost bias to follow the new strategic mandate. 4. Outcome focus matched. You hit the decommissioning date while delivering a 60% reduction in operational toil. 5. Systemic evolution matched. You introduced infrastructure agnostic design rules to future-proof the entire org. This demonstrates that you are a leader who steers the ship through the storm, rather than complaining about the weather.
Follow-up 1. Clarification probe. What happened to all the custom Kubernetes tooling and scripts your team built over those 6 months? Was all that work wasted?
Answer: it was not wasted. It was archived. We kept the core Docker container logic, which was 70% of the effort. We discarded the K8 seconds specific orchestration scripts. In a fast-moving enterprise, you have to be comfortable with sunk costs. I treated those 6 months as an intensive R&D phase that gave us the deep container expertise required to make the Fargate migration a success.
Follow-up 2. Level 3 or Level 4 junior depth. Technically, what was the biggest difficulty in moving from self-managed Kubernetes to AWS Fargate?
Answer: the networking and IAM security models were the biggest shift. In K8 seconds, we managed service-to-service auth ourselves. In Fargate, we had to master IAM roles for tasks and security group orchestration. I had to quickly learn how to map our complex K8 seconds network policies to standard AWS VPC rules to ensure our security posture remained identical.
Follow-up 3. Level 5 or Level 6 senior depth. Pivots like this often cause senior engineers to leave because they feel their expertise, like K8 seconds, is no longer being utilized. How did you retain your top talent?
Answer: I reframed the expertise definition. I told them, you are not a Kubernetes expert, you are a distributed systems expert. Kubernetes was just the current implementation detail. I showed them that mastering the cloud-native ecosystem, Fargate, IAM, RDS, made their resumes even more valuable in the current market. By connecting the company's change to their personal career growth, I kept 100% of my senior staff during the pivot.
Follow-up 4. Curveball. What if the CTO's Fargate mandate was technically inferior to your K8 seconds setup for our specific high-performance needs? Would you have still adapted so quickly?
Answer: I would have disagreed and committed. I would have formally documented the performance gap and the projected cost increase in an impact summary to ensure the CTO had all the facts. However, once the decision was final, I would execute the Fargate pivot with 100% effort. A senior architect must be able to thrive even in suboptimal technical environments to ensure the business succeeds.
Leadership pro tip: change is an IQ test.
Junior engineers fight change because they feel it invalidates their past effort. Senior architects welcome change because they know it tests the organization's metabolic rate. If you can show an interviewer that you can pivot a massive project without losing speed or team trust, you prove you possess the high-level leadership required for director and principal roles. Question 89. Describe a time when you improved after failure. Note, interviewers use this question to evaluate your technical resilience and your ability to close gaps in your own judgment or skill set. This is a primary signal for the growth mindset and self-awareness required at companies like Google and Apple.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to find candidates who are stagnant or lack the ability to self-correct. Avoid these traps. 1. The minor mistake pivot, describing a failure so small that the improvement was trivial and did not require real growth. 2. The forced learning, admitting you only improved because a manager mandated it, showing a lack of internal drive. 3. The theoretical improvement, saying you learned a lesson but failing to show a concrete, technical change you implemented in your next project. 4. The one-off fix, fixing the specific bug you caused but failing to fix the personal or team process that allowed the bug to exist. 5. Lack of vulnerability, describing the failure in a way that minimizes your own responsibility, making the improvement seem unnecessary.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 resilience signals. 1. Self-diagnostic rigor. Did the candidate perform a deep personal root cause analysis on why they failed? 2. Technical evolution. Did they acquire a new difficult technical capability as a result of the failure? 3. Structural correction. Did they implement a new safeguard or pattern into their engineering workflow? 4. Consistency. Did they demonstrate the improved behavior over a long period in subsequent projects? 5. Humility. Did they share their failure and the lesson with the team to prevent others from failing? Strong candidates prove that their most robust technical skills were forged in their worst failures.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer around a failure of complexity management and your subsequent evolution. Situation: I was leading a high-speed migration of a monolithic database to a sharded architecture. During the pilot, a critical race condition occurred that corrupted 0.5% of user metadata. I had ignored the advice to implement a global lock because I thought it would hurt performance too much. Task: I failed to balance data integrity with system throughput. My goal was to recover the data and ensure I never made a performance over correctness error again. Action: I did not just fix the bug. I spent a month performing an intensive deep dive into distributed systems theory and formal verification methods. I learned how to use TLA+, a formal specification language, to model our system state transitions. I redesigned the sharding logic, this time using a verified state machine that guaranteed consistency before I even wrote a line of code. Result: the second migration phase was 100% successful with zero data drift. By using formal modeling, we identified 3 other hidden race conditions that would have caused outages months later. Learning plus L. I learned that intuition is not a substitute for formal logic in distributed systems. I subsequently authored an architectural verification playbook and now require TLA+ modeling for any project involving complex asynchronous state. The +L, learning, shows you turned a technical failure into a new standard for high-assurance engineering.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite technical and professional evolution. 1. Self-diagnostic rigor matched. You correctly identified that your bias for performance caused you to ignore data integrity risks. 2. Technical evolution matched. You learned TLA+, a high-level formal modeling skill to solve your lack of distributed systems depth. 3. Structural correction matched. You redesigned the system using a verified state machine instead of just patching the code. 4. Consistency matched. You proved the new approach by successfully migrating the remaining dataset with zero drift. 5. Humility matched. The +L step, the verification playbook, proved you scaled your personal lesson to the entire organization. This demonstrates an architect who converts scars into systemic guardrails.
Follow-up 1. Clarification probe. When you realized you had corrupted 0.5% of the metadata, did you try to fix it silently, or did you alert the stakeholders immediately?
Answer: I followed a strict zero-delay notification policy. As soon as the checksum mismatch was confirmed, I declared a SEV1 incident, notified the product and legal leads, and admitted that my design assumption had failed. Transparency during a failure is the only way to maintain the trust capital required to lead the recovery.
Follow-up 2. Level 3 or Level 4 Junior Depth. How did TLA plus modeling specifically help you find the race conditions that your standard unit tests missed?
Answer: unit tests only test paths the developer can imagine. TLA Plus tests the entire state space. It mathematically explores every possible combination of network delays and out-of-order events. It found a specific sequence where a network retry and a database timeout overlapped in a way that our integration tests would have only caught in production once every million requests.
Follow-up 2. Level 5 or Level 6 Senior Depth. Formal modeling like TLA plus adds significant time to the design phase. How do you justify that extra overhead to a product team that wants to move fast?
Answer: I frame it as incident prevention ROI. I showed them that the month I spent learning and modeling the system was 10 times cheaper than the 2 weeks our team spent on 24/7 incident response after the first failure. I now use a criticality tier system. We do not model everything, but if a system is stateful and critical, the cost of not modeling it is an unacceptable business risk.
Follow-up 4. Curveball. Looking back, if you had not failed and corrupted the data, do you think you would have ever learned formal verification, or would you still be relying on your intuition today?
Answer: I likely would have continued relying on intuition until a much larger, more catastrophic failure occurred. That is why I value that specific failure so much. It forced me to realize the limits of my own knowledge before the stakes got even higher. A controlled failure early in an architect's career is often the best thing that can happen to their long-term reliability.
Leadership pro tip. Improvement must be structural.
Junior engineers improve by trying harder. Senior architects improve by engineering better. When an interviewer asks about improving after failure, they aren't looking for a promise to be more careful. They are looking for the new tool, the new process, or the new architectural pattern you implemented to make sure that specific type of failure is physically or logically impossible in the future. Question 90. Tell me about a time when you mentored someone. Note: interviewers use this question to evaluate your ability to scale your expertise and grow the talent around you, which is a core leadership signal for hire and develop the best at companies like Amazon and Meta. At the senior level, your impact is measured by how much you elevate the team's baseline, not just your individual output.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to filter out solo heroes or condescending mentors. Avoid these traps. 1. The savior complex, describing how you mentored someone by just doing their work for them so the project would not fail. This is enabling, not mentoring. 2. The vague advice, saying you just gave encouragement or tips without a structured plan for their technical or professional growth. 3. The forced mentor, admitting you only mentored them because your manager assigned them to you, rather than taking proactive ownership of their growth. 4. The one-off interaction, describing a single code review or a 30-minute chat as mentoring. True mentoring is a sustained commitment over time. 5. No measurable outcome, failing to show how the person improved. For example, they got promoted, took on a larger project, or reduced their PR rejection rate.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 talent development signals. 1. Diagnosis: did the candidate identify the specific skill or behavioral gap, for example, design thinking, communication, confidence? 2. Structured planning: did they create a roadmap with milestones for the mentee? 3. Empowerment: did they give the mentee safe-to-fail opportunities to lead? 4. Feedback loop: did they provide regular, high-bandwidth and actionable feedback? 5. Scaling impact: did they build a mentorship framework that other seniors in the org could use? Strong candidates prove they are force multipliers who build the next generation of leaders.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, Structure your answer around growing a high-potential engineer into a high-impact lead. Situation: a junior engineer on my team had exceptional coding skills, but was struggling to get his architectural designs approved by the review board. He was becoming frustrated and starting to withdraw from technical discussions. Task: I realized he was hitting a communication gap, not a technical gap. I needed to coach him on how to think and write like an architect so he could lead his own feature tracks. Action: I initiated a 3-month architecture mentorship plan. I did not write his docs. Instead, I had him shadow my RFC process for 2 weeks. Then, I gave him a non-critical feature and required him to write a mock design doc for me first. I provided brutal but private feedback on his trade-off analysis. I coached him on the influence without authority skills needed to handle a review board. Result: within 1 quarter, he successfully defended a major redesign of our telemetry pipeline. His PR rejection rate dropped by 60%, and he was promoted to mid-level engineer at the end of the year. Learning plus L. I realized that mentorship is often just gap bridging. I subsequently built a design document template and a peer review checklist for our entire department to help other juniors bridge the same gap faster. The plus L, learning, shows you scaled your individual mentorship into a departmental capability.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite talent leadership. 1. Diagnosis matched. You identified the root cause as a communication gap rather than a lack of coding talent. 2. Structured planning matched. You used a phased shadow to mock to lead roadmap over a 3-month period. 3. Empowerment matched. You gave him a non-critical feature to lead, creating a safe environment to practice high-stakes design. 4. Feedback loop matched. You provided private, intensive trade-off coaching before the public review board meeting. 5. Scaling impact matched. The plus L step, design templates and checklists, institutionalized your coaching for the whole org. This demonstrates that your value is not just in your code but in the growth of the engineers around you.
Follow-up 1. Clarification probe. Did you have to spend a significant amount of your own engineering time to mentor him? How did that affect your deliverables?
Answer: I treated mentorship as a P1 feature. I allocated 4 hours a week specifically for our one-on-one seconds and doc reviews. I communicated this to my manager as a team scalability goal. By investing 40 hours over a quarter, I created a new engineer capable of leading his own tracks, which permanently increased our team's total velocity. Mentorship is a capital investment, not a distraction.
Follow-up 2. Level 3 or Level 4 junior depth. What was the single most important soft skill you taught him during those 3 months?
Answer: the art of pre-alignment. He used to walk into review boards with a finished design and get surprised by the pushback. I taught him to socialize his design with key stakeholders 48 hours before the meeting. By the time the formal review happened, the conflict had already been resolved in private. This is the difference between a coder and a leader.
Follow-up 3. Level 5 or Level 6 senior depth. Mentoring someone for promotion can create jealousy in the team. How did you ensure the rest of the team did not feel you were playing favorites?
Answer: transparency was the key. I announced the architecture mentorship as an open framework. I told the team, I'm helping times with design docs this quarter. If anyone else wants to shadow these sessions or wants a similar plan, my door is open. By making the mentorship criteria-based rather than personality-based, it became a standard for everyone to aspire to, rather than a secret club.
Follow-up 4. Curveball. What if the junior engineer had failed to improve after 3 months of your coaching? How would you handle that conversation?
Answer: I would perform a joint post-mortem on our plan. I would ask, did the milestones match your learning style? Did I provide the right context? If the effort was high but the output remained low, I would pivot. Not everyone is ready to be a tech lead. I would help him find a role where his exceptional coding could still shine, like an individual contributor deep fixer, while we pause the architectural leadership track.
Leadership pro tip. Mentorship is scalable architecture.
Junior engineers think mentoring is about being nice. Senior architects think mentoring is about scalable redundancy. If you are the only person who can design systems on your team, you are a single point of failure. Mentoring others to take your place is the only way you can free yourself to solve the next, larger problem. Always hire and develop your own replacement. Question 91. Tell me about a time when you helped someone improve their performance. Note: interviewers use this question to evaluate your ability to identify specific performance bottlenecks in people and apply structured coaching to raise the team's baseline, which is a major leadership signal at companies like Amazon and Google.
Here are the critical red flags, the instant rejection signals.
Interviewers watch for candidates who confuse performance management with micromanagement. Avoid these traps. 1. The Band-Aid fix, describing how you just did the person's work for them to meet a deadline which solves the sprint but hides the performance gap. 2. The vague encourager, telling someone to be more proactive or work faster without providing measurable technical milestones. 3. The immediate escalation, running to a manager to put the person on a PIP before attempting peer-to-peer coaching and discovery. 4. Lack of accountability, helping the person but failing to set clear consequences or check-ins to ensure the improvement was permanent. 5. Generic solutions, applying a one-size-fits-all approach rather than diagnosing the specific root cause of that person's struggle.
Here are the signals the interviewer is scoring.
While you answer this question, interviewers evaluate these 5 performance leadership signals. 1. Diagnostic capability. Did the candidate identify why the person was failing? Skill gap, context gap, or behavioral gap? 2. Structured feedback. Did they deliver clear, evidence-based feedback regarding the performance gap? 3. Technical enablement. Did they provide specific artifacts, pairing, or resources to close the gap? 4. Accountability. Did they establish a timeline and measurable goals for the improvement? 5. Impact. Did the person's performance actually improve and stay improved over time? Strong candidates prove they can scale the team's velocity by fixing the weakest links.
Here is the FAANG level senior answer, STAR+L.
Pass the senior bar. Structure your answer around coaching an engineer through a complexity gap. Situation: a senior peer on my team was struggling to lead a high-priority cloud migration. While they were a brilliant coder, their project planning was fragmented, causing our deployment milestones to slip by 2 weeks. Task: as the tech lead, I needed to help them bridge the gap from individual contributor to project leader to ensure the migration did not fail. Action: I did not take over the project. I scheduled a private strategy audit. I used our sprint data to show them where the bottlenecks were. I introduced them to work breakdown structures and coached them on how to map dependencies across teams. I required them to draft a milestone recovery plan which I reviewed and refined with them in daily 15-minute syncs. Result: the engineer's planning became significantly more structured. We recovered the 2-week delay within 1 month and hit the final decommissioning date on time. The engineer's subsequent project had 0 planning-related delays. Learning +L. I realized that senior engineers often fail not due to lack of effort, but because they lack a strategic toolkit. I subsequently built a project lead framework, a set of templates for scoping and dependency mapping, now used by all aspiring leads in the org. The +L shows you institutionalized the coaching logic, so the whole team leveled up.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite performance leadership. 1. Diagnostic capability matched. You correctly identify that the gap was project planning, not coding talent. 2. Structured feedback matched. You use sprint data to show the performance gap objectively rather than making it personal. 3. Technical enablement matched. You introduced a work breakdown structure and coached them on dependency mapping. 4. Accountability matched. You required them to draft the recovery plan themselves, keeping them in the driver's seat. 5. Impact matched. You quantified the recovery, 2 weeks recovered, and the long-term success of their next project. This shows you are an architect who builds people as well as systems.
Follow-up 1. Clarification probe. When you showed them the data about the missed milestones, how did they react? Did they get defensive?
Answer: initially, there was some resistance. They blamed the unclear requirements of the other teams. I validated that frustration but moved the focus back to ownership. I said, I agree the requirements are messy, but our job as leads is to clear that mess, not be blocked by it. By framing the problem as a leadership challenge to be solved, they moved from defensive to curious.
Follow-up 2. Level 3 or Level 4 junior depth. How did you ensure that your daily 15-minute syncs did not turn into micromanaging the engineer?
Answer: I made the engineer the owner of the meeting. They set the agenda, and presented the progress against the recovery plan milestones. My role was only to ask what is the biggest blocker for tomorrow, and have you socialized this change with the SRE team? By being a consultant rather than a supervisor, I maintained their autonomy while providing the necessary guardrails.
Follow-up 3, Level 5 or Level 6 Senior Depth. Helping a senior peer improve can be politically difficult. Did you involve your mutual manager in this performance coaching?
Answer: I kept the manager informed but did not ask them to intervene. I told the manager, I have noticed some planning gaps in the migration project, and I'm going to partner with Times to build out a more robust roadmap. This allowed the manager to be aware of the risk without it becoming a formal performance issue, which gave the engineer a safe space to improve without fear of a PIP.
Follow-up 4, Curveball. What if, after your coaching, the engineer still refused to use the templates and the project failed? Who owns that failure?
Answer: I own the failure. If I recognize a risk and my attempt to mitigate it via coaching fails, it is my responsibility to escalate the risk to the engineering manager immediately. Letting a project fail out of a desire to be nice is a leadership failure. I would have formally documented the refusal to follow the agreed-upon plan and requested a formal change of project ownership to protect the business goal.
Leadership Pro Tip. Performance is a system design problem.
Junior managers think poor performance is a character flaw. Senior architects think poor performance is a system mismatch. When someone struggles, ask, does this person have the right API to the rest of the team? Usually, by changing the process, the documentation, or the communication contract, you can fix the performance bug without needing to replace the engineer. Question 92. Tell me about giving tough feedback to a peer or direct report. Note: interviewers use this question to probe your emotional intelligence and courage in delivering high-stakes, uncomfortable truths to ensure project success. This is a core signal for empathy and trust, evaluated heavily at companies like Apple and Meta.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to find candidates who are toxic, passive, or socially clumsy. Avoid these traps. 1. The sandwich trap, hiding the core negative feedback between two fake compliments. This shows a lack of candor and can be seen as insincere in high-performance cultures. 2. The blunt instrument, delivering feedback that is purely critical without offering a solution or path forward. This is being a jerk, not a leader. 3. The public call-out, giving tough feedback in a group meeting or public Slack channel. This destroys psychological safety instantly. 4. The third-party feedback, saying I heard other people were unhappy with you. This lacks courage. You should speak only from your own observation. 5. The delayed feedback, waiting weeks or months for a formal review to deliver feedback about a specific incident. Real-time feedback is the senior standard.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 EQ signals. 1. Radical candor. Did the candidate deliver the truth directly and clearly without sugarcoating? 2. Empathy. Did they consider the impact of the feedback on the other person and choose the right setting? 3. Objectivity. Was the feedback based on work output and business impact rather than personality? 4. Actionability. Did they provide a concrete correction path? 5. Resolution. Did the feedback actually lead to a positive change in the system or the relationship? Strong candidates prove they value the team's success more than their own comfort.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer around an architectural gatekeeping conflict. Situation: I was the tech lead for a new API platform. A highly experienced peer from a different team was gatekeeping our shared infrastructure repo. He was rejecting PRs with vague comments like "this does not fit our style," but he would not define what that style was, which was blocking 3 different teams. Task: I needed to deliver tough feedback to a senior peer to stop the project from stalling, without creating a toxic rivalry between our teams. Action: I requested a private one-on-one. I used the Situation Behavior Impact (SBI) model. I said, when you reject PRs without specific architectural rationale, the impact is that 3 teams are blocked and our velocity has dropped by 30%. It feels like the goal is gatekeeping, not quality. I proposed a solution. We stop the ad hoc PR comments and spend 2 days co-authoring a formal contribution guideline document together. Result: he was initially shocked but admitted he was trying to protect the system without a clear framework. We co-authored the guidelines, the PR bottleneck vanished, and we eventually became close collaborators on the Architecture Guild. Learning plus L. I learned that gatekeeping is usually a symptom of missing standards. I now proactively establish style and architecture guides before opening a repo to external contributors to prevent human friction. The plus L shows you turned a personal confrontation into a new documentation standard.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite radical candor. 1. Radical candor matched. You used the word gatekeeping directly. It's an uncomfortable word, but it was the technical truth of the situation. 2. Empathy matched. You took the conversation to a private one-on-one and offered to help him write the guidelines rather than just complaining. 3. Objectivity matched. You focused on the 30% velocity drop and blocked teams, not his personality. 4. Actionability matched. You provided a clear solution, the contribution guideline document. 5. Resolution matched. The relationship improved from rivals to collaborators, and the technical bottleneck was solved. This demonstrates that you prioritize the engineering mission over avoiding awkward conversations.
Follow-up 1. Clarification probe. How did you feel right before that meeting? Delivering that specific feedback must have been very stressful.
Answer: it was. My natural instinct is to avoid conflict. However, as a senior architect, my primary loyalty is to the platform's success and the developer experience of the team. I reminded myself that by not giving this feedback, I was failing the other 3 teams who were blocked. The stress of letting the project fail was greater than the stress of the one-on-one.
Follow-up 2. Level 3 or Level 4 junior depth. What if the peer had argued that his gatekeeping was necessary to prevent junior engineers from breaking the production environment?
Answer: I would have validated that concern completely. I would have said, I agree we must protect production. Let's build those protections into our CI/CD pipelines as automated tests, rather than relying on you manually blocking every PR. The goal is to move the safety check from a human gate to a machine gate so the system remains safe but does not lose speed.
Follow-up 3. Level 5 or Level 6 senior depth. Some people react very poorly to being called a gatekeeper. How did you handle his immediate emotional reaction?
Answer: I did not argue with his reaction. I stayed silent for a few seconds to let the impact land, then I immediately pivoted to the solution. I said, I'm only using that word because that is how it is being perceived by the other teams. I know your goal is quality. Let's find a way to scale that quality without you needing to be in every PR. By separating his intent quality from his behavior gatekeeping, I allowed him to save face while still agreeing to the change.
Follow-up 4. Curveball. Looking back, do you think you should have involved your manager earlier in this dispute to avoid the risk of a peer-to-peer blowout?
Answer: no. At the senior level, if you cannot have a direct, honest conversation with a peer about a technical blocker, you lack the influence without authority required for the role. Involving a manager early signals that you are escalation dependent. I only escalate when peer-to-peer honesty has been exhausted and the business remains at risk. In this case, honesty was the fastest path to a fix.
Leadership pro tip. Feedback is a safety protocol.
Junior engineers view tough feedback as a relationship risk. Senior architects view withholding feedback as a systemic risk. If you see a behavior or a process that is hurting the team, it is your professional duty to point it out. Delivering it with empathy and a solution makes you a leader. Ignoring it makes you a bystander.
Category 11 wrap-up. Scaling your impact.
You have mastered the learning and growth category. You have demonstrated that a senior architect is a perpetual student who can bridge technical gaps in days, and a mentor who views team growth as a core architectural requirement. You have proven that feedback is your primary tool for system correction. But growing the team is only possible if the organization operates on a foundation of trust.
Transition, the guardian of integrity.
A brilliant engineer who lacks ethics is a liability to the enterprise. As you ascend to leadership roles, you will face moments where business pressure directly conflicts with data privacy, security standards, and legal compliance. Your value as an architect is defined by your courage to protect the user and the company's integrity above all else. This brings us to Category 12, ethical judgment and integrity.
Category 12, ethical judgment and integrity.
In high-stakes loops at companies like Apple and Amazon, integrity is a non-negotiable filter. Interviewers want to see if you have a moral North Star that guides your technical decisions. They are looking for candidates who can navigate the gray areas of corporate pressure, speak truth to power, and prioritize long-term compliance and safety over short-term revenue goals.
Ethical judgment and integrity scenarios.
These 5 scenarios evaluate your character and your commitment to professional and organizational standards. 93. Tell me about a time you had to make an ethical decision. 94. Tell me about a time you disagreed with company policy. 95. Describe a time you stood up for what you believed was right. 96. Tell me about a time you handled sensitive or confidential information. 97. Tell me about a time when you had to push back on leadership for ethical reasons. Senior architects are the final line of defense for the company's reputation. Question 93. Tell me about a time you had to make an ethical decision. Note, interviewers use this question to evaluate your professional integrity and your ability to uphold data privacy or security standards even when they conflict with a major business deadline. This is a critical signal for earning trust and customer obsession, evaluated at companies like Apple and Amazon.
Here are the critical red flags, the instant rejection signals.
Interviewers watch for candidates who are morally flexible under pressure. Avoid these traps. 1. The self-serving ethics, describing a decision where you only did the right thing because you were afraid of getting caught. 2. The passive observer, noticing an ethical breach like data misuse, but failing to intervene because it was not your project. 3. The whistleblower without data, escalating an ethical concern based on a hunch or personal dislike rather than objective evidence. 4. The compromised architect, admitting you agreed to a short-term ethical violation to hit a deadline, even if it was corrected later. 5. Lack of professionalism, describing the scenario in a way that sounds like you are gossiping about a former employer's lack of ethics.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 integrity signals. 1. Moral courage, did the candidate take an uncomfortable stand for a professional standard? 2. Risk assessment, did they recognize the potential legal or reputational damage of the unethical path? 3. Objectivity, did they rely on company policy and legal frameworks rather than personal feelings? 4. Interpersonal tact, did they handle the conflict professionally without burning bridges? 5. Structural fix, did they implement a new safeguard to prevent the same ethical dilemma from recurring? Strong candidates prove that integrity is a technical requirement, not a personal preference.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer around a data privacy conflict where you protected the user. Situation: I was the tech lead for a new internal analytics dashboard. To speed up the launch, the marketing team requested that we skip the user de-identification step, arguing that since the data was only for internal use, the privacy risk was negligible. Task: I needed to hit the launch date, but I realized that providing raw, identifiable user data to 100 internal employees was a massive violation of our privacy policy and a GDPR audit risk. Action: I did not just block the request. I wrote a 1-page privacy risk assessment. I quantified the potential fines and showed how a single compromised internal credential would lead to a total user data breach. I proposed a privacy-by-design compromise. We implemented a K-anonymity hashing layer that provided the marketing team with the trends they needed without exposing any PII, personally identifiable information. Result: the dashboard launched 2 days late, but we ensured 100% compliance with our privacy standards. The CMO eventually thanked me for identifying the risk before it reached an auditor. Learning plus L. I learned that internal use is often used as a shortcut for poor security. I later authored a mandatory privacy shield standard for our CI/CD pipelines, requiring automated PII detection for any new analytics export. The plus L, learning, shows you turned an ethical conflict into an automated privacy guardrail.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite professional integrity. 1. Moral courage matched. You stood up to a request from a powerful department, marketing, To protect user privacy. 2. Risk assessment matched. You used a privacy risk assessment to translate an abstract ethical concern into a concrete financial risk. 3. Objectivity matched. You cited company policy and GDPR risk rather than just saying you felt it was wrong. 4. Interpersonal tact matched. You offered a technical middle ground, hashing, that allowed the business to get its data safely. 5. Structural fix matched. The +L step, automated PII detection, removed the human element from future privacy decisions. This demonstrates that you are a guardian of the company's legal and ethical survival.
Follow-up 1. Clarification probe. What if the marketing lead had argued that your anonymization layer was too expensive and was hurting their department's budget?
Answer: I would frame the budget in terms of expected loss. I would show that the $5,000 cost of the hashing layer was an insurance policy against a $5 million regulatory fine. When you compare a minor engineering cost to an existential legal risk, the business priority almost always shifts to safety. As an architect, my job is to make those hidden costs visible.
Follow-up 2. Level 3 or Level 4 junior depth. Technically, why was raw data more dangerous than your K-anonymity version for an internal dashboard?
Answer: raw data allowed any employee to track a specific individual's behavior. K-anonymity ensures that any single record in the dashboard could belong to at least K individuals, effectively hiding the individual in a crowd. It allows the marketing team to see users aged 25 to 30 like this feature, without ever knowing which specific user it was.
Follow-up 3. Level 5 or Level 6 senior depth. Standing your ground caused a 2-day delay in a high-profile project. How did you manage the frustration of the project manager who was being graded on that deadline?
Answer: I took full responsibility for the delay in the stand-up. I did not blame marketing for the request. I stated that I had underestimated the privacy requirements during the initial scoping. By owning the timeline shift myself, I neutralized the friction between teams and ensured that the correction was seen as a technical necessity rather than a personal dispute.
Follow-up 4. Curveball. If the CMO had told you to just ship it and promised to take the blame if an audit happened, would you have followed their direction?
Answer: no. Accountability cannot be traded in a technical system. While they might take the blame in a meeting, I am the one with the root access who authorized the data flow. My professional ethics and our company's security policy are not negotiable based on a verbal promise. I would have formally escalated the risk to the Chief Privacy Officer to ensure a documented executive decision was made before proceeding.
Leadership pro tip. Ethics are a system invariant.
Junior engineers view ethics as a choice. Senior architects view ethics as a system invariant, a condition that must remain true for the system to be valid. In an interview, show that your technical standards, security, privacy, integrity, are non-negotiable constraints of your design process, regardless of the deadline pressure. Question 94. Tell me about a time you disagreed with company policy. Note: interviewers use this question to evaluate your critical thinking and your ability to challenge status quo bureaucracy with a better solution. At companies like Netflix and Amazon, they value informed captains who improve the rules, rather than blind followers who execute bad policies.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to find candidates who are either defiant or mindless. Avoid these traps. 1. The rule breaker, admitting that you simply ignored the policy and did what you wanted. This is a massive failure in professional conduct. 2. The generic complainer, disagreeing with a policy like return to office or vacation time that has no impact on engineering quality or customer success. 3. The passive compliance, admitting you knew the policy was bad for the system but followed it anyway without ever trying to change it. 4. The hostile challenger, describing the policymakers as stupid or out of touch. This signals a lack of collaborative empathy. 5. The unsuccessful attempt, telling a story where you disagreed but failed to propose a viable, data-backed alternative.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 strategic signals. 1. Critical evaluation. Did the candidate identify a policy that was actually harming technical velocity or system safety? 2. Strategic alignment. Did they frame their disagreement in terms of the company's goals, for example, security, speed, cost? 3. Alternative design. Did they offer a concrete V2 of the policy that solved the original problem better? 4. Influence. Did they work through the correct channels to gain consensus for the change? 5. Professional maturity. If the change was rejected, did they disagree and commit to the existing policy? Strong candidates prove they improve the organization by improving its rules.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer around a security policy that was actually creating a security risk. Situation. Our company had a legacy policy requiring all engineers to rotate their internal service passwords every 30 days manually. The goal was to prevent credential leakage. Task. I realized this policy was having the opposite effect. Because it was manual and frequent, engineers were writing passwords in Slack sticky notes and unencrypted local files, which was a massive security vulnerability. Action. I did not just ignore the policy. I researched the NIST guidelines for password rotation and presented a proposal to the Security Guild. I argued that frequent manual rotation was a high-risk anti-pattern. I proposed an alternative. We migrate to federated identity, SSO with MFA for humans and short-lived SDS tokens for services, effectively eliminating passwords entirely. Result, the Security Guild approved the pivot. We removed the manual rotation requirement for 400 engineers, saving thousands of hours of toil annually, and our credential theft risk profile dropped to near zero. Learning plus L. I learned that policies follow technology. I now host a quarterly policy review for the Architecture Guild to identify rules that have been rendered obsolete by new cloud-native capabilities. The plus L, learning, proves you ensure company rules evolve at the same speed as the technology.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite organizational leadership. 1. Critical evaluation matched. You identify that the password policy was creating more risk than it solved. 2. Strategic alignment matched. You used NIST industry standards to ground your argument in professional authority. 3. Alternative design matched. You did not just complain. You architected an SSO and SDS token-based replacement. 4. Influence matched. You successfully lobbied the Security Guild to update the corporate policy. 5. Professional maturity matched. You handled the disagreement through the formal RFC process rather than just breaking the rules. This demonstrates that you are a staff-level architect who scales the organization's logic.
Follow-up 1, clarification probe. What was the hardest part about convincing the old-school security traditionalists to drop the manual rotation rule?
Answer: the fear of control loss. To them, seeing a password change every 30 days felt like security. I had to pivot the conversation from control to observability. I showed them that with SDS tokens, we could audit exactly when a token was used and revoke it in milliseconds, something they could not do with manual passwords. Once they saw the audit logs, they felt more in control than before.
Follow-up 2, Level 3 or Level 4 junior depth. Technically, why are short-lived tokens safer than a password that is changed every 30 days?
Answer: a password is a long-lived secret. If it is stolen on day 1, an attacker has 29 days of access. A short-lived token, like an AWS IAM role token, typically expires in 1 hour. Even if it is stolen, the blast window for the attacker is extremely small. Automation makes security a time game that the attacker cannot win.
Follow-up 3, Level 5 or Level 6 senior depth. Changing a core security policy affects the entire company. How did you handle the rollout for legacy teams who did not want to change their code to support SSO?
Answer: I used a bridge strategy. We implemented an identity proxy that allowed legacy services to continue using their old credentials temporarily, while the proxy handled the token exchange with our new SSO provider. This allowed the policy change to happen immediately for the whole org, while giving the legacy teams a 6-month window to refactor their code properly.
Follow-up 4, Curveball. What if the Security Guild had said no and insisted on keeping the manual 30-day rotation? What would you have done?
Answer: I would disagree and commit. I would continue to follow the manual rotation policy perfectly. However, I would also work to automate the policy. I would write a script to handle the rotations for my team so we followed the letter of the law without the human risk. A senior leader follows the rules, but a senior architect finds a way to make bad rules less dangerous through engineering.
Leadership pro tip: policies are architectural debt.
Just like code, policies can become stale and dangerous. When you face a policy you disagree with, treat it like technical debt. Do not fight it with emotion. Fight it with a better V2 architecture. If you can show that your alternative is more secure and more efficient, you aren't being difficult, you are being a strategic asset. Question 95. Describe a time you stood up for what you believed was right. Note, interviewers use this question to evaluate your professional courage and your commitment to high standards in the face of social or hierarchical pressure. Companies like Amazon and Netflix look for engineers who will have backbone and refuse to ship compromised systems, even when faced with aggressive business deadlines.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to filter out toxic martyrs or weak pushovers. Avoid these traps. 1. The selfish stand, standing up for something that only benefited you, for example, arguing for a higher salary or a better desk. 2. The emotional outburst, describing the stand as an argument or a fight where you lost your temper. This shows a lack of EQ. 3. The vague principle, standing up for something generic like quality without being able to define the specific technical risk you were preventing. 4. The zero compromise, refusing to listen to any other perspective or data, showing dogmatism rather than conviction. 5. The late stand, only standing up for what was right after the system already failed and the blame was being assigned.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 backbone signals. 1. Technical conviction: was the candidate stand rooted in a verified technical or ethical risk? 2. Calculated risk: did they understand the personal or project-level consequences of their pushback? 3. Diplomatic courage: did they deliver their dissent respectfully to senior leadership? 4. Data-driven defense: did they use metrics or benchmarks to justify their position? 5. Outcome alignment: did their stand eventually lead to a better result for the customer or the company? Strong candidates prove that silence in the face of a critical risk is a form of negligence.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer around a security or reliability risk you refuse to ignore. Situation: 3 days before our high-profile Q4 marketing launch, a penetration test found a logic flaw in our new referral service that could allow a user to generate unlimited $20 credits. The product VP wanted to ignore it and launch anyway, calling it a low-probability edge case. Task: as the security architect for the project, I knew this was a viral risk. If the exploit leaked on social media, it could bankrupt the marketing budget in hours. I had to stand my ground against the project's launch. Action: I did not just block the deployment. I wrote a blast radius simulation script. I proved that a single script could drain $50,000 in credits per hour. I presented this data directly to the VP and offered a safe launch alternative. We disabled the referral service for the first 24 hours while my team implemented a credit cap rate limiter as a hotfix. Result: the VP was shocked by the math and agreed to the 24-hour delay. We shipped the cap on day 2. The campaign was a success, and we actually caught 3 real-world attempts to exploit that specific flaw during the first week. Learning plus L. I learned that business leaders do not ignore risk, they just do not always understand the velocity of technical risk. I subsequently implemented a financial guardrail standard, requiring all promotional services to have hard budget caps at the database level by default. The plus L, learning, shows you turned a personal stand into a new organizational safety standard.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite architectural backbone. 1. Technical conviction matched. You identified that a logic flaw was a high-speed financial risk, not just a minor bug. 2. Diplomatic courage matched. You pushed back on a product VP who was under intense pressure to hit a Q4 launch date. 3. Data-driven defense matched. You used a blast radius simulation to make the risk visible in dollar terms. 4. Outcome alignment matched. You offered the safe launch compromise to satisfy both the business date and the security requirement. 5. Systemic improvement matched. The financial guardrail standard ensured future marketing events were safe by design. This shows you are an architect who protects the company's money and reputation at the highest levels.
Follow-up 1, clarification probe. How did the product VP react when you showed them the $50,000 per hour simulation data?
Answer: the tone of the room changed instantly. Up until that point, they viewed my concern as an engineering perfectionism issue. Once the risk was quantified in revenue loss, it became a profit protection issue. A senior architect's job is to translate technical red flags into the language of business impact.
Follow-up 2, Level 3 or Level 4 junior depth. Technically, why was the credit cap rate limiter the right choice for a hotfix instead of just fixing the logic flaw itself?
Answer: fixing the logic flaw required changing our core database schema and resyncing our ledger, a 5-day risky project. The credit cap was a defensive layer at the application gateway. It was a circuit breaker. Even if the bug was triggered, the gateway would stop the bleeding at $100 per user. It was the fastest way to achieve safety without needing a perfect fix immediately.
Follow-up 3, Level 5 or Level 6 senior depth. Standing up for what is right often makes people the enemy of the product team. How did you repair that relationship with the product VP after you delayed their launch?
Answer: I stayed on the bridge with them for the next 24 hours. I did not just point out the problem and leave. I became the primary driver of the solution. By demonstrating that I was equally committed to the launch as they were, I earned their respect. I turned the situation into a COO success rather than a security victory. Influence is built by helping people ship safely, not just blocking them.
Follow-up 4, curveball. What if you had been wrong and the $50,000 risk was actually impossible? Would you have regretted delaying the launch?
Answer: no. In security, we operate on the assume breach mindset. I would rather be wrong about a risk and delay a launch than be wrong about a safety and bankrupt the company. I would have conducted a false positive postmortem to improve my risk simulation models, but I would never regret the decision to prioritize the company's integrity over a date. Credibility is built by consistency.
Leadership pro tip, translate the threat.
Business leaders aren't technical, they are risk-averse. If you stand up for something technical like cleaner code, you will lose. If you stand up for a business impact like revenue loss or legal liability, you will win. When you believe something is right, find the business translation of that technical truth and use it to lead. Question 96. Tell me about a time you handled sensitive or confidential information. Note: interviewers use this question to evaluate your professional discretion, your understanding of data sovereignty, and your ability to act as a guardian of the company's most sensitive assets. This is a critical signal for earning trust and security mindset evaluated at companies like Apple and Google.
Here are the critical red flags, the instant rejection signals.
Interviewers watch for candidates who are careless or performative with sensitive data. Avoid these traps. 1. The gossip trap, sharing the actual confidential details during the interview. This proves you cannot be trusted with secrets. 2. The unconscious handler, describing a time you handled sensitive data but did not realize it was sensitive until someone else pointed it out. 3. The hero hack, admitting you bypassed security controls or used your admin power to access data you did not have a specific business need for. 4. The slack disclosure, mentioning that you discussed sensitive or confidential personnel or financial issues in a non-encrypted or publicish channel. 5. Lack of protocol, failing to describe the specific technical or legal framework, for example, GDPR, SOC 2, HIPAA, that guided your handling of the data.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 discretion signals. 1. Discretion: did the candidate restrict access to the minimum necessary individuals? 2. Technical guardrails: did they use encryption, vaulting, or access control lists to protect the data? 3. Integrity: did they follow company policy even when it was inconvenient for the project timeline? 4. Risk mitigation: did they proactively identify potential leaks in the data lifecycle? 5. Policy improvement: did they strengthen the organization's confidentiality standards afterward? Strong candidates prove that confidentiality is an architectural constraint, not just an HR rule.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer around discovering and securing an institutional leak. Situation: while performing a routine architectural audit of our telemetry pipeline, I discovered that our application's debug logs were accidentally capturing raw payment authorization tokens in plain text. These logs were accessible to over 200 engineers. Task: I needed to immediately secure this high-stakes data leak and scrub the historical records without disrupting the ongoing production support operations. Action: I did not announce the leak in a public channel. I contacted the security lead and my manager via a private, encrypted thread. I immediately implemented a log scrubbing regex filter at our ingestion gateway to redact tokens in real time. I then authored a secure script to rotate the credentials for every affected user and led a silent purge of the 30-day log history in our ELK cluster. Result: we closed the leak in under 4 hours. No tokens were exploited, and we maintained our PCI DSS compliance. We communicated the incident only to those with a need to know to prevent further exposure. Learning plus L. I realized that logging libraries are a massive security blind spot. I subsequently built an automated PII scanner into our CI/CD pipeline that blocks any code attempting to log fields marked as sensitive in our data schema. The +L shows you converted a discrete leak into a permanent, automated security gate.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite professional discretion. 1. Discretion matched. You kept the discovery to a private, encrypted thread with only the security lead and manager. 2. Technical guardrails matched. You implemented a regex filter at the gateway and a silent purge of the historical logs. 3. Integrity matched. You prioritized the safety of user tokens over the convenience of engineering debug logs. 4. Risk mitigation matched. You forced a credential rotation for every affected user to ensure zero residual risk. 5. Policy improvement matched. The PII scanner in the CI/CD pipeline removed the human factor from future log leaks. This demonstrates that you are a guardian who acts with speed, silence, and systemic rigor.
Follow-up 1. Clarification probe. Why did not you alert the 200 engineers who had access to the logs so they could help you find the source of the leak?
Answer: that would have increased the insider risk. By announcing the existence of raw tokens in a public channel, I would have essentially pointed a map to the gold for anyone with malicious intent. I kept the investigation small and high bandwidth, specifically to contain the knowledge of the vulnerability while we were in the process of closing it.
Follow-up 2. Level 3 or Level 4 junior depth. Technically, how did you verify that your log scrubbing regex did not accidentally redact legitimate data and break the support team's dashboards?
Answer: I used a dry run mode. I deployed the regex to a parallel, non-blocking stream in our staging environment. I compared the before and after payloads. I verified that only strings matching the 16-digit payment token pattern were replaced with redacted, while the surrounding transaction metadata remained intact. This gave me the confidence to move to production without causing a secondary incident.
Follow-up 3. Level 5 or Level 6 senior depth. The silent purge of logs might have deleted evidence that engineers needed to debug other unrelated issues. How did you manage that trade-off?
Answer: I prioritize compliance over convenience. Deleting 30 days of logs is a painful engineering trade-off, but leaving raw payment tokens in a shared store is a company-ending risk. I communicated the purge to the engineering leads 15 minutes before execution, framed it as a mandatory security remediation, and offered to help them reconstruct non-sensitive state from our secondary metrics if their debugging was interrupted.
Follow-up 4. Curveball. What if you found out that a senior executive had been the one who requested the logging of those tokens, just for a few days, to troubleshoot a VIP customer issue?
Answer: the source of the request does not change the risk. I would still secure the data immediately. However, I would handle the follow-up differently. I would schedule a private briefing with that executive to show them the blast radius of that decision. I would frame it as protecting them and the company. Usually, when a leader sees that their request created a multi-million-dollar liability, they become the biggest advocate for the new automated guardrails.
Leadership pro tip. Secrets are liabilities.
Junior engineers view access to sensitive data as a privilege. Senior architects view it as a liability. When answering this question, show the interviewer that your goal is always to reduce the company's exposure. The best way to handle sensitive information is to build systems where that information is never stored, never seen, and never handled by humans in the first place. Question 97. Tell me about a time when you had to push back on leadership for ethical reasons. Note: interviewers use this question to evaluate your professional backbone and your ability to deliver uncomfortable truths to power. At companies like Amazon and Netflix, they are looking for architects who prioritize long-term customer trust and legal compliance over short-term business goals or executive whims.
Here are the critical red flags, the instant rejection signals.
Interviewers watch for candidates who are either insubordinate or morally compliant. Avoid these traps. 1. The self-righteous tone, describing the leader as corrupt or unethical in a personal way. This signals a lack of professional maturity. 2. The passive surrender, admitting you pushed back once but then just followed orders when the leader insisted, allowing the ethical breach to happen. 3. The emotional argument, basing your pushback on your feelings or opinions rather than hard data, company policy, or legal frameworks. 4. The public confrontation, describing a time you challenged a leader in a large meeting, which shows a lack of tactical EQ and diplomatic skill. 5. Zero alternative, pushing back and saying no without offering a safe path to still achieve the business goal legally and ethically.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 backbone signals. 1. Technical integrity. Was the pushback rooted in a clear violation of safety, privacy, or security standards? 2. Data-driven dissent. Did the candidate use a risk model or financial impact data to justify their position? 3. Diplomatic courage. Did they deliver the dissent privately and respectfully to the person with the power? 4. Solution orientation. Did they offer an alternative V2 path that satisfied both ethics and business goals? 5. Resilience. Did they maintain their professional relationship with the leader after the conflict? Strong candidates prove they are informed captains who protect the organization's future.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer around a security versus speed conflict at the executive level. Situation: our VP of sales was pushing for a 48-hour launch of a new external data sharing portal to close a major end-of-quarter deal. The portal had not yet passed its final mandatory security audit for data exfiltration protection. Task: I was the lead architect. If I blocked the launch, the company would miss its revenue target. If I allowed it, we were potentially exposing millions of user records to the public internet. Action: I requested a 10-minute private sync with the VP. I did not say no. I presented a threat model showing that the current portal had a critical flaw. A simple enumeration attack could dump the entire database. I proposed a safe harbor alternative. We launched the portal on time, but with a manual approval gate for all data exports for the first 7 days, while my team automated the security controls in the background. Result: the VP accepted the compromise. We closed the deal, and my team implemented the automated controls within 5 days. We successfully blocked 2 legitimate enumeration attempts during that first week that would have otherwise resulted in a total breach. Learning plus L. I learned that leaders do not ignore ethics, they ignore abstract risk. I subsequently built a real-time risk dashboard for the executive team, translating security gaps into probability of breach and projected legal cost so they could see the ethical stakes in business terms. The plus L, learning, shows you turned a one-time pushback into a new executive governance system.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite leadership backbone. 1. Technical integrity matched. You refused to ship a portal with a known data exfiltration flaw, even for a major deal. 2. Data-driven dissent matched. You used a threat model and an enumeration attack simulation to prove the risk was real. 3. Diplomatic courage matched. You took the conversation to a private sync with the VP rather than arguing in the project channel. 4. Solution orientation matched. You offered the manual approval gate as a temporary safe path to hit the revenue target. 5. Systemic improvement matched. The real-time risk dashboard ensured leadership would never be blind to technical debt again. This demonstrates that you are a partner who helps leadership succeed safely, not a roadblock.
Follow-up 1. Clarification probe. What if the VP had ignored your threat model and told you, I will take the risk, just ship it now? What would you have done?
Answer, I would have disagreed and escalated. I would have said, I understand the revenue goal, but as the architect, I cannot authorize a design that knowingly violates our GDPR data sovereignty contract. I must formally raise this to the CTO and our Chief Compliance Officer for a final ruling. My loyalty is to the company's long-term survival and the user's privacy, which always overrides a single person's end-of-quarter target.
Follow-up 2, Level 3 or Level 4 Junior Depth. How did you manage the extra workload of the manual approval gate for that first week?
Answer, I did not dump the work on the junior engineers. I volunteered to be the primary approver myself for the first 72 hours. This ensured that I felt the pain of the trade-off I had proposed. It also allowed me to see the real-world traffic patterns firsthand, which helped us tune the automation rules faster.
Follow-up 3, Level 5 or Level 6 Senior Depth. Did the relationship with the VP of Sales suffer after you challenged them?
Answer, actually, it improved. By offering the manual gate solution, I showed that I was not just a security cop, I was a business enabler. I helped them win the deal while keeping them out of the news for a data breach. They now bring me in during the prospecting phase of large deals to ensure the architecture is compliant before the contract is even signed. Influence is built through successful, safe delivery.
Follow-up 4, Curveball. Looking back, if you had not been able to find that manual gate compromise, and the only two choices were launch and breach or delay and fail, which would you have chosen?
Answer, I would have chosen delay and fail. Losing a contract is a localized business failure. A catastrophic data breach that compromises millions of users is a systemic, brand-destroying failure that can lead to bankruptcy. An architect must have the clarity to know that no single deal is worth the integrity of the entire platform. I would have accepted the personal career risk of being the one who blocked the deal to protect the company.
Leadership pro tip, do not be a roadblock, be a guardrail.
Junior engineers push back by saying no. Senior architects push back by saying not like that. If you have to disagree for ethical reasons, always bring an alternative path that achieves the business result with a different risk profile. If you can help leadership win safely, you become an indispensable advisor rather than a perceived obstacle.
Category 12 Wrap-Up, Integrity as an Invariant.
You have mastered the ethical judgment and integrity category. You have proven that a senior architect is the moral compass of the engineering organization. You have demonstrated the courage to prioritize data privacy and business compliance over short-term revenue spikes, proving that you are a guardian of the company's long-term reputation. But technical mastery and integrity are only sustainable if you possess deep self-awareness.
Transition, the interior life of an architect.
An architect who does not understand their own biases, motivations, and weaknesses is a risk to the team. Senior leadership requires the ability to look inward as rigorously as you look at your system architecture. This brings us to our final category, self-reflection and motivation, where we explore the psychological maturity required to sustain a career at the highest levels of tech.
Check the comments section or description of this video. I have given a link to download a magical bundle that teaches you to develop Google caliber thinking and provides a complete mental model in a way that screams Google SRE. This bundle is the only end-to-end system that teaches you to think, act, and communicate like a Google SRE before you even set foot in the interview. It is the only structured playbook for Google's impossible rounds like NALS and troubleshooting. Most candidates sound like outsiders. The magic of this bundle is makes you sound like you already work at Google. Cracking the Google SRE interview is one of the toughest challenges in tech. Most resources only prepare you for parts of the process, a few coding problems here, some system design notes there. But Google's SRE loop is multidimensional. It tests how you think, act, and communicate. Imagine preparing with scattered LeetCode problems, random design blog posts, and still wondering how to survive the NALS round. That's how most candidates prep, fragmented, incomplete, and unstructured.
Now, imagine having one complete system.
Imagine instead you had one system that gave you everything.
A system that gives you
1. End-to-end coverage of every single round. 2. playbooks that turn chaos like NALS and troubleshooting into structure. 3. Realistic practice drills that simulate the actual interview loop. 4. Insider language and frameworks that make you sound like you already belong. That's what this bundle does. It's not just prep material, it's a game changer because it transforms the way you think, act, and communicate into the exact style Google interviewers are looking for.
The Google STAR+L interview bundle covers
1. Recruiter screen and resume prep, tailored templates and scripts that pass the first filter. 2. Coding rounds, Python and Go question and answers designed for SRE-style reliability tasks. 3. System design and NALS, playbooks for both high-level design and Google's infamous NALS round. 4. Troubleshooting and debugging, a step-by-step handbook to master war-room-style scenarios. 5. Behavioral and Googleness, real reliability scenarios that make you sound like you already work at Google. 6. Post-interview and hiring committee, an insider breakdown of how decisions are made. 7. Salary negotiation, recruiter-proof scripts and strategies to maximize your offer confidently. If leak code is practice mode, this bundle is the real game simulation. It doesn't just prepare you for questions. It prepares you to think, act, and communicate like a Google SRE before you even set foot in the interview.
Category 13, Self-Reflection and Motivation.
Interviewers at companies like Meta and Amazon use this final category to determine your long-term fit. They are looking for candidates who are self-driven, intellectually honest, and capable of constant self-correction. They want to see that you aren't just looking for a job, but that you are seeking specific architectural challenges that align with your professional drive, and that you possess the humility to recognize your own growth areas.
Self-reflection and motivation scenarios.
These 7 final scenarios evaluate your psychological maturity and alignment with elite engineering cultures. 98. What motivates you at work? 99. What is your biggest weakness? 100. What type of work environment do you thrive in? 101. Why do you want to work at this company specifically? 102. What makes you different from other candidates? 103. Tell me about a career decision you are proud. 104. Who was the most difficult person you have worked with and how did you handle it? Self-awareness is the highest form of technical debt management. Question 98. What motivates you at work? Note, interviewers use this question to evaluate your professional alignment and whether your internal drive matches the company's specific mission and scale. At companies like Amazon and Google, they are looking for missionaries, not mercenaries, engineers who are fueled by solving complex systemic problems rather than just perks or titles.
Here are the critical red flags, the instant rejection signals.
Interviewers watch for candidates with shallow or unsustainable motivations. Avoid these traps. 1. The mercenary signal mentioning compensation, stock options, or title as your primary motivator. This suggests you will leave as soon as a better offer arrives. 2. The perk hunter, focusing on free food, office design, or work-life balance as the why behind your application. 3. The routine developer, saying you are motivated by shipping code or closing tickets. Senior architects are expected to be motivated by business outcomes, not output. 4. The static architect, failing to mention a desire for learning or tackling new, uncomfortably large technical challenges. 5. Vague platitudes, using generic phrases like "I love technology" without being able to name a specific type of problem that keeps you engaged.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 alignment signals. 1. Problem market fit. Does the candidate enjoy the specific type of complexity this company handles? For example, low latency, massive data, security. 2. Customer obsession. Is their motivation linked to the impact their work has on the end user? 3. Intellectual curiosity. Do they show a drive to master the mechanical underpinnings of their stack? 4. Resilience. Does their motivation sustain them through difficult, long-term project cycles? 5. Autonomy. Are they self-winding, or do they require constant external motivation from a manager? Strong candidates prove that their personal mission is a subset of the company's vision.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer around systemic impact and complexity mastery. Situation. Throughout my career, I have realized that I am most engaged when I am working at the intersection of high-scale engineering and direct business impact. Task: my goal as an architect is to find ways to make impossible scale feel like a standard operating procedure for my team. Action: I am motivated by entropy reduction. I love taking a fragmented, high-latency legacy environment and re-engineering it into a clean, event-driven architecture. For example, in my last role, I spent 6 months optimizing a data pipeline. My motivation was not the code. It was the moment our latency dropped from 4 hours to 4 minutes, enabling our fraud team to stop an active attack in real time. Result: that specific project saved the company $2 million. Seeing that technical elegance directly translates to business survival is what drives me to dive deep into the internals of the systems I build. Learning plus L. I learned that my primary motivator is leverage. I am most productive when I am building paved roads that allow hundreds of other engineers to move faster and safer. I seek out roles where the complexity is high and the margin for error is low. The plus L, learning, defines you as a force multiplier rather than a solo contributor.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite professional alignment. 1. Problem market fit matched. You explicitly mentioned impossible scale and entropy reduction, the bread and butter of FAANG architecture. 2. Customer obsession matched. You tied your work to the fraud team and business survival, showing you see the human and financial context. 3. Intellectual curiosity matched. You described diving into internals and re-engineering legacy environments. 4. Outcome focus matched. You quantified the impact as $2 million saved, showing your drive is results-oriented. 5. Knowledge multiplier matched. Your learning about leverage and paved roads proves you are motivated by team success. This demonstrates that you are a self-driven leader who is mission-aligned with high-growth tech.
Follow-up 1. Clarification probe. You mentioned entropy reduction. How do you maintain your motivation when you are stuck in a period of high-maintenance work where you cannot build new architectures?
Answer: I view maintenance as optimization discovery. When a system requires heavy maintenance, it is the system's way of telling us where the design is flawed. I stay motivated by using that period to gather the data required to justify the next architectural pivot. I am motivated by the solve, and sometimes the hardest part of the solve is the meticulous data gathering that happens during maintenance.
Follow-up 2. Level 3 or Level 4 junior depth. How do you stay motivated when you hit a technical blocker that you cannot solve for several days?
Answer: blockers are actually my favorite part of the job. They signal that I have reached the boundary of my current knowledge. I stay motivated by shifting from execution mode to research mode. I treat the blocker like a puzzle. I will dive into the source code of the library or the kernel logs to find the ground truth. The aha moment of overcoming a difficult blocker is a major source of my professional energy.
Follow-up 3. Level 5 or Level 6 senior depth. Motivation can be contagious. How do you instill your entropy reduction drive into a team that is currently feeling burned out and cynical?
Answer: I focus on short-term wins. Burnout often comes from a feeling of powerlessness. I identify one small, painful process, like a slow build or a flaky test, and I lead the effort to fix it immediately. When the team sees that we can actually improve their daily lives through engineering, the cynicism fades and is replaced by momentum. Motivation is not a speech. It is the feeling of winning small technical battles together.
Follow-up 4. Curveball. What if you found out that the entropy reduction project you were motivated by was actually a low priority for the business? Would your motivation drop?
Answer: no. My motivation is to deliver value, not just to build cool things. If my entropy reduction project is low priority, it means I have not successfully translated the technical debt into business risk. I would stay motivated by working with the product lead to find the alignment. If the alignment truly is not there, I would pivot my drive to whatever the P0 priority is, because my ultimate satisfaction comes from shipping what the customer needs.
Leadership pro tip. Seek the hard choice.
Junior engineers look for easy wins to stay motivated. Senior architects look for hard problems that have been ignored for years. In an interview, show that you are motivated by the challenges that others run away from. If you are the person who runs toward the spaghetti code or the legacy migration, You are the person who gets the staff-level offer. Question 99. What is your biggest weakness? Note, interviewers use this question to evaluate your self-awareness, intellectual honesty, and your commitment to continuous self-improvement. Companies like Google and Meta are not looking for a perfect candidate. They are looking for a learning candidate who knows their blind spots and builds systems to mitigate them.
Here are the critical red flags, the instant rejection signals.
Interviewers watch for candidates who are dishonest or lack depth in their self-reflection. Avoid these traps. 1. The fake weakness, giving a positive disguised as a negative. For example, I work too hard or I care too much about quality. This shows a lack of integrity. 2. The unfixable flaw, admitting to a core professional failure. For example, I struggle with deadlines or I am bad at testing, without showing a correction path. 3. The blame the environment, claiming your weakness is that you are too frustrated by other people's incompetence. This signals a toxic attitude. 4. The stagnant response, describing a weakness you had 5 years ago but failing to describe what you are currently struggling with and improving today. 5. The unconscious candidate, claiming you do not have any major weaknesses. This is a red flag for arrogance and a lack of coachability.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 growth signals. 1. Vulnerability. Did the candidate have the courage to name a real, uncomfortable professional gap? 2. Objectivity. Did they describe the weakness in terms of behavior and impact rather than personality? 3. Systemic mitigation. Did they implement a tool or process to prevent their weakness from hurting the team? 4. Improvement velocity. Are they actively making progress on closing the gap right now? 5. Self-correction. Do they have an early warning system to detect when their weakness is surfacing? Strong candidates prove that their weaknesses are well managed and under active remediation.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer around an architectural bias that you have learned to manage. Situation. As an architect, my natural bias is toward elegance and future-proofing. Earlier in my career, I had a tendency to over-engineer solutions, building complex abstractions for scale we would not hit for years. Task. I realized this was a weakness because it increased the time to value for our customers and added unnecessary cognitive load for my team. Action. I did not just try to be simpler. I implemented a pragmatism protocol. For every design, I now force myself to write a V1 minimal version alongside the ideal version. I created a simplicity rubric for our team, requiring us to justify the inclusion of any component that is not required for our current 12-month traffic projection. Result, by acknowledging this bias, I have reduced our project lead times by 30%. My team now ships faster, and we only pay the complexity tax when the data justifies it. Learning plus L. I learned that perfect is the enemy of shipped. I have institutionalized this by making operational simplicity a first-class requirement in our RFC templates, ensuring my own bias for elegance is checked by the team's need for maintainability. The plus L, learning, shows you built a guardrail against your own professional instincts.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite self-awareness. 1. Vulnerability matched. You admitted to over-engineering, a real and dangerous weakness for senior architects. 2. Objectivity matched. You tied the weakness to increased time to value and cognitive load, not personal feelings. 3. Systemic mitigation matched. You built the pragmatism protocol and the simplicity rubric to act as your external conscience. 4. Improvement velocity matched. You quantified the improvement, 30% reduced lead time on recent projects. 5. Self-correction matched. You added operational simplicity to the RFC template to ensure the team can check your work. This demonstrates that you are a managed risk, which makes you a safe hire for critical systems.
Follow-up 1, clarification probe. Can you give me an example of a time your simplicity rubric actually forced you to change your mind recently?
Answer: last month, I wanted to implement a complex service mesh to handle MTLS and observability. I ran it through the rubric and realized that for our current cluster size of only 15 nodes, the operational overhead was 2 times higher than the security benefit. I decided to defer the mesh and use simpler application layer middleware instead. It was painful to let go of the elegant solution, but it was the right call for the current scale.
Follow-up 2, Level 3 or Level 4 Junior Depth. How do you react when a junior engineer calls out your design for being too complex based on your own rubric?
Answer: I celebrate it. That is the highest signal that the rubric is working. I explicitly tell my team that they are the guardians of simplicity. If a junior cannot understand the flow of my architecture, it is a design failure on my part, not a learning failure on theirs. I immediately move back to the whiteboard and look for where to simplify the state transitions.
Follow-up 3, Level 5 or Level 6 Senior Depth. Some might say that your simplicity focus is just another way of saying you are afraid of complex engineering. How do you distinguish between pragmatic simplicity and lack of ambition?
Answer: ambition is measured by the business problem you solve, not the complexity of the code you write. I am highly ambitious about our system's reliability and throughput. My focus on simplicity is a strategic bet that a simpler system is easier to scale, easier to secure, and faster to repair. I do not fear complexity. I just refuse to pay for it unless I am buying a specific business advantage.
Follow-up 4, Curveball. If we hire you, and you find yourself in a situation where there is no rubric and no team to check your work, how will you prevent yourself from reverting to your over-engineering habits?
Answer: I rely on my personal checklist. Before I commit to an architecture, I always ask, what happens if I get paged for this at 3 a.m. and I'm half asleep? If the answer is I would be confused, I know I have over-engineered it. Self-management is about creating internal friction for your own bad habits. I am my own most skeptical reviewer.
Leadership Pro Tip. A weakness is a feature request.
Junior engineers try to hide their weaknesses. Senior architects treat their weaknesses like a bug report on their own performance. When you are asked this question, do not look for a way to look perfect. Look for a way to show that you have engineered a fix for your own flaws. A well-managed weakness is more valuable to a company than an unknown strength. Question 100. What type of work environment do you thrive in? Note: interviewers use this question to evaluate your cultural contribution and whether you will be an accelerant or an inhibitor in their specific engineering climate. At companies like Netflix and Meta, they are looking for candidates who crave high autonomy, radical candor, and context, not control.
Here are the critical red flags, the instant rejection signals.
Interviewers watch for candidates who require low-trust or high-process environments. Avoid these traps. 1. The instruction seeker, saying you thrive when you have clear, detailed instructions from my manager. This is a massive red flag for senior roles which require managing ambiguity. 2. The safe haven, saying you want a stable, predictable environment with no surprises. FAANG is highly volatile. This signals you will panic during pivots. 3. The silo developer, describing an environment where you are left alone to code. Senior architects must be motivated by collaboration and cross-functional friction. 4. The passive participant, failing to mention your role in creating the environment. A senior leader does not just join a culture, they build it. 5. Generic flattery, saying you want an environment exactly like this company, without being able to define the specific principles, like disagree and commit, that attract you.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 cultural signals. 1. Appetite for ambiguity. Does the candidate crave high-stakes, undefined problems? 2. Autonomy. Do they perform best when given a goal rather than a task? 3. Psychological safety. Do they value environments where they can admit mistakes and challenge authority? 4. High standards. Do they thrive in cultures where good enough is rejected? 5. Cultural contribution. Will they actively improve the team's engineering practices and mentorship? Strong candidates prove they are cultural additions, not just cultural fits.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer around context over control and technical truth. Situation. Throughout my career, I have realized that I am most productive in high-trust, low-bureaucracy environments that prioritize the best technical truth over hierarchy. Task. I thrive when I am accountable for a business outcome rather than a feature list. Action. I seek out environments that value radical candor. For example, in my previous role, I thrived because our architecture reviews were brutally honest. We focused on the risks, not the egos. I actively contributed to this by hosting Failure Friday sessions where we publicly dissected our own design errors to improve the collective knowledge. Result: in that environment, we were able to ship a complete re-architecture of our data mesh in 4 months, a project that would have taken a year in a more process-heavy organization. I was motivated by the speed of decision-making and the lack of political gatekeeping. Learning plus L. I learned that the best environment for an architect is one where authority is decentralized. I now carry this into every team I join by pushing to automate governance, so we spend our time on engineering, not on chasing approvals. The plus L, learning, shows you do not just thrive in a good culture, you actively export it to your team.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite cultural alignment. 1. Appetite for ambiguity matched. You mentioned thriving on business outcomes which are inherently ambiguous. 2. Autonomy matched. You explicitly asked for context over control and decentralized authority. 3. Psychological safety matched. You described participating in and building Failure Friday and brutally honest reviews. 4. High standards matched. You prioritized technical truth over hierarchy, showing you value quality above politics. 5. Cultural contribution matched. The plus L step proved you take an active role in automating governance to protect the culture. This demonstrates that you will act as a cultural force multiplier if hired.
Follow-up 1. Clarification probe. You mentioned radical candor. Have you ever been in a situation where that candor felt like a personal attack rather than a technical one? How did you handle it?
Answer: yes, I have seen candor used as a shield for poor behavior. When that happens, I return to the architecture principle. I will say, I value the feedback, but let's recenter this on the data. How does this specific comment help us hit our sub-100 milliseconds goal? By moving the focus back to the mission, I can filter out the noise of the personal attack and maintain the professional standard.
Follow-up 2. Level 3 or Level 4 junior depth. How do you stay productive in an environment where the best technical truth is still being debated and no decision has been made for weeks?
Answer: I do not wait for the debate to end. I propose a pilot for decision. I will offer to build 2 small, competing prototypes over a 48-hour window. Usually, once people see the actual latency or memory impact of 2 options, the technical truth becomes obvious and the debate ends. My role is to use engineering to break the tie of the debate.
Follow-up 3. Level 5 or Level 6 senior depth. Our environment is high trust, but we are also heavily regulated. How do you balance decentralized authority with the need for strict compliance and audits?
Answer: I move the governance from the human to the code. I advocate for policy as code. Instead of having a centralized review board that developers must wait for, we build the compliance rules into the CI/CD pipeline. If the code passes the automated audit, the developer has the authority to deploy. This maintains the high-trust autonomy while guaranteeing the high compliance outcome.
Follow-up 4. Curveball. What if you join our team and find that the culture is actually very hierarchical and low trust? Would you quit, or would you try to change it?
Answer: I would treat it as an architectural debt problem. Cultures, like codebases, accumulate debt. I would not try to change the whole company on day one. I would focus on microculture. I would build a high-trust, data-driven environment within my own feature track. Once adjacent teams see that my track is shipping faster and with fewer incidents, they will naturally look to adopt our trust-based practices. You change culture through results, not just complaints.
Leadership pro tip. Be the environment you crave.
Junior engineers look for an environment that fits them. Senior architects create the environment they need. In an interview, show that you aren't just looking for a culture, you are a culture carrier. If you mention that you actively mentor, document, and automate governance, the interviewer will know that no matter what the current environment is, you will make it better. Question 101. Why do you want to work at this company specifically? Note: interviewers use this question to evaluate your professional alignment and whether your missionary drive matches the company's specific architectural and business challenges. At companies like Amazon and Google, they are looking for candidates who have done deep research and want to solve the problems that only exist at their specific scale.
Here are the critical red flags, the instant rejection signals.
Interviewers watch for generic flattery or mercenary motivations. Avoid these traps. 1. The standard copy-paste, giving an answer that could apply to any tech company. For example, I want to work with smart people on cool tech. 2. The The perk hunter, focusing on the brand name, the stock price, the office, or the work-life balance rather than the engineering mission. 3. The fanboy trap, praising the products as a consumer without being able to discuss the architectural challenges behind them. 4. Lack of research, failing to mention a specific recent technical announcement, engineering blog post, or business shift relevant to the company. 5. The resume builder, admitting you just want the brand name on your resume to increase your future market value.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 alignment signals. 1. Technical curiosity. Has the candidate researched our specific engineering culture and stack? 2. Mission alignment. Do they care about the problem we are solving, for example, organizing the world's info, being Earth's most customer-centric company? 3. Value match. Do they mention specific leadership principles or cultural values that resonate with them? 4. Long-term commitment. Do they see a 3 to 5 year growth path within our specific ecosystem? 5. Clarity of intent. Can they explain why now is the right time for them to join this specific team? Strong candidates prove they aren't just looking for a job, they are looking for this job.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer around a specific architectural obsession that matches the company's unique scale. Situation. Throughout my career in distributed systems, I have been obsessed with the consistency versus availability trade-off in global-scale retail environments. Task. I wanted to move to a company where these theoretical trade-offs are a daily production reality, and where the cost of latency is measured in millions of dollars. Action. I have followed your engineering blog for years, specifically your recent shift towards cell-based architecture to isolate regional failures. In my current role, I implemented a micro version of this, but I reached the ceiling of my environment scale. I want to join this team specifically to contribute to the next generation of your global checkout mesh and learn how you manage state synchronization across 20+ regions. Result. My intent is to apply my experience in multi-master replication to your specific problem of global inventory drift, which I know is a major focus for your engineering org this year. Learning plus L. I realize that my personal growth is tied to scope of impact. By joining a company that operates at this tier, I am committing to a higher level of operational rigor and architectural accountability that I simply cannot find anywhere else. The plus L, learning, shows you view the company as a catalyst for your professional evolution.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite alignment and research. 1. Technical curiosity matched. You mentioned specific concepts from their engineering blog like cell-based architecture. 2. Mission alignment matched. You tied your passion for consistency versus availability directly to their global checkout mission. 3. Value match matched. You explicitly sought out their scale and operational rigor, which maps to high engineering standards. 4. Long-term commitment matched. You identified a specific 3 to 5 year problem space, global inventory drift, you want to own. 5. Clarity of intent matched. You explained why your current role's ceiling makes this company the logical next step. This demonstrates that you are a highly informed candidate who will be productive from day one.
Follow-up 1, clarification probe. You mentioned our cell-based architecture blog post. What specific part of that design did you find most applicable to your current experience?
Answer. The concept of shuffle sharding within the cells. In my current project, we struggled with a poison pill request taking down our entire cluster. Your post explained how sharding the request path into isolated virtual cells limits the blast radius to only 1% of users. I realized that implementing that level of isolation is the only way to achieve 99.999% uptime, and I want to help build that at your scale.
Follow-up 2, Level 3 or Level 4 junior depth. Beyond the tech, what is one non-technical thing about our culture that attracted you here?
Answer. The writing culture. I have seen that your architects value 6-page narrative documents over PowerPoint slides. As someone who believes that the process of writing forces clearer architectural thinking and better cross-team alignment, that cultural preference for logic over visuals is a perfect fit for my working style.
Follow-up 3, Level 5 or Level 6 senior depth. We are a high-pressure environment with very high expectations. How do we know you will not get culture shock and leave after 6 months once you see the intensity of our on-call rotations?
Answer: I do not view on-call as a burden. I view it as architecture feedback. My current on-call rotation is what taught me the rust pointer safety and kernel-level skills I mentioned earlier. I am looking for your intensity because it is the fastest way to find the flaws in a design. I thrive in environments where high pressure is the forcing function for operational excellence.
Follow-up 4, curveball. If we offered you the same salary and title at our biggest competitor tomorrow, why would you still choose us?
Answer: because of the problem set. Your competitor is focusing on competitor strategy, but you are focusing on company's unique strategy. I am more interested in the technical debt and scale challenges you are facing here. The salary is a baseline. The architectural problems I get to wake up and solve every morning are the real differentiator.
Leadership pro tip: research is respect.
Junior candidates think an interview is about them. Senior architects know an interview is about the union of the candidate and the company. When you show that you have read their white papers, know their outage history, and understand their business constraints, you are showing the highest form of professional respect. It proves you are already invested in their success. Question 102. What makes you different from other candidates? Note: interviewers use this question to evaluate your unique value proposition, up, and your self-awareness of your superpowers. At the senior level, they are not looking for a generalist. They are looking for a specialist who brings a specific missing piece to the engineering organization, such as deep forensics, financial logic, or organizational scale.
Here are the critical red flags, the instant rejection signals.
Interviewers watch for arrogance or generic answers that show a lack of niche awareness. Avoid these traps. 1. The "I'm a hard worker" cliché. Every candidate at this level works hard. This is not a differentiator. 2. The arrogant expert, claiming you are the best at a language or framework without being able to discuss the flaws or limitations of that technology. 3. Attacking other candidates, putting others down to make yourself look better. This signals a toxic teammate. 4. Generic skill list listing a string of buzzwords: Kubernetes, AI, Rust, instead of a unique mental model or strategy. 5. Lack of business mapping, failing to explain how your unique skill actually makes the company more money or reduces their risk.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 UVP signals. 1. Niche mastery. Does the candidate possess a deep, rare skill, for example, formal verification, kernel-level networking? 2. Force multiplier. Will their presence elevate the skills of the 10 engineers around them? 3. Architectural scars. Do they bring lessons from failure that the current team does not have yet? 4. T-shaped profile. Are they a deep expert in one area with a broad understanding of the business context? 5. Self-awareness. Do they know exactly where they fit in the engineering value chain? Strong candidates prove they are the specific solution to a specific problem.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer around your interdisciplinary edge. Situation: most architects I have worked with focus purely on technical elegance. My differentiator is that I treat architecture as a financial and operational constraint. Task: I do not just ask will it scale. I ask what is the cost per transaction, and what is the on-call cognitive load. Action: for example, in my last role, I blocked a technically superior active-active design because I proved that the complexity tax on our junior engineers would increase our MTTR by 40%. I instead designed a warm standby system that achieved the same 99.99% SLA, but was 3 times easier for the team to operate during an incident. Result: this pragmatism saved the company $200,000 in operational toil and allowed us to maintain high reliability with a smaller, leaner team. Learning plus L. I learned that the best candidate is not the one with the most knowledge. It is the one with the best judgment on when to use that knowledge. I bring this business-first engineering lens to every design review I lead. The plus L, learning, proves that your judgment is your primary architectural product.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates your unique architectural signature. 1. Niche mastery matched. You demonstrated financial and operational pragmatism as your core specialization. 2. Force multiplier matched. You protected the team from complexity tax, making everyone more productive. 3. Architectural scars matched. You showed you have learned to value easy to operate over intellectually elegant. 4. T-shaped profile matched. You balanced the 99.99% SLA tech with the $200,000 saving business. 5. Self-awareness matched. You explicitly named your UVP as judgment over knowledge. This demonstrates that you are a senior leader who manages the bottom line, not just the code.
Follow-up 1. Clarification probe. If you prioritize ease of operation so highly, are you worried that you might miss out on cutting-edge innovations that require high complexity to succeed?
Answer: I view innovation and complexity as a budget. I am happy to spend that budget on our core competitive advantage, the 20% of the system that makes us unique. For the other 80%, the plumbing, I am ruthlessly simple. I am different because I know exactly when to be innovative and when to be boring. That balance is what ensures long-term velocity.
Follow-up 2. Level 3 or Level 4 junior depth. How do you teach this business-first mindset to the junior engineers who only want to work with the newest, most complex tools?
Answer: I use the opportunity cost framework. When a junior wants to use a complex tool, I ask them, if we spend 2 weeks setting this up, what feature are we not building for the customer? I show them the cost of maintenance on our previous projects. Once they see that simple code gives them more time to build cool features, they naturally move toward pragmatism.
Follow-up 3. Level 5 or Level 6 senior depth. What is the most controversial architectural opinion you hold that makes you different from your peers?
Answer: my most controversial opinion is that consistency is almost always more important than availability for enterprise data. Many architects are taught availability at all costs. I have seen more businesses ruined by silent data corruption than by 15 minutes of downtime. I am different because I will fight for a hard fail over a silent drift every single time. It is a safer bet for the business.
Follow-up 4. Curveball. We have 5 other candidates who are technically equal to you. Give me one human reason why I should pick you over them for this specific team.
Answer: I am the candidate who will tell you when you are about to make an expensive mistake. In an environment of high stakes and fast growth, you do not just need expertise, you need calibration. I bring the architectural scars and the professional maturity to say no to a bad idea, even if it is the popular one. I am the insurance policy for your high-stakes technical roadmap.
Leadership pro tip: be a complement, not a copy.
Junior engineers try to prove they are the same as the existing team, safe. Senior architects try to prove they are the complement to the existing team, valuable. If the team is already fast but messy, be the reliability and governance expert. If the team is slow and bureaucratic, be the pragmatic and velocity expert. Identify the team's systemic gap and present yourself as the perfect patch for that gap. Question 103. Tell me about a career decision you are proud of. Note: interviewers use this question to evaluate your strategic alignment and your ability to prioritize long-term business health over short-term career optics. At companies like Google and Meta, senior engineers are expected to make decisions that provide the highest leverage for the organization, even if they aren't the most glamorous or visible choices.
Here are the critical red flags, the instant rejection signals.
Interviewers watch for candidates who confuse individual success with leadership impact. Avoid these traps. 1. The solo achievement, focusing on a purely technical win. For example, I learned a new language, that had zero organizational impact. 2. The self-promoting decision, describing a decision that was clearly designed to get you a promotion rather than to help the business. 3. Lack of risk, choosing a safe or obvious decision that required no courage, trade-off analysis, or strategic foresight. 4. Missing rationale, failing to explain the why behind the decision, specifically the business constraints and alternative paths you rejected. 5. The tool-first focus, bragging about choosing a specific technology without explaining how that choice solved a systemic problem.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 strategic signals. 1. Business alignment. Did the candidate's proudest moment directly solve a P0 company priority? 2. Courageous dissent. Did the decision involve pushing back on a popular but risky path? 3. Total cost of ownership. Did they prioritize maintainability and operational safety over technical flash? 4. Leverage. Did the decision elevate the productivity of the 50 engineers around them? 5. Maturity. Did they show the wisdom to choose a boring solution when it was the right one? Strong candidates prove that their pride is rooted in the value they created for others.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer around a strategic pivot that protected the system's long-term health. Situation. Our organization was rushing to launch a high-profile AI-driven personalization engine. I was the lead architect. The project was the CEO's top priority, but our underlying data pipeline was still running on legacy, unobservable bash scripts. Task. I was proud of the decision to halt the AI launch for 4 weeks to perform a mandatory foundational modernization of our data ingestion layer. Action. I knew this would be unpopular. I did not just ask for a delay. I wrote a stability ROI document. I proved that launching AI on a dark data pipeline would cause 40% more customer-facing incidents. I negotiated with the product VP to move the AI launch to Q2 and spent Q1 building an observable, schema-validated event bus using Kafka and Protobuf. Result: the foundational work reduced our incident rate by 70%. When the AI engine finally launched, it was 4 times more accurate because it was consuming clean, validated data. The CEO cited our data rigor as the reason for the project's success in the annual review. Learning plus L. I learned that the invisible work is often the most valuable. I now use a foundation-first checklist for all high-stakes initiatives to ensure we aren't building skyscrapers on sand. The plus L, learning, shows you turned a difficult pushback into a repeatable organizational safety gate.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite architectural leadership. 1. Business alignment matched. You tied the delay directly to accuracy in customer incidents, which are business metrics. 2. Courageous dissent matched. You had the backbone to halt a CEO priority project because you saw the hidden technical risk. 3. Total cost of ownership matched. You recognized that the invisible work Kafka or Protobuf was the real long-term asset. 4. Leverage matched. By building a schema-validated event bus, you improved the data quality for every other team in the org. 5. Maturity matched. You chose data foundations over the glamour of an immediate AI launch. This demonstrates that you are a principal-level leader who protects the company's future.
Follow-up 1. Clarification probe. During those 4 weeks of modernization, how did you keep the executive team from losing faith in the engineering department's velocity?
Answer: I used radical transparency. I set up a weekly infrastructure progress demo specifically for non-technical stakeholders. Instead of showing them code, I showed them the new data quality dashboards. I made the invisible work visible by showing exactly how many corrupt records our new pipeline was catching before they hit the AI model. When they saw the garbage being filtered out, they became the strongest supporters of the delay.
Follow-up 2. Level 3 or Level 4 junior depth. Technically, why was the legacy bash script pipeline a risk for an AI model specifically?
Answer: AI models are extremely sensitive to distribution shift and data corruption. Bash scripts lack type safety and schema enforcement. If a source system changed a date format, the bash script would pass it through as a string, and the AI model would begin generating hallucinations based on that bad data. By moving to Protobuf, we enforced a contract at the source. If the data did not match the schema, it was rejected at the gate, ensuring the model's training set remained pure.
Follow-up 3. Level 5 or Level 6 senior depth. A 4-week delay is a heavy cost. Looking back, was there a way to build the foundations while launching the AI rather than halting everything?
Answer: we evaluated that parallel path. The risk was decision branching. If we launched AI on the old data, we would have to maintain 2 versions of the model, one for the old dirty data and one for the new clean data. This would have doubled our maintenance toil indefinitely. I chose the hard halt to ensure we had a single, clean source of truth, which actually saved us more time in the long run. Senior leadership is about choosing the fastest path to stability, not just the fastest path to start.
Follow-up 4. Curveball. What if, after the 4-week delay, the AI engine still failed to deliver the expected business results? Would you still be proud of the decision to delay?
Answer: yes. Even if the AI project failed, the infrastructure we built, the Kafka or Protobuf pipeline, was a zero-loss asset. It was immediately repurposed to power our real-time analytics and our fraud detection systems. By making a foundational investment, I ensured that even if a specific feature failed, the platform became significantly stronger. As an architect, I am proud of decisions that create reusable value, regardless of the individual project outcome.
Leadership pro tip: pride follows purpose.
Junior engineers are proud of what they built. Senior architects are proud of what they prevented. In an interview, the best career decision is often the one where you stopped a disaster, simplified a mess, or built a paved road that others used to win. Show that your pride is linked to the company's integrity and the team's long-term velocity. Question 104. Who was the most difficult person you have worked with, and how did you handle it? Note: interviewers use this question to evaluate your emotional intelligence, de-escalation skills, and your ability to separate professional technical disagreements from personal friction. At companies like Amazon and Netflix, they are looking for candidates who can manage brilliant jerks and turn toxic friction into architectural alignment.
Here are the critical red flags, the instant rejection signals.
Interviewers watch for candidates who are petty, gossipy, or emotionally reactive. Avoid these traps. 1. The character assassination, focusing on the other person's personality flaws. For example, they were lazy, they were arrogant, rather than their professional behavior. 2. The avoidance strategy, saying you just stopped talking to them or worked around them. This proves you cannot manage complex interpersonal dynamics. 3. The I won narrative, describing a situation where you defeated the other person or made them look bad to leadership. 4. The manager fix, claiming the only way the issue was resolved was by having a manager tell the other person to stop. This shows zero peer influence. 5. Lack of empathy, failing to describe the why behind the other person's behavior, for example, their specific stress, fear, or technical bias.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 EQ signals. 1. Objective framing, did the candidate describe the difficulty as a process or technical misalignment rather than a personal one? 2. De-escalation, did they move the conflict out of public channels, PR, Slack, into a high-bandwidth private medium? 3. Upward empathy, did they try to understand the pressure or goal that was making the other person difficult? 4. Systems thinking, did they implement an architectural or process fix to solve the human friction permanently? 5. Professional maturity, did the relationship eventually reach a state of mutual technical respect? Strong candidates prove they fix the communication protocol between people, not the people themselves.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer around managing an architectural gatekeeper through process and artifacts. Situation: I was the new tech lead for a service mesh migration. One of our most senior infrastructure engineers was being extremely difficult. He was rejecting every PR with vague, highly pedantic comments about system conventions that were never documented, blocking 4 different teams. Task: I needed to stop the PR deadlock and restore team velocity without creating a toxic war with a key technical stakeholder. Action: I took it offline. I requested a 15-minute sync and asked, I see your quality concerns. Can you help me understand the specific production risk you are trying to prevent? I realized his difficulty was actually fear. He had survived 3 massive outages and was using pedantry to protect the system. I proposed a contract-first solution. We spent 3 days co-authoring a formal infrastructure RFC and an automated linter that codified his exact standards into the CI pipeline. Result: the difficulty vanished because the friction was moved from a human argument to an automated test. The PR emerge time dropped by 50%, and that engineer eventually became my strongest advocate on the architecture board. Learning +L. I learned that difficult people are often unheard experts. I subsequently implemented an RFC culture for all shared repos, ensuring that standards are debated in a document, not in a code review. The +L, learning, shows you used a difficult interaction to drive a global engineering standard.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite professional maturity. 1. Objective framing matched. You identified the problem as undocumented conventions causing a PR deadlock, not as a personality clash. 2. De-escalation matched. You moved the argument out of PR comments and into a private, goal-oriented sync. 3. Upward empathy matched. You correctly identified that his behavior was a reaction to production trauma and a desire for quality. 4. Systems thinking matched. You built an automated linter to remove the human friction from the code review process. 5. Professional maturity matched. You turned a blocker into an advocate by respecting his expertise and codifying it. This demonstrates that you handle people with the same logic you use to handle code by fixing the protocol.
Follow-up 1 clarification probe. When you say you codified his standards, did you agree with every pedantic rule he wanted? Or did you push back on some?
Answer: I used the data of utility filter. For rules that were purely subjective, like naming styles, I conceded and automated them. They were not worth the fight. For rules that I believed actually slowed down system performance, I brought benchmarks. By automating the boring rules he cared about, I gained the trust required to win the high-stakes architectural arguments using data. You have to pick your battles to win the war.
Follow-up 2 Level 3 or Level 4 Junior Depth. How did the other 4 teams react when you implemented this new automated linter and RFC process?
Answer: they were relieved. Before, they felt like they were throwing code into a black box and hoping for the best. With the linter, they got immediate feedback on their local machines before they even pushed. It replaced social anxiety with technical feedback. Visibility is the best cure for team friction.
Follow-up 3 Level 5 or Level 6 Senior Depth. Some might say that by automating his pedantic rules, you were enabling a difficult personality instead of fixing it. Why not just tell him to stop being pedantic?
Answer: telling a senior engineer to stop caring about quality never works and only creates a more toxic relationship. My role as a leader is to channel that person's energy into a systemic asset. By turning his pedantry into a linter, I leveraged his high standards for the entire company while removing his ability to block individual engineers. I fixed the behavior by fixing the medium through which he expressed it.
Follow-up 4 Curveball. What if, after the linter was built, he found a new way to be difficult, like ignoring the linter and still blocking PRs for reasons he could not explain? What then?
Answer: at that point, it transitions from a process gap to a performance violation. I would formally document the specific instances where he violated the agreed-upon RFC and linter standard. I would have one final direct conversation. We agreed on the automated standard to unblock the team. Your current actions are violating that alignment. If the behavior continued, I would immediately escalate to his manager with the evidence of the impact on our velocity. You protect the team's culture, even if it means losing a high performer.
Leadership pro tip: code fixes code, process fixes people.
Junior managers try to change people's personalities through coaching. Senior architects try to fix the protocol through which people interact. If you can move a conflict into an RFC, a design doc, or an automated test, you have removed the emotion from the equation. High-performing teams are those where the technical truth is easier to find than the manager's approval.
Category 13 Wrap-up: self-awareness as a technical asset.
You have completed the final category of the behavioral loop. You have proven that a senior architect is not just a master of distributed systems, but a master of their own professional psychology. By demonstrating that you understand your own motivations, acknowledge your weaknesses, and actively engineer your own growth, you have shown the highest form of technical debt management, the ability to self-correct.
Part 2 Wrap-up: navigating the dark side of engineering.
In Part 2 of this masterclass, we tackled the most grueling dimensions of the FAANG interview: failure, ambiguity, extreme pressure, and ethical integrity. You have learned how to defend a catastrophic outage, how to pivot when data is missing, and how to speak truth to power. If you have mastered these 51 scenarios, you are no longer just an individual contributor. You are a resilient engineering leader.
The conclusion: the 100-plus question behavioral masterclass.
You have just completed one of the most comprehensive behavioral interview series ever produced. We have deconstructed over 100 scenarios, mapped them to the core scoring signals of companies like Google, Meta, and Amazon, and introduced the STAR+L framework to ensure your answers hit the senior bar every single time.
Your final roadmap to success.
To ensure you walk into your next interview with absolute confidence, follow these 3 final steps. 1. Review Part 1. If you started with this video, you must go back and master the execution and influence round. Part 1 covers leadership, teamwork, and impact. The link is at the top of the description. 2. Refine your stories. Do not memorize our answers word for word. Use them as blueprints to rebuild your own 6 to 8 master stories using the STAR+L structure. 3. Practice the interrogation. Have a peer hit you with the curveball and depth follow-ups we covered. Your ability to defend your decisions under pressure is where the offer is won. Senior architects do not just tell stories. They defend their technical and organizational judgment.
Final thoughts. Move from answering to leading.
Most candidates view the behavioral round as a barrier to overcome. Elite architects view it as an opportunity to set the technical direction of the team. When you speak about failure, ownership, and ethics with the depth we have practiced today, you stop being a candidate and you start being a consultant. You are no longer asking for a job. You are offering a solution to the company's most complex technical and human problems. Subscribe to ACE interviews for the next level of system design and architecture. The full list of Part 1 and Part 2 scenarios is available in the description. Go lead. Go build. Good luck.
Check the comments section or description of this video. I have given a link to download a magical bundle that teaches you to develop Google caliber thinking and provides a complete mental model in a way that screams Google SRE. This bundle is the only end-to-end system that teaches you to think, act, and communicate like a Google SRE before you even set foot in the interview. It is the only structured playbook for Google's impossible rounds like NALS and troubleshooting. Most candidates sound like outsiders. The magic of this bundle makes you sound like you already work at Google. Cracking the Google SRE interview is one of the toughest challenges in tech. Most resources only prepare you for parts of the process, a few coding problems here, some system design notes there. But Google's SRE loop is multidimensional. It tests how you think, act, and communicate. Imagine preparing with scattered LeetCode problems, random design blog posts, and still wondering how to survive the NALS round. That's how most candidates prep, fragmented, incomplete, and unstructured.
Now, imagine having one complete system.
Imagine instead you had one system that gave you everything.
A system that gives you
1. End-to-end coverage of every single round. 2. Playbooks that turn chaos like NALS and troubleshooting into structure. 3. Realistic practice drills that simulate the actual interview loop. 4. Insider language and frameworks that make you sound like you already belong. That's what this bundle does. It's not just prep material, it's a game changer because it transforms the way you think, act, and communicate into the exact style Google interviewers are looking for.
The Google SRE interview bundle covers
1. Recruiter screen and resume prep, tailored templates and scripts that pass the first filter. 2. Coding rounds, Python and Go question and answers designed for SRE-style reliability tasks. 3. System design and NALS, playbooks for both high-level design and Google's infamous NALS round. 4. Troubleshooting and debugging, a step-by-step handbook to master war-room-style scenarios. 5. Behavioral and Googleness, real reliability scenarios that make you sound like you already work at Google. 6. Post-interview and hiring committee, an insider breakdown of how decisions are made. 7. Salary negotiation, recruiter-proof scripts and strategies to maximize your offer confidently. If LeetCode is practice mode, this bundle is the real game simulation. It doesn't just prepare you for questions. It prepares you to think, act, and communicate like a Google SRE before you even set foot in the interview.
For more exciting tips, tricks and more importantly, for valuable insights of interviews, please share, like, and subscribe to my channel. It has a lot of valuable information about various insights of interviews. It has a wide range of real-world portfolio projects of various technologies for interviews, and it has wide range of most asked interview questions and answers of various technologies like data science, SAP, AWS, DevOps, and full-stack web development and more. That will be useful during interviews. It has a wide range of most asked interview questions and answers and real-world portfolio projects of various technologies for freshers. For 2 to 3 years, experienced candidates, and for 5 or above years, experienced candidates to test their skills by knowing most asked interview questions and make themselves ready for interviews.